All right, let's take a look at the practice test. For the instructions, we're asked to find the amplitude, the period, and the phase shift in radians. We also want to find the vertical shift and then sketch the graph. All right, before we jump in and look at any problems, I want to give you a brief recap of what we talked about in the lesson. I'll also show you a problem that's not on the practice test, just so you can get a little bit of a refresher before you start going into this topic. All you really need to do is follow the procedure I give you. It's very, very easy if you do that. So we have something like f of x, or you could say y is equal to a. So a here would not be 0. It could be some positive number or some negative number, but not 0, times the sine of. So this right here would be your argument for the sine function. So it's b times the quantity x minus c. We're going to see that writing it in factored form is going to make it a lot easier to get all the information we need. Then we have plus d. Now, I told you that a is not going to be 0. I'm going to specifically list here that b is greater than 0, and that's just going to simplify the problem. You can have examples where b is negative, but in that particular case, you can use identities that we're going to talk about in the next section to rewrite it to where b is positive. You can also just adjust this formula for the period. So instead of 2 pi over b, you can just go 2 pi over the absolute value of b. So that's all you really need to do if you get something where b is less than 0. So we have the amplitude. It's just the absolute value of this guy a right here. We have the period, which is going to be 2 pi over b, as long as b is greater than 0. We have a phase shift of c. Now, this is the one that gives students the most trouble. So basically, in the factored form, it becomes very easy to see what's going on. Let's say you had something like y is equal to, let's go the sine of, and I'm just going to make something up. So let's just say it's x minus 2, like this. So compared to y equals the sine of x, what's happening is, to get the same y value, the x value has to be 2 units larger. You always have to think about what you need to do to undo what's being done to x. Here you have minus 2, so to undo that, you have to add 2 or shift to the right by 2 units. That's what's happening. So the same y value is occurring when the x value is 2 units larger. So this right here is a shift to the right. So shifts right by 2 units. And you'll see here we say right c units if c is greater than 0. So minus 2. 2 is greater than 0. If it's a minus 2, you're shifting to the right by 2 units. Then this one is the one that confuses people. So left by the absolute value of c units if c is less than 0. Okay, so let's say that we had a plus here. You would know that it shifts left by 2 units. But why does it have this left by the absolute value of c units if c is less than 0? Here, c is still 2. So it's not less than 0. The reason is you're following this formula where you have a minus baked in. You have to go minus a negative. So that's what they're referring to if you see this in your book and you're a little bit confused. So if you see something written that way, it's just going to shift left by the absolute value of negative 2 units. So it's shifting to the left by 2 units. That's all it is. And let's look at the last part. So the vertical shift, that's really simple to understand. Basically, that's going to be d. So that's going to be up d units if d is positive, and down by the absolute value of d units if d is negative. And obviously, if d is 0, then there's no vertical shift. Okay, before I read through the procedure, let me address one common question. We talked about this in the lesson, but sometimes people do get confused or they forget. Basically, people ask, where does the period come from? So how do you know it's 2 pi over b, or in the case where b is negative, 2 pi over the absolute value of b? Well, essentially what you're doing is, if you go back up, you have this argument, which is b times the quantity x minus c. So coming down, you have b times the quantity x minus c. So normally, if you just have something like y equals the sine of x, you know that the period is 2 pi. That's just the standard period for sine or cosine. So basically, if you have your x there, which is the argument, you would say it goes through one cycle from 0 to 2 pi. So now the argument changes, so you're just going to solve this inequality. So that's where we get this from. If you just divide both sides by b to kick things off, like this will cancel. 0 over b is going to be 0. Remember, we said that b was a positive number. And then we're going to say this is less than or equal to. Now you have x minus c, which is less than or equal to. Now you have your 2 pi over p. So what we're going to do at this point is add c to each part. So add c to each part. Let me slide down here a little bit. This cancels. So now you have x is greater than or equal to. This is c. And then less than or equal to 2 pi over b plus c. So this is your cycle here. And what you can say is that the start of the cycle would be at c. So this right here is where it starts. And then this right here, this 2 pi over b plus c, that's the end. So basically, if you get lost on the phase shift or something like this, you can actually solve this inequality and you can figure out your phase shift that way. You can also figure out your period that way or use it to check. Now, to get your period, you just take your ending minus your beginning, or your ending minus your start. So basically, you do 2 pi over b plus c minus c, and that gives you 2 pi over b. So that right there is where that period is coming from. With that being said, let's go ahead and look at the little procedure. I'm going to modify this in certain places. This comes straight from a textbook. There are some things that are just very, very tedious that you want to avoid. So the first thing is identify the amplitude and period. So we know how to do that. It's very simple. Then you want to find the values of x for the 5 key points. So the min, max, and x-intercepts. So this is very, very easy to do. You're going to start with the x value where the cycle begins, and then you're going to add quarter periods, or the period divided by 4, to each previous x value. And then this is where I'm going to change things up a little bit. It says find the values for y by evaluating the function for the values of x in the last step. You can do it that way, and you might want to do it that way to check, to make sure you're not doing something incorrectly, but it's a lot faster if you just use the graphing transformations there, where you think about, well, what's being done to the y coordinate based on the function you're given. Then it says connect the 5 key points with a smooth curve to graph one cycle of the sine or cosine function. And then lastly, this is optional. A lot of teachers will just tell you to graph one cycle, so you can probably just stop. But some of them will want you to extend it a little bit. So just extend the graph left to right as much as needed. So that's based on your teacher. If you're self-studying, I would just do one cycle just to prove that you can do it, and then you can just look on Desmos and compare your graph to what they give you. Okay, let's look at the basic sine function real quick and just refresh our memory on what it looks like. So basically, you have 3 x-intercepts. At an x-intercept, the y-coordinate is always 0. So this x-intercept right here, this is 0, 0. This one right here is pi, 0, and this is 2 pi, 0. So this is at the beginning, the middle, and the end. Then you have the maximum, that's a quarter of the way through. That's going to be at pi over 2, 1. And then you have the minimum, that's going to be 3/4 of the way through. And that's going to be at 3 pi over 2, -1. So if you look at this basic graph right here, again, you know the period is 2 pi. The amplitude, which again is half the difference between the maximum and minimum values. So it's just describing this right here, if you want to look at it. So the horizontal line that passes through what we call the middle of that graph, what is the height above and also below that horizontal line? So if you look at this, this would be 0 in terms of the y value, and this would be 1, so the amplitude is 1. Again, if you look at y equals the sine of x, you could put a 1 out there. The amplitude would be the absolute value of 1, which is 1. Okay, before we look at the first problem, let me just give you an example just to go through some of the things that we talked about with the formulas involved, and then we'll jump into the practice test. So this right here is the graph of f of x equals 4 times your sine of the quantity x over 3 minus 2 pi over 3 and then plus 2. So this right here, if you look at the graph, is going to be one cycle. So this right here is one cycle of the graph. So your goal when you're in the section is to figure out, how do I get these 5 key points? So this guy right here, this guy right here, this guy right here, here, and then here. And then again, you can just make your smooth curve, and then you can continue it to the right or to the left, depending on what your teacher wants. So let me just copy this real quick. We have f of x is equal to 4, and then times your sine of, I'm going to put this in factored form now. So what I'm going to do is pull out a 1/3. So you can have a 1/3 out in front, and this is times the quantity. You have your x, and then minus, this would be 2 pi. Again, if you're factoring and getting a little bit lost, you can always check it with multiplication. 1/3 times x is 1/3 x, or x over 3. And then 1/3 times negative 2 pi is negative 2 pi over 3. Then we have our plus 2. And I'm going to come down here and paste this in. I'll just go back and forth to the graph if I want to make a connection with something. The first thing is your amplitude. So this is your amplitude. And we're thinking about this as this guy right here. You want the absolute value of it. So the absolute value of 4 would be 4. Now, when we think about this, let's go back up. You'll notice that at the max value, you have a y-coordinate of 6. So that's a 6 there. And at the minimum value, you have a y-coordinate that is -2. So does it make sense for this to be 4 for the amplitude? Yes, because this is what you're describing. You are describing this height right here, which would be 4. If you do 6 minus 2, that's 4. If you do 2 minus a -2, that's 2 plus 2, that's 4 as well. So you can do it like this if you want. So that's what your amplitude is describing. It's basically the height of the graph, both above and below that horizontal line that passes through the middle of the graph. Normally, that line is the x-axis, or y equals 0, but because you have this +2 here, it got shifted up, so now that line is y equals 2. So again, you can see this is 4 and this is 4, so it does make sense that the amplitude here is 4. Now let's talk about the period. So the period, again, I showed you the long way to do it, where you set up an inequality. We're not going to do that. We're just going to use the formula. But if you get stuck, you can always do it that way. So what I'm going to do is just say that it's 2 pi over, this is your b right here. So it's out in front of these parentheses. Again, I'm always going to be factoring this in my examples. If you didn't factor it, well, then it's just the coefficient of x. So here it's just 1/3. And basically, you're going to say that this is 2 pi over 1 times the reciprocal of this, which is 3 over 1, which equals 6 pi. So that is your period. Let me erase this and just put that this is 6 pi. And then from here, you want to figure out your phase shift. So your phase shift. And again, you're just looking at this part right here. How do I undo what's being done to x there? I'm subtracting away 2 pi. So I've got to add 2 pi to undo that. So that's giving me a shift to the right by 2 pi units. So shift to the right by 2 pi. Don't forget the pi in this example because that's there. Then the last thing here would be the vertical shift. So we want to know what is the vertical shift. And that one's extremely easy. It's just this right here, which is +2, which means we're going up by 2 units. So up by 2 units. Now, we should know that this right here, this 4 on the outside, is giving me a vertical stretch by a factor of 4. This 2 right here is shifting me up by 2 units. So if we look at the graph, you have this point right here, which on the normal sine graph would occur at pi over 2, comma 1. You see that the y-coordinate is now 6, and that's because that 1 for the y value got multiplied by 4, so that gives you a 4, and then you got to add 2 to shift up. So now the y value is 6. This minimum that was -1, it got multiplied by 4, that's -4. Then you add 2 to that to shift up by 2 units, that's going to be -2. That's why you're getting a y value at the maximum of 6 and a y value at the minimum of -2. The more confusing part when you think about graphing transformations is always what's happening on the inside. So I want to talk about this 1/3 here. Remember that that is actually going to give me a horizontal stretch by a factor of 3. And you can see that from the period. The normal period for sine or cosine is 2 pi. Well, now it's 6 pi. Well, basically it's taking 3 times as long to go through one cycle. We're going to get our x coordinates here and here in a moment. But basically when you see this, you're going to see that from right here to right here, that's going to be 6 pi. So I've stretched the graph horizontally by a factor of 3. I have also shifted the starting point of the cycle from this 0 right here to this guy right here, which is going to end up being 2 pi. So this right here, let me just arrow to that. The point there would be 2 pi. Again, we know because of the phase shift, this got shifted 2 pi units to the right. And then comma 2, we know that's going to be the y value. So that's the starting point. Now let me come down here and let me get some points going here. So let me copy this and paste this in. We need a lot of room for this. Let me erase this and this and this. When you look at your book, they're going to tell you that the procedure is start off with that point that we just got, which was 2 pi. Again, this 2 pi I got from the phase shift. So normally it's at 0 where it starts with the x value. I'm shifting 2 pi units to the right. So now it would be 2 pi where it starts. And then basically comma, we know this is going to be 2. Okay, so once we have that, you could add quarter periods and then basically plug in each time to get the y value. But I'm going to tell you that's going to be really, really slow. So what I like to do for that, let me just scooch this down, is I like to consider when you think about graphing transformations, this is done first in terms of vertical, and then this is done second. So all you have to do, if you start off with your basic points, so 0, 0, then you have pi over 2, 1, and then you have your pi, 0, and then you have your 3 pi over 2, -1. Let me slide down a little bit so this all fits. And then lastly, you have 2 pi, 0. Well, again, all you really have to do instead of plugging in and taking all that time, just take this guy right here, multiply by 4 first, then add 2. So 1 times 4 is 4, 4 plus 2 is 6. We already saw that was on the graph. Then basically, this right here is going to be a 2. And then this right here, we would have -1 times 4, that's -4, plus 2, that's negative 2. Again, we saw that on the graph. And then this guy right here, we know this is going to be a 2. That's how I get my y values. I think it's just much faster and easier. If you want to plug in, feel free to do so. Let me scooch this over so it all fits on the screen properly. And grab this and move this over here. Now, in terms of the x values, you can do it by adding quarter periods, or you can use graphing transformations. Because people usually get confused about the graphing transformations on the inside, I would just say stay away from that and just go with the quarter periods. You will get the same answer, but you have to go in the correct order. So in factored form, and I want to repeat that, in factored form. So if you're not paying close attention, pay attention to what I'm saying now. In factored form, this guy right here is 1, and then the shift is 2. So in other words, if you start with this and you go, well, pi over 2, you would do this first. Now it's not times 1/3. The horizontal stretching there is a factor of 3. Remember, I have to undo what's being done to x. So to undo multiplying by 1/3, I've got to multiply by 3. So basically, you would multiply pi over 2 by 3. That would give you 3 pi over 2. And then you would do your shift. So then you would add 2 pi. So you add 4 pi over 2. And that would give you 7 pi over 2. That's one way you can do it. I know a lot of you will be confused by that, and I know that it's very easy to make a mistake with this part right here, so I would say just avoid that and just add quarter periods. So here you know the period is 6 pi, divide that by 4, and then basically that's going to give you 3 pi over 2. So if you say that I'm going to start with this of 2 pi, so let me write here quarter periods is going to be 3 pi over 2. So if you start with 2 pi, and you add 3 pi over 2, well, again, you can write this as 4 pi over 2. And this gives you 7 pi over 2. So you can do it that way. I think it's much easier to do it that way. Again, when you try to involve the graphing transformations there, a lot of students do find that troubling. And so you just want to stay away from methods that are error prone. So let me get rid of this. And we're just going to keep adding 3 pi over 2. So 7 pi over 2 plus 3 pi over 2, that's 10 pi over 2. I'm going to simplify that in a moment. 10 pi over 2 plus 3 pi over 2, that's 13 pi over 2. And then 13 pi over 2 plus 3 pi over 2, that's 16 pi over 2. So I didn't simplify it immediately because I wanted a common denominator. And so 10 pi over 2 is 5 pi. And then 16 pi over 2 is 8 pi. So if you think about subtracting 8 pi minus 2 pi, that's 6 pi, that's your period. So that's how you know you're on the right track. Okay, let me go ahead and grab this real quick. And let me paste this in. It's really hard to see. So we know this is 2 pi comma 2. This point right here would actually be 7 pi over 2 comma 6. Let me erase these as I use them. This point right here is going to be 5 pi and then comma 2. Let me get rid of this one. And then this one down here, this would be your minimum. So 13 pi over 2 comma negative 2. And let me get rid of that. And then you have 8 pi comma 2. So that's going to be right there. So this is your 8 pi comma 2. So basically that's how you can get these points right here. So once you do this a few times, it becomes very, very simple. It is a bit tedious, especially if you're trying to sketch this graph by hand. A lot of teachers will just ask you for the information now. So they'll say, well, what is the amplitude, the period, the phase shift, and the vertical shift? And maybe they'll say, describe the transformation or something like that. In this particular case, again, going in order, you would want to say that you have a vertical stretch by a factor of 4. And then you could say that you have a horizontal stretch by a factor of 3. And then a phase shift to the right by 2 pi, and then followed by a vertical shift up by 2. So that's how I would list that. Again, you got to be really careful when something's in factored form versus unfactored form. The way I'm describing that is coming from this factored form here. This is 1, and this is 2 in terms of your vertical. So you got to go in order there. This is 1, and this is 2 in terms of your horizontal. But remember, with the horizontal, everything is the opposite of what you think. You have a 1/3 there, so really you're saying you have a stretch by a factor of 3. Then you have a minus 2 pi there, so really you're saying you're shifting 2 pi units to the right. So be careful in terms of listing those graphing transformations, remembering that for things on the inside of the function, it's always the opposite of what you think. When we come back to this, once you have these points, you can just sketch your graph. So a smooth curve through these points like that. And then if you want to continue it, you can just get additional points. You could keep adding quarter periods. You know that the y values are going to be the same. So in other words, right here, let's just say about right there, I could add another quarter period. So I know that 8 pi, so let me do that here. So 8 pi plus 3 pi over 2, we could write this as 16 pi over 2. So 16 pi over 2, this would give me 19 pi over 2. So basically, to get this x value here, this would be 19 pi over 2, comma, we know the y value would be 6 because it's just coming from this y value here. Again, the cycle is just repeating. So this y value and this y value would be the same, this y value and this y value would be the same, so on and so forth. So that's how you can continue the graph either to the right or to the left, just based on what your teacher asked for. All right, now let's officially look at the first problem. So we have f of x equals the sine of 4x. Let me just come down to the graph and I'll just do everything right here. So f of x equals the sine of 4x. This one's really simple. The only change that's really being made here is I'm multiplying x by 4. Again, when you're doing something on the inside, it's always the opposite of what you think. I am not stretching horizontally by a factor of 4. How do I undo this? I've got to divide everything by 4. So really, what I'm doing is I'm taking all the x values there and I'm dividing by 4 to get those same y values. So what you see here is that the period would be a fourth of what it normally is. So usually it's 2 pi. Now it's going to be 2 pi over 4. So let me write here that the period is going to be 2 pi over 4. And of course, you can cancel this with this and put a 2 down here. So it's going to be pi over 2. So this is sped up quite a bit. Let me move this over here. And we want our amplitude. So I forgot to do that one. So basically with that, you could put a 1 out in front. So there's nothing really visible that's multiplying that guy. So you just consider that to be a 1. So it's the same amplitude from the basic sine function. So it's the absolute value of 1, which equals 1. Okay, in terms of the phase shift, you're not going to have one. So phase shift, you can just put none. And then for the vertical shift, you don't have one there. So vertical shift, this is also none. You need to get the 5 key points. So let me actually do that up here. So we have f of x is equal to the sine of 4x. So again, I like to write out my points each time. So 0, 0. Then you have pi over 2, 1. Then you have pi, 0. You have 3 pi over 2, -1. And then you have 2 pi, 0. And again, all I'm going to do is think about, well, if there's no phase shift, well, then this guy right here, this x coordinate is going to be the same here. So this starts with 0. And then for the y value here, there was no vertical transformation. So it's just going to be matched. This is going to be a 0. And actually, you can go down and just fill those in now. This would be a 1. This would be a 0. This would be a -1. And then this would be a 0. So that's really easy. In terms of these, again, you can go through and divide everything by 4. Again, because you have that 4 there that's multiplying x, how can I undo that? I'm going to divide everything by 4. So really, you can say pi over 2 divided by 4 is pi over 8. You could do it that way. Or you could add quarter periods. The period here, so the period here, again, is pi over 2. Well, a quarter period is going to be pi over 2 times a fourth, which is pi over 8. Well, pi over 8 plus 0 is pi over 8. And then you can keep doing it that way. So you can add pi over 8 plus pi over 8 and keep going, or you can take these values and just divide them by 4, whatever you want to do. This is going to end up being pi over 4. This is going to be 3 pi over 2 divided by 4, or times a fourth. That would be 3 pi over 8, and then 2 pi divided by 4. So 2 pi divided by 4, and that is going to be pi over 2. So this right here is pi over 2. So in this particular instance, it's just quicker to divide everything by 4 in terms of the x values. If you want to add quarter periods, that works the same. If you did pi over 8 plus pi over 8, you would get 2 pi over 8, which reduces to pi over 4. So that right there. And then again, if you just kept adding, so let's say you had 2 pi over 8 plus pi over 8, that's 3 pi over 8. And then if you did 3 pi over 8 plus pi over 8, you'd get 4 pi over 8, which is pi over 2. So it's the same thing either way, whichever method you want to use. Let me bring this down here, and I'll just erase things as I go. So this point right here, this would be the start of your cycle, which is 0, 0. Then you have your maximum. So that's going to be, let's say, about right there. So this would be your pi over 8, and then 1. Let me get rid of these two. I've used them. And then we have our x-intercept here, which is going to be pi over 4, 0. So that's right there. This is pi over 4, 0. And then sliding down now, you have this one right here, which is your minimum. And so that's going to be 3 pi over 8, -1. So this is 3 pi over 8 comma -1. And then to complete the cycle, we're going to end up right there. And that's going to be this guy right there, which is your pi over 2 comma 0. Again, if you want something that's going to be super detailed, what you can do is go to Desmos. And I'm actually going to give you a link for this. But basically, you'll see that I've already labeled all these points for you on Desmos. You can just go through and verify. And then you can think about, well, how can I get this guy, this guy, this guy, this guy? In other words, if I want to go to the right or to the left by, let's say, 1 or 2 more cycles, what would I need to do? So that's something you can do on your own. Okay, for problem 2, we have f of x equals 3 times the sine of x over 4. All right, so we have the f of x is equal to 3 times the sine of, let me write 1/4 x like that. I think this is a little bit easier to understand. So basically, when we start off with the amplitude, so the amplitude, well, basically it's the absolute value of this 3 here. So I can put absolute value of 3, and that's going to be 3. Let me make that a little bit better. For the period, again, this is 1/4 as the coefficient of x. So it's just 2 pi divided by that coefficient, which is 1/4. So it's 2 pi times 4, which is going to be 8 pi. So this is 8 pi. When you think about the phase shift and the vertical shift, in this case, there's not going to be one. So the phase shift, there's none. And the vertical shift, also none. We'll come up here and we'll get our key points. So again, I'm just going to write these out. You have 0, 0. You have your pi over 2, 1. You have your pi, 0. You have 3 pi over 2, -1. And then you have 2 pi, 0. All right, so thinking about what's going to happen to the y values here, again, all of them are just getting multiplied by 3. So you could plug in, but I think it's just a lot easier to do it that way. So let me go ahead and key that in now. And basically, you're going to have 3 times 0, which is 0. So it's going to be here, and then here, and then here. Then at your maximum, the y value is going to be 1 times 3 or 3. And then at your minimum, the y value is going to be -1 times 3 or -3. Now, in terms of the x values, again, very, very easy to do this. You can start off at 0 for your first x value, again, because there's no phase shift here. And then you can add quarter periods. So the period here is going to be 8 pi. So the quarter period is going to be 2 pi. It's just 8 pi divided by 4, which is 2 pi. And so basically you can just go through and say, okay, well, this is 0. This is going to go to 2 pi. Then it's going to go to 4 pi. Then it's going to go to 6 pi. Then it's going to go to 8 pi. That's all you need to do. The other way you can do this is you can think about what's happening here. Again, this is the more confusing way to do it, so I don't suggest it, but you can. And basically, you have a horizontal stretch by a factor of 4. Because you have a 1/4 that's multiplying x, to undo that, you have to multiply by 4. So in other words, what I could have done is I could have said, okay, well, 0 times 4 is 0. And then pi over 2 times 4 is going to be 2 pi. Same answer. And then pi times 4 is going to be 4 pi. Same answer. And then 3 pi over 2 times 4 is going to be 6 pi. And then 2 pi times 4 is going to be 8 pi. So if you want to do it that way, that's fine. I find it to be a little bit more confusing for most students. So I would just stick with this method here of thinking about the phase shift. Here there's none, so you just copy the first x value and then just adding quarter periods. Okay, let me come down to the graph and put this in right there. I just made these a little bit smaller so they would fit. And let me kind of put this maybe right there for right now. So basically, the cycle starts right here. So this is your 0, 0. Then you're going to go up to the maximum. So that's going to be 2 pi, 3. Then you're coming back to an x-intercept. So that's going to be at 4 pi, 0. You're coming down to a minimum. And that's going to be at 6 pi, -3. And then you're coming back up to an x-intercept. And that's going to be at 8 pi, 0. So I can erase these, and you can just have those points there. I didn't extend it too far to the left or right here, just because the graph is stretched so much. But again, you can just click that link and go to Desmos if you want to play around with these points or look at some points to the right or to the left of this guy just to extend things and get a little practice. All right, let's take a look at problem 3. So here we have f of x equals 2 times the cosine of, we have this 3x minus pi over 2. Now let me remind you, because we looked at sine already, the basic graph for y equals the cosine of x, so y equals the cosine of x, that's this guy right here. So basically it changes up a little bit. It's the graph of y equals the sine of x that's been phase shifted pi over 2 units to the left. Now, if you look at it, now what we have is a maximum at the start of the cycle and a maximum at the end of the cycle. And then you have two x-intercepts. So then basically this is at a quarter of the way and this is at 3/4 of the way. And then halfway, you're going to have your minimum. So you just need to remember these points. So let's come down here and let's think about how to write this in factored form first. So we have f of x is equal to, you have 2 times your cosine of, I'm going to pull out a 3. So this is where everybody gets a little bit confused. From the first part, it's easy. So you have a 3x there. So if I pull out a 3, I just have x and then minus. What I'm going to do here, because 3 times a third would be 1, I'm just going to put a 1/3 here and then times pi over 2. So that's all you need to do. And then if you simplify, that would give you pi over 6. But I just want to point out, before you simplify, if you were to multiply 3 times x, you have 3x, and then minus matches the minus here, and then you have 3 times 1/3 would be 1, and then times pi over 2 would be pi over 2. So this is exactly what we want. I would simplify this and say it's pi over 6. So just like that. In factored form, it's just so much easier to work with things. So now the amplitude would be the absolute value of 2. So the absolute value of 2, which is 2. For the period, it's 2 pi over this guy right here. Again, if it's factored out, it's out in front of the parentheses. If it's not, it's the coefficient of x right there. So it's 2 pi over 3. Then we have our phase shift. And basically you look inside and you have x minus pi over 6. Again, how do I undo what's being done to x? I want to add pi over 6, so that's going to the right by pi over 6 units. So I'm just going to put right by pi over 6. And then for the vertical shift, there's none. There's nothing out here. You could put plus 0 if you want, but there's no point. So I'm just going to go vertical shift, and you can just put none. Okay, let me actually copy this, and I'll just throw this on this page right here. And I'm just going to stay on this page. I think this will be a little bit quicker. And let me move this over a little bit. So with the basic points for the cosine graph, again, you start at the maximum. So you have this 0, 1. Then the next guy that you come across, you're going to have an x-intercept. So pi over 2, 0. Then you're going to go to your minimum. So that's pi, -1. Then you're going to go back to your x-intercept. So that's 3 pi over 2, 0. And then you end up back at the maximum. So now you're going to be at 2 pi and then 1. Okay, so again, if you think about this, the period here, we found that that was 2 pi over 3. If you want a quarter period, well, that's going to be 2 pi over 3. And then I'm going to go times 1/4. Cancel this with this and put a 2 down here. So basically that's pi over 6. So the quarter period is pi over 6. And remember, the phase shift is pi over 6 to the right. Let me come back up, and you can do the x ones or the y ones first. It doesn't matter. It's up to you. So basically, if my phase shift is pi over 6 units to the right, that means that instead of starting with an x value of 0, I'm going to start with an x value of pi over 6. And then forget about the y values for right now. You can add quarter periods. The quarter period is pi over 6. So pi over 6 plus pi over 6 is 2 pi over 6. So this is 2 pi over 6. I'll simplify that in a moment. 2 pi over 6 plus pi over 6 is 3 pi over 6. Again, I'll simplify these in a moment. Let me just keep going because I have a common denominator. 3 pi over 6 plus pi over 6 is 4 pi over 6. And then 4 pi over 6 plus pi over 6 is 5 pi over 6. All right, simplifying, this would be 2 divided by 2 is 1. 6 divided by 2 is 3. So this is pi over 3. Let me rewrite that. So pi over 3. And then 3 pi over 6, that's of course pi over 2. So pi over 2. 4 pi over 6, divide 4 by 2, you get 2. And 6 divided by 2 is 3. Okay, so we have the x values now. The next thing you want would be the y values. And again, all you're really doing is you're taking these and you're multiplying them by 2. So I can say that 1 times 2 is 2. So that's going to be there, and then also here. And then 0 times 2 is 0. So that's that one, and then that one. And then this one, -1 times 2, is going to be -2. So again, it's pretty easy to do this. If you want to use the transformations for the x values, again, you got to be really, really careful here. When you look at this 3 right there, again, it's not a horizontal stretch by a factor of 3. You're actually getting a horizontal compression. So what's happening is all the x values are actually divided by 3 or multiplied by 1/3, however you want to think about that. So you would want to do that first, and then basically after that, you would want to do your shift to the right by pi over 6. Let me just show you a few of these. I'll just do the first two. So starting with 0, if I multiply by 1/3, I still have 0. Then if I add pi over 6, I'm at pi over 6. That one's really easy. Then if I had pi over 2, and I multiply by 1/3, I would get pi over 6. So I would get pi over 6. Again, this is done first, this is 1, and the shift is done second. Again, in factored form. I can't say that enough. So now, once you've done that, you want to do your shift to the right by pi over 6, and it's the same thing as what we did. Pi over 6 plus pi over 6 is 2 pi over 6, and of course you can simplify that and say that 2 divided by 2 is 1, so that's pi over 6 divided by 2 is 3, so it's pi over 3 either way. So however you want to do it, I just think it's much faster in most cases, not in all cases, but in most cases to just add quarter periods after you start with the phase shift guy for the first one. Okay, let's go through and mark these off. So basically I'm starting at pi over 6, comma 2. So that's going to be right there. So let me mark this and say that this is pi over 6, comma 2. And let me make that a little bit better. The next guy is going to be an x-intercept. That's going to be right there. So this is pi over 3, comma 0. So this right there is pi over 3, comma 0. Let me make that a little bit better there. And then basically you're coming down to the minimum, which is going to be right there. And now you're going to have this pi over 2, comma negative 2. Maybe I can make that a little bit better there. And then coming back up, you're going to have another x-intercept. So that's at 2 pi over 3, comma 0. So this right here is 2 pi over 3, comma 0. So you're going to come back up to this maximum. So this guy right there, this is going to be 5 pi over 6, and then comma 2. So again, once you've got those 5 points, you can continue to the left or the right as much as you want, or you can just draw this little curve right here for one cycle. Again, feel free to click that link on Desmos, and you can go into more detail in terms of these points here. And then also if you want to look at points to the right or to the left, if you want to do some extra practice. Okay, let's take a look at problem 4. So here we have f of x equals cosine of, you have 3x minus 5 pi over 6. Let me just factor this now. So we have f of x is equal to the cosine of, let's go ahead and say that I'm going to pull out a 3, and then inside this would be x and then minus. Again, how do I undo multiplying by 3? Well, I would divide by 3, or you could say multiply by 1/3. So just put that there, and then times 5 pi over 6. Keep it real simple. So I know that 3 times x is 3x. Then minus, you have minus. And then you have 3 times 1/3, that's 1. So then you'd basically just have your 5 pi over 6. So that would match completely. Okay, so now that we have this form here, I'll just go ahead and do it here. When we get to the graph, I'll just work on the points. Let me put a 1 there for clarity. So the amplitude, again, is going to be the absolute value of 1, which is 1. And then when you think about your period, this is 2 pi over 3. And then when you think about the phase shift, so the phase shift, let me simplify this. This would be 5 pi over 18. So let me put that like that. Again, this is x minus 5 pi over 18. So to undo that, I need to add 5 pi over 18. So I'm going to the right by 5 pi over 18 units. So we'll go right 5 pi over 18. And then for the vertical shift, again, there's going to be none here. So vertical shift, we'll just say none. Okay, let's take a look at the graph. Let me go ahead and write that the period is, so the period is 2 pi over 3. So a quarter period is going to be 2 pi over 3 times a fourth. This would cancel, give me a 2 down there, so it's going to be pi over 6. That's really all you need to know is the quarter period and the phase shift. So the quarter period is pi over 6, and then the phase shift, let me write P period, S period for that. We know that it's going to the right by 5 pi over 18. So instead of 0, for the first x coordinate, you're going to have 5 pi over 18. So let me actually get rid of this. I'll just put the first x coordinate here is going to be 5 pi over 18. And in terms of the y coordinates, nothing's being affected here. So we know that normally it's 1, so it's going to stay as a 1. Let me put this here for the default, just so we're clear on what's happening. Let me put all these in. So next you would go to pi over 2, and this would be 0. And then next you would go to pi, and this would be -1. And then next you would go to 3 pi over 2, and this would be 0. And then lastly, you'd have 2 pi, and then this would be 1. Okay, so again, if you want to just add quarter periods, it'll make it real easy to do. So you have pi over 6 for the quarter period. I would go ahead and rewrite that. And let me just put equals. I'll say that it's pi over 6 times 3 over 3, which is 3 pi over 18. So just writing it to have a common denominator. So basically 5 pi over 18 plus 3 pi over 18, that's going to be 8 pi over 18. Again, I'll simplify that in a moment. So 8 pi over 18 plus 3 pi over 18, that would be 11 pi over 18. And then 11 pi over 18 plus 3 pi over 18, that's 14 pi over 18. And then 14 pi over 18 plus 3 pi over 18, that's going to be 17 pi over 18. Let me simplify these. So 8 divided by 2 is 4. And then 18 divided by 2 is 9. So this would be 4 pi over 9. Then this one's good. 14 divided by 2 is 7. And 18 divided by 2 is 9. All right, no change to the y values. So this is going to be 0, -1, 0, and 1. Let me make these better. It doesn't look so good. Let me close that down better like that. And let's go ahead and start with our 5 pi over 18, comma 1. So let's just say that that's going to be about right there. So I'll just label that and say it's 5 pi over 18, comma 1. And then this guy right here, let's just say it's about right there. This would be, let's say 4 pi over 9, comma 0. Maybe that 4 could be better there, and make that better there. Then this right here, let's say that's your minimum there. And then that's going to be at 11 pi over 18, comma, you'll have -1. And then we're coming back up, you're going to have an x-intercept. So that guy right there, let's say that that's going to occur at 7 pi over 9, comma 0. And then you're going to come back up to your maximum. Let's just say it's about right there. And I'll say for that point, it's going to be 17 pi over 18, and then comma 1. So again, if you want to click the link on Desmos, you can see these points in more detail. We're just sketching this cycle right here. So that's one cycle of the cosine graph. Again, you can keep doing this to the left or the right as much as you want. And I would advise you to just play around with the graph that I've given you on Desmos just to try to get additional points and see if you're correct. All right, let's take a look at problem 5 now. So we have f of x equals 3 times the sine of, you have your 4x plus pi over 6. I'll just do the first part here. So just like I did in the last example, so f of x is equal to, let's go 3 sine of, let's just go ahead and factor. So I'm going to pull out a 4. Again, inside you would have x plus, go ahead and just put a 1/4 here, and then times your pi over 6. That's all you have to do. 4 times x is 4x, then you have plus and plus. 4 times a fourth is 1, and then you'd have pi over 6. Okay, so looking at this, again, once it's in factor form, it's very, very simple. You're going to say that your amplitude is going to be the absolute value of 3, which is 3. Then your period, so your period is going to be 2 pi over this guy right here. So that's going to be your 4. 2 pi over 4, you could say that's really pi over 2 by just dividing 2 by 2 and getting 1. And then 4 divided by 2 is 2, so you'd have pi over 2. Okay, then you also have a phase shift. So you have your phase shift. And again, looking at this, you would multiply and say this is pi over 24. So let's go pi over 24. Again, how do I undo what's being done to x? Well, I'm adding pi over 24, so that means I need to subtract away pi over 24. So that means I'm going to the left by pi over 24. Okay, then for the vertical shift, so for the vertical shift, there's none. So just put none and be done with that. So we know the period is pi over 2. So a quarter period, again, all you have to do is multiply pi over 2 by 1/4. So that's going to be pi over 8. So let's just leave that there for right now. In terms of getting some points, again, I'm looking at sine. So again, if you do the standard points, you have your 0, 0. You have pi over 2, 1. Then you have pi, 0. You have 3 pi over 2, -1. And then you have 2 pi, 0. Okay, so let's think about what's going to happen here. First off, we know that there's a phase shift. We're going to the left by pi over 24. So for the x value here, it's going to be minus pi over 24. Again, if I'm starting at 0 normally, and I go to the left by pi over 24, well, now it's negative pi over 24. Let me actually scooch these down just a little bit, and didn't take that with me, so let me copy that. Then, basically, I'm going to add quarter periods. So you could write this as 3 pi over 24. So you have a common denominator, and just keep going. You could just simplify later. So negative pi over 24 plus 3 pi over 24, and that's 2 pi over 24. Let me just write it like that. So 2 pi over 24. Yes, we can simplify. We'll do that in a moment. Let me move these down, kind of bunched up together, and I'll bring this one back up just a little bit. So 2 pi over 24 plus 3 pi over 24, that's 5 pi over 24. And then 5 pi over 24 plus 3 pi over 24, that's 8 pi over 24. And then lastly, 8 pi over 24 plus 3 pi over 24, that is 11 pi over 24. So let me go through and simplify now. So this one and this one can be simplified. So 24 divided by 2 is going to be 12. So this is basically pi over 12. And then 24 divided by 8 would be 3. So let's make this pi over 3. Now let's talk about the y values. All we're doing here is multiplying them all by 3. So basically, if this is 0, this would be 0 still, and then this would be 0 still, and then this would be 0 still. This 1 times 3 would be 3, and this negative 1 times 3 would be negative 3. And let me make that a lot better there. I'm just going to erase this and this. I'm going to try to label this a little bit differently. It's kind of hard to see what I'm doing on the graph. So let me move this over here. Again, you can always click the Desmos link if you want something in more detail. I'm just trying to give you a rough estimate of what things look like. It's very hard to do this manually. That's why we normally rely on some graphing software. So you have negative pi over 24 comma 0. Let me just label this as number 1. And basically, I'm going to come over here and say that that's going to be about right there. So I'm just going to say that's number 1 for this point right here. Then you have pi over 12 comma 3. So let's just say that that's right there. I'm going to label that as number 2, again, referring to pi over 12 comma 3. And then coming down, you have this point right here. You have 5 pi over 24 comma 0. So I'm just going to label that as number 3, let's say. And then let me make this a little bit better here. We calm it down to the minimum. So right there, you're going to be looking at this one. So this would be number 4. So that's pi over 3 comma negative 3. And then basically we're coming back up to where we have an x-intercept. And so that's going to be number 5. So number 5. So this is 11 pi over 24 comma 0. This would just be one cycle of that sine graph. So just looking at it like that, you can easily tell that. And again, you can go to the right or to the left as much as you want. Click that link on Desmos if you want to get more detail or do more practice. Now, before I wrap up this problem and go to the next one, I did forget to number these guys right here. I did number 1, but I didn't do the rest. I think it's pretty obvious that this is number 2. I was talking about it as I did it, but just in case you're confused and you want something for reference, this is number 2, and this would be number 3, and this would be number 4, and then lastly, this would be number 5, if you're trying to match things up here. All right, for problem number 6, let's see, we have f of x equals 2 times the sine of, we have this 2x minus 3 pi over 4. Again, let me just factor it here. So f of x is equal to 2 times the sine of, let's put some brackets here, pull out a 2, and then you have x minus, again, I could just put a 1/2 here, and then times your 3 pi over 4. Close that down. Again, checking that 2 times x is 2x, and then minus 2 times 1/2 is 1. So you just have that 3 pi over 4. Okay, so looking at this, again, it's very, very simple in terms of getting the basic stuff, so the information you need. So the amplitude is just the absolute value of 2, which is 2. The period here is 2 pi over 2, which is just pi. So the period here is going to be pi. The phase shift, so let me abbreviate this just to make it shorter. So phase shift, so basically what you do is say this is 3 pi over 8 here. So this is 3 pi over 8. You are saying, how do I undo this? Well, I would add 3 pi over 8. Again, x minus 3 pi over 8, I'm shifting to the right by 3 pi over 8. So let's say that we're going right 3 pi over 8. And then for the vertical shift, again, I'm just going to abbreviate it. There's none, right? There's nothing out there. So we'll just put none. So let me put some stuff in there. Okay, coming down to the graph. Again, when you work with the basic sine function, you have your 0, comma 0 to get things started. Then you have your pi over 2, comma 1. You have your pi, comma 0. You have your 3 pi over 2, comma negative 1. And then 2 pi, comma 0. We know that for the first guy here, we're going to think about the phase shift. We're going to the right by 3 pi over 8. And I would note that a quarter period here is going to be pi over 4. So 0 plus 3 pi over 8 would be 3 pi over 8. And then this y value here all we're doing is multiplying by 2. So let's just keep this as a 0. And let me make this 3 better here. Your quarter period is going to be pi over 4. So all you're doing is you're saying 3 pi over 8 plus pi over 4. Again, you can just make this 2 pi over 8, just so you have a common denominator. So like that, let me fix that so it's more clear. And basically, if you look at 3 pi over 8 plus 2 pi over 8, that would be 5 pi over 8. So 5 pi over 8. I'll get the y value in a moment. And then coming through here, let's just keep adding 5 pi over 8 plus 2 pi over 8. That's 7 pi over 8. And then let's just keep adding. So 7 pi over 8 plus 2 pi over 8. That's 9 pi over 8. And then one more time. So 9 pi over 8 plus 2 pi over 8. That's going to be 11 pi over 8. So we've got all the x values, so that's done. For the y values, again, you're just multiplying things by 2. So 1 times 2 would be 2. And then this we know would still be 0, and this would still be 0. Negative 1 times 2 is negative 2. So again, once you have this, you're ready to sketch your graph. Very easy to do once you get a few of these problems down. It just becomes the same thing over and over again. It's just a rinse and repeat. Okay, so let's go through and find this one right here. I'll just call this number 1, number 2, number 3, number 4, and number 5. That way I don't have to spend time labeling things. So 3 pi over 8 comma 0. So where's that going to be? That's going to be right here. And then basically you have 5 pi over 8 comma 2. That's going to be right there. And then you have your 7 pi over 8 comma 0. So right there. And then you have your 9 pi over 8 comma negative 2. So let's say right there. And then coming back up to this 11 pi over 8 comma 0. So let me just quickly label this for reference. So this is number 1. This would be number 2. This would be number 3. Let me make that a lot better there. And then this would be number 4. And then this would be number 5. So you can just go based on this. Again, just click the link on Desmos if you want something in more detail. But you're just sketching one cycle here of your sine graph. And then basically you can continue to the right or the left as much as you want. Again, click the link on Desmos if you want to do more practice. All right, let's take a look at problem 7 now. So we have f of x equals 3 times the sine of, we have this x over 2 minus pi over 3, and then plus 2. Okay, so once again, I'm just going to go ahead and factor this now. So let's go f of x is equal to, we have our 3, and then sine of, let me go ahead and say that this x over 2, you could really write that as 1/2 times x. So I'm going to pull out a 1/2, and then inside the parentheses, you'd have x, and then minus. So now you have to think about this. If I'm pulling out a 1/2, how do I undo that? So in other words, what can I multiply by 1/2 to get 1? That would be 2. So I'm going to write a 2 and then times pi over 3. Close that down and then close this down and then plus 2. In other words, if you go back through and you say 1/2 times x, well, that's 1/2 times x or x over 2. Then you have minus and you have minus. 1/2 times 2 is 1. So then I'm just left with this pi over 3. So when we look at this now, we can go through and get our information. So the amplitude here, again, the absolute value of 3, that's just 3. And then for the period, so for the period, we're going to have our 2 pi over, it's going to be 1/2. So 2 pi over 1/2, again, it's just 2 pi multiplied by 2. So that's going to be 4 pi. So 4 pi. And then when we think about the phase shift, so let me just abbreviate that. So phase shift, you can multiply this together and just say this is 2 pi over 3 and make that a little bit better there. Again, because this is x minus 2 pi over 3, to undo what's being done to x, I need to add 2 pi over 3. So I'm going to the right by 2 pi over 3. So I'm just going to say right 2 pi over 3. And then this right here is going to create a vertical shift. So I'm going up by 2 units. So vertical shift, and I'm going up by 2. We have the period as 4 pi, and a quarter period, you would do 4 pi divided by 4, so that's pi. So when I come down here, I'm just going to put that my quarter period is pi. Now let's go back through and write our points in. So the normal points for the sine graph, again, you're going to have this 0, 0. You're going to have your pi over 2, 1. You have your pi, 0. Then you have 3 pi over 2, negative 1. And then lastly, you're going to have 2 pi, 0. All right, so the phase shift here, if we come back up, was right by 2 pi over 3. So instead of having an x-coordinate of 0, I'm going to have 2 pi over 3. So for this one, let's say that it's 2 pi over 3. I'll get the y values in a moment. Let's just go through and add. Instead of pi, let's write this as 3 pi over 3 for the quarter period. So 2 pi over 3 plus 3 pi over 3, that's 5 pi over 3. And you're just going to keep doing that. So let me do that here and here. So basically 5 pi over 3 plus 3 pi over 3, that's 8 pi over 3. And then 8 pi over 3 plus 3 pi over 3, that's going to be 11 pi over 3. And then 11 pi over 3 plus 3 pi over 3, that's 14 pi over 3. Okay, so now going through this, you don't need the quarter period anymore. You can get rid of that. You want to get your y values. So thinking about what's being done, we would first, again, this is 1, and then this is 2. You have to do those in that order. So it's 1, then 2. So you're going to multiply by 3 first, then add 2. So 0 times 3 is still 0, then plus 2 is 2. So that's going to be for that one, and that one, and that one. Then when you think about this one, 1 times 3 is done first, that's 3, then plus 2, that's 5. You'll notice if you look for the y-coordinate of your maximum, that is 5, so that is the correct way to do this. Then if you look at this one right here, it's -1, times 3, that's -3, then plus 2, that's -1. Again, looking at a minimum here, so basically the y-coordinate is -1, so that's consistent. Okay, get rid of this, and this, and this, and this. And again, to save a little time and space, I'm just going to go ahead and say that this is number 1, number 2, number 3, number 4, and number 5. So we have 2 pi over 3 comma 2. So where is that going to be? Well, that's going to be, let's say, about right there. So that's going to be for number 1. So 2 pi over 3 comma 2. So from here we go up and we hit our maximum. And so this would be your number 2. So that would be 5 pi over 3 comma 5. And then we're going to come back down. And we're going to come to right there. And again, the reason why we're stopping where there's a y value of 2, remember, normally we have our x-intercepts there, but we have this plus 2 that shifted everything up. A lot of times I'll take and draw a little horizontal line there. So this is the line y equals 2, and that's going through the middle of the graph. You can see that if you look at, let me erase this temporarily. If you look at from right here to right here, you can tell the amplitude is going to be 3. Right? And you can see that from right there as well. But this is 3, right? This is 2 for the y-coordinate, and this is 5. Well, 5 minus 2 is 3. If you look at it from here to here, it's also 3. So if you look at this as 2 and this is -1, well, 2 minus -1 is 2 plus 1, that's 3. So that's a good way to think about things in terms of where those previous x-intercepts are going to end up. You have this one, and then this one. Let me label that right there. And then basically this is your max, and then this is your minimum. Let's just say that's right there. So this was number 2, and this is your number 3. So again, that's 8 pi over 3 comma 2. This is your number 4. So 11 pi over 3 comma -1, and that needs to be closed down. And then coming back up, this is your number 5. So number 5, and so that's 14 pi over 3 comma 2. All right, let's take a look at problem 8. So let me slide down here. So we have f of x is equal to 3 times the cosine of, again, I'm just going to pull out the 4. So 4, and let me actually use brackets here, and I'll use parentheses here. So this would be x minus, again, how do I undo multiplication by 4? Well, I can divide by 4 or multiply by a fourth, whatever you want to do there. So let's just go ahead and close that down and put -1. Let's just go ahead and simplify this now. This would be 2 pi over 12. So 2 pi over 12, which of course, 12 divided by 2 would be 6. So you can just say it's pi over 6. Okay, let's slide down. Let's just go through and get our information. So the amplitude, again, that's the easiest thing to find. It's just going to be the absolute value of that 3, which is 3. And then the period is going to be 2 pi over 4. So that ends up giving you pi over 2. And then the phase shift, again, this is minus pi over 6. So to undo that, I need to add pi over 6. So you're going to the right by pi over 6. Then the vertical shift, you have -1 here. You could write that as plus -1 if you want. Basically, you're going down by 1 unit. So I'm just going to go down 1. Okay, so we're going back to cosine here. Let me go ahead and do this now. Again, I always find this helpful to draw a horizontal line through the middle of the graph. So y is equal to -1. Again, if you're looking for some confirmation of your amplitude, you can always think about that right there. And of course, that would be 3. This is 2, this is -1. 2 minus the -1 is 3. So you can do that there. Now, when we think about when we would normally have an x-intercept, well, the y value would be 0. Now what's going to happen is your y value is going to be -1. So just keep that in mind. Okay, so let's just think about some points. So for cosine, normally you would have, you start off at 0, 1, and then you're going to go to your pi over 2, and then comma, this would get you to 0. And then you have your pi, and that's -1. And then you have 3 pi over 2, and that's going to put you at 0. And then you have 2 pi, and that's going to put you back to 1. We know the period was pi over 2, so the quarter period would be pi over 2, and then times 1/4. So that's going to be pi over 8. That's your quarter period. Now, you had a phase shift, pi over 6 to the right. So let's say that this one, for the x value, let's just start with pi over 6. And I'll do the y values again in a little while. Those are easy to get. So basically, you want to add pi over 6 to pi over 8. So what I would do here is I would just get a common denominator. I would multiply this by, you would go, well, between 6 and 8, 6 is 3 times 2, and 8 is 2 cubed. So really, you want 8 times 3 or 24 for the LCD. So I would say this is times 3 over 3. So this is 3 pi over 24. So that's what I'm going to do. I'm going to go 3 pi over 24. And then for this one, you could multiply it just temporarily by 4 over 4. So that would be 4 pi over 24. So if you had 4 pi over 24 plus 3 pi over 24, that's 7 pi over 24. And then again, I'm just going to keep doing this. So I'm going to go 7 pi over 24 plus 3 pi over 24. And that's going to give me 10 pi over 24. Again, I'll simplify this in a moment. And then 10 pi over 24 plus 3 pi over 24, that's 13 pi over 24. Let me put some commas in here. And then for this one, you have 13 pi over 24 plus 3 pi over 24. That is 16 pi over 24. Okay, so what can I simplify? We know that 10 pi over 24, I can divide 10 by 2 and get 5. 24 divided by 2 is 12. Can't simplify this. For 16 and 24, you can divide 16 by 8 and get 2, and divide 24 by 8 and get 3, so that's 2 pi over 3. All right, for the y values, again, you can always plug in if you're confused about things, but the easiest way to do this is just to multiply by 3 first. Again, this is 1, and then this is 2, so then you're going to subtract away 1. So if I start with 1 and I multiply by 3, that's 3, then I got to go down by 1. I've got to shift down by 1, so 3 minus 1 is 2. And again, you start off at the maximum with this guy. So you know if you look, it's going to be this guy right here. That's your pi over 6 comma 2. So that would be my first point. Let me just label this as I go right here. So this is point number 1. And then basically I'll do that right here. This is point number 1. Now, anywhere where there was a 1, you can just go ahead and put a 2. So also right there. Let me get rid of this. We're done with that one. Now for the next one, again, instead of being at 0, we're shifting down by 1 unit. We're going to be on a y-coordinate of -1. But basically, the procedure would be 0 times 3, that's 0, and then minus 1, that's -1. So this would be number 2. Let me put that back in. So this is number 2. So we're coming down. And so basically, that would occur, let's just say right there. So that's your number 2, let's say. And maybe that could be better. I'll try to do this as best as I can. And then you're going to come to this one. So -1 times 3 would be -3, and then minus 1, that's -4. So we're coming down. So you can see that at the minimum, the y-coordinate is -4. So this is number 3 here. Let me erase this and put this as number 3. All right, so that's 5 pi over 12 comma -4. All right, for this point right here, we basically have, again, a 0. So all I'm going to do for the y value there is say it's -1. So we're just shifting down by 1 unit because 0 times 3 would still be 0, and then 0 minus 1 is -1. So this would be your number 4 here. So 13 pi over 24 comma -1. That would put you right there, let's say. So this is number 4. And then we're going to come back up to the maximum. So this is for number 5. So this is going to be 2 pi over 3 comma 2. So it's going to be right there. So again, just look at the more detailed graph on Desmos. You can just click the link. And we're just sketching one cycle of this guy. So it'll look something like that. And again, if you want to play around on Desmos, you can go as much as you want to the left or the right, or get more detail on the points that we looked at. Let me label this as number 5, just so this is complete and I don't leave anything off. So that was this point right here, the 2 pi over 3 comma 2. Okay, let's look at problem 9. So we have f of x equals 4 times the cosine of, we have our quantity 4x plus 3 pi over 2, and then plus 2. So once again, let me just start by factoring. So f of x is equal to 4, and then cosine of, let me put some brackets here. I'll put a 4 in there, and then this would be x plus, again, if I want to undo this, I'm going to put a 1/4 here, because 4 times 1/4 is 1, and then you have times your 3 pi over 2. If you just go ahead and simplify this now, it would be 3 pi over 8. So 3 pi over 8, close that down, and then plus 2. All right, so looking at this, again, we know that the amplitude, that's the easiest one to get, It's just the absolute value of this number right here. So the absolute value of 4 is 4. For the period, this is 2 pi over 4. So that becomes pi over 2. So this is pi over 2. Maybe I should just do the quarter period now. I'll just do that now to get it out the way. So pi over 2 times 1/4, or pi over 2 divided by 4, that's going to be pi over 8. So here for the phase shift, I'm going to think about, again, how do I undo what's being done to x? Here you have plus 3 pi over 8. So that means I need to subtract 3 pi over 8 away to undo what's being done to x. Another way you can do it is with that model. I don't like this. I think it confuses students. So again, they always try to make a minus here. So you have minus a negative. So basically, when this is a negative, what they say is you're going to the left by the absolute value of this number of units. They would basically say you're going to the left by 3 pi over 8. But I like to think about it like this. I just think it makes more sense. I just think about, well, how can I undo what's being done to x? So basically, it's just you're going left by 3 pi over 8, because I would need to subtract away 3 pi over 8 to undo what's being done to x. Again, that's how it makes sense for me. Maybe you like the formula. You can do it either way. So then the vertical shift, that's just coming from this part right here. So it's plus 2. We're just going up by 2. All right, let's come down here and look at the graph. The first thing I'm going to do, just like in other examples, I'm going to make a little horizontal line. We'll do y equals 2. That's going to go through the middle of this graph. So let me put that in like that. And I'm just going to arrow to this and say that's y is equal to 2. Now you can use this to check your amplitude. So at the maximum, the y value is 6. And then coming down here, the y value is going to be 2. So 6 minus 2 is 4. So that's one way to check it. You can also do the same thing by coming from this line here, going down to the minimum. So the y value for the minimum is negative 2. So you would do 2 minus a negative 2, which is 2 plus 2. So that's also 4. So a good way to check your amplitude. Another thing is, we're going to be taking those x-intercepts that we normally have, and we're going to be shifting them up by 2 units because of this plus 2. So again, normally this line is y equals 0. That cuts through the middle, or the x-axis. Now it's going to be at y equals 2. So a point that has a y-coordinate of 0 will now have a y-coordinate of 2. All right, so let's put in the basic points for the cosine graph. So we have 0, 1. Then we have our pi over 2, 0. We're going to have our pi, negative 1. Then we're going to have 3 pi over 2, and then 0. And then we're going to go back up to the maximum. So we're going to do 2 pi, 1. All right, the first thing we need is the phase shift. So let's go back. And the phase shift was left 3 pi over 8. So that means from this 0 right here, I'm going to subtract away 3 pi over 8. So basically, the x-coordinate there would be negative 3 pi over 8. And then from there, you're just going to add quarter periods. So we know that the period, again, going back, was pi over 2, and the quarter period was pi over 8. Let me write this out here. So the quarter period, and that's going to be pi over 8. So negative 3 pi over 8 plus pi over 8, that is going to give me negative 2 pi over 8. Now, yes, you can simplify that. I'll do that in a moment. Negative 2 pi over 8 plus pi over 8, that's negative pi over 8. And then if you do negative pi over 8 plus pi over 8, that's 0. And then if you do 0 plus pi over 8, that's pi over 8. So this one can be simplified. Negative 2 pi over 8 would be negative pi over 4. So let's just rewrite that one. And now let's think about the y values here. When you think about this one and this one, again, those were your x-intercepts, so where your y-coordinate was 0. When you multiply 0 times 4, you still have 0, so you're really just adding 2 or going up by 2 units. So I know that this one right here would be 2, and then this one right here would be 2. Again, that's why it's helpful to draw that line, y equals 2. Let me close this down and this down. Okay, now for this one and this one, essentially you just take 1 right here, your y-coordinate, and you multiply by 4 first, so that gives you 4. Then you add 2, that gives you 6. So that's this one and this one. Then for the last one, you have negative 1. Again, multiply by 4 first, that's negative 4. Then add 2, that's going to be negative 2. And again, I'll just number things. It's a little bit easier to do it that way. So let's say that this is number 1, this is number 2, this is number 3, this is number 4, and then this is number 5. Okay, so we're going to start off with point number 1. and this is negative 3 pi over 8 comma 6. That's going to be right here. So this right here would be your point number 1. Then we're going to come to this point right here. Let's say that this right here is number 2. So basically it's negative pi over 4 comma 2. So again, we're going to be on that line y equals 2. Then we're going to come down to the minimum right here. And basically that's going to be our number 3. So this is going to be negative pi over 8 comma negative 2. And then basically we're going to come back up. So we're going to go to right there. This is going to be your point number 4. So that's going to be 0 comma 2. And then we're going to come back up to the maximum. So we're going to finish up right there. So this is going to be your point number 5. And that is pi over 8 comma 6. So again, this is just going to be one cycle of that cosine graph. So this guy right there. Once again, I've given you a link on Desmos. So if you want to continue this to the right or to the left, you can do that just to get some additional practice. You can also just click the link if you want to get some more detail. All right, for problem 10, we have f of x equals 2 times the cosine of x plus 3 pi over 4, and then minus 2. All right, in this case, you really have a 1 as the coefficient of x, so you don't have to pull anything out. This gives you a period of 2 pi. So anytime you just see x like that, your period is 2 pi. Again, you could write this as f of x is equal to 2 times the cosine of, if you really wanted to, you could go 1 times the quantity x plus 3 pi over 4, and then do minus 2 like that. Maybe you're a little bit confused, but in unfactored form, you can always get the period for something like sine or cosine by doing 2 pi divided by whatever this coefficient is here or whatever's outside of here. Well, here it's just 1, so it would be 2 pi over 1, which is 2 pi. So really, you don't have to do much here. You're just going to say that the amplitude, so the amplitude is the absolute value of 2, which is 2. The period, again, would just be the standard 2 pi. We really don't have to do anything because the coefficient here is 1. The phase shift, again, this is plus 3 pi over 4, so I'm going to the left by 3 pi over 4. So let me put left 3 pi over 4, and then this right here, this minus 2, that's shifting me down. So let me put vertical shift. I'm just going to go down by 2. Okay, so once again, let's just come down to the graph. So I'm going to make a horizontal line, y equals negative 2. So once again, not required, just something I like to do. Again, it makes it easier to check your amplitude if you're concerned about that. So from right here, which would be a maximum coming down to this line right here, you have 0. That would be your y coordinate there because this would be the x-axis. And then down here, this is negative 2 for the y coordinate. So 0 minus the negative 2 is 0 plus 2, so that's 2 for the amplitude. Again, that's going to match what you have right there. Again, you could also do it this way. So you have from negative 2 going down to negative 4. And so negative 2 minus a negative 4 is negative 2 plus 4. And so again, that's going to be 2. Then in addition to this, remember that all your points that would have been on the x-axis, so where the y coordinate would have been 0, now the y coordinate is going to be negative 2. So you're going to be on that line. So let me once again start by writing in the standard points for cosine. So you have 0, 1, and then you have your pi over 2, 0. Then we're going to have pi, negative 1. We're going to have 3 pi over 2, 0. And then we're going to have 2 pi, 1. So thinking about the phase shift, again, coming back here, we can see it's left by 3 pi over 4. The period here is 2 pi, so that's the standard period. So your quarter period is just going to be pi over 2. So what I want to do is I want to subtract away 3 pi over 4 from 0. So 0 minus 3 pi over 4, that's going to be negative 3 pi over 4. Then basically you're going to add quarter periods. So the quarter period here, again, if this is 2 pi for the period, the quarter period is pi over 2. So basically what you're going to do is write this with a common denominator and say this is 2 pi over 4, just to make that a little bit easier. So negative 3 pi over 4 plus 2 pi over 4, that would be negative pi over 4. Then for this one, negative pi over 4 plus 2 pi over 4, that's going to be pi over 4. And then let me put some commas in there and there. For this one, pi over 4 plus 2 pi over 4, that's going to be 3 pi over 4. And then to finish things up, if you have 3 pi over 4 plus 2 pi over 4, that's going to be 5 pi over 4. Okay, let's get rid of this. Let's think about the y coordinates now. So we know when the y values were 0, So essentially where we had x-intercepts before, now we're just going down by 2 units because of this minus 2 right here. We're going to be on this line, which is y equals -2. Let me label that. I forgot to do that. So this is y equals -2. So let me put in a -2 here and then also here. Again, you can just go through the procedure if you don't want to think about it that way. If you do 0 times 2, that's done first, that's still 0. Then -2, that's -2. Then for this one and this one, you would do 1 times 2 first, that's 2. Then -2, that's going to be 0. So there, and then also there. Let me put some commas in there. And then basically for this one, you have -1. So -1 times 2, that's -2. And then -2, that's going to be -4. Okay, let me get rid of this. And let me just slide this down. Again, I'll just number things. We'll say this is number 1, number 2, number 3, number 4, and then number 5. So for number 1, we have -3 pi over 4, comma 0. So that's going to be right here. So basically, this is your point number 1. Then we're going to come down, and we're going to hit right here. So right here. Again, you're on that line y equals -2. That's where you would have had an x-intercept before, but you've been shifted down by 2 units. So we have -pi over 4, comma -2. So let me arrow to that and say that this is number 2. Then we're going to come to the minimum. So that's going to be right there. This is going to be for number 3. We have pi over 4, comma -4. So this right here is number 3. And then we're coming back up. So here we're going to be on that line again, which is y equals -2. Let me change the color. That one doesn't show up so well. This right here would be number 4. And that's going to be 3 pi over 4, comma -2. And then we're coming back up to the maximum. So let's say that's going to be right there. So that's going to be finishing up at number 5, which is 5 pi over 4, comma 0. So again, this right here would represent one cycle of that cosine graph. So one cycle of that cosine graph. If you want to click the link on Desmos, as I've told you before, you can go to the right or to the left as much as you want, or you can just use it to get some more detail. All right, let's take a look at the practice tests. For the instructions, we're asked to find the period, phase shift, vertical shift, and a pair of consecutive vertical asymptotes. We're asked to sketch the graph. All right, before we look at any problems, let's go ahead and do a quick review of some things that we need to know if we're trying to graph the tangent function. I'll talk about the cotangent function later on. Again, before we start, I also want to remind you that in this section, we're just thinking about the concept. How could I graph the tangent function or the cotangent function if I had to? So if I had a piece of paper and a pencil and I wanted to graph it. It does not have to be a perfect graph. You're just trying to learn the concept. If you want to graph something as we move out of this chapter, you're going to use graphing software, so something like Desmos. Generally speaking, in your book, when they first show you this, you're going to graph y equals tangent of x over one cycle, or one period if you want to say it that way. And the way they're going to show this to you is they're going to say y equals the tangent of x, where x is greater than -pi over 2 and less than pi over 2. So why are -pi over 2 and pi over 2 not included? Why do we have vertical asymptotes at those values? Well, if you go back to the definition of the tangent function, so the tangent of x is equal to the sine of x over the cosine of x. Well, remember that when you have a fraction involved, you want to guard against division by 0. We know that division by 0 is undefined. So we know that wherever the cosine value is going to be 0, so odd multiples of pi over 2, 3 pi over 2, 5 pi over 2, also -pi over 2, -3 pi over 2, -5 pi over 2. So wherever that's going to happen, the tangent value is going to be undefined. So something like, let's say, the tangent of, let's go pi over 2, and this is equal to the sine of pi over 2 over the cosine of pi over 2. We know the sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So again, 1 over 0, this is going to be, by definition, undefined. So this is undefined. Now this is going to happen, again, anywhere where the cosine value would be 0, so we just say odd multiples of pi over 2. So your first goal, when you sketch the tangent function, is to find what we call two consecutive vertical asymptotes. So if you're looking at y equals the tangent of x, again, we just use -pi over 2 and pi over 2 for the two consecutive vertical asymptotes. Let me write that out. So the vertical asymptotes for this guy, you have x equals -pi over 2, and you have x equals pi over 2. So those two guys. So if you get something that's different, let's say you had something like y equals the tangent of bx, well, all you have to do is take the bx here and plug it in for x right there and solve the inequality for x. So in other words, you would set up bx is greater than negative pi over 2 and less than pi over 2, like that, and that would give you your interval over which you can sketch the graph. You would have the leftmost value here, whatever that is, that would be your leftmost consecutive vertical asymptote that you're finding, and whatever this rightmost value is once you've solved this, that would be the rightmost consecutive vertical asymptote, and so you would just set those up on the graph. The other thing is, you need to find the 3 key points. So we talked about this in the lesson. You should know these 3 points from the basic y equals tangent of x graph. So something like this one right here, which is going to be negative pi over 4, comma negative 1. This one right here, this is going to be 0, comma 0. And then this one right here, this is going to be pi over 4, comma 1. So you need to memorize those points. When you get to your other tangent function that you're trying to graph, you can either use graphing transformations only to figure out where these guys are going to be, or you can use a combination of things. What I like to do is stick with the book method, and what they do is they find the period, which again, when you're working with tangent, it's going to be pi. So if you have something like y equals the tangent of bx, well, the period for this, so the period here is going to be pi over b. So the standard period divided by b, whatever that coefficient of x is. But let's erase this and just go with in terms of the y equals tangent of x. So we know the period is pi. If you want to find the quarter period, because this guy right here, this point is at the first quarter, this is halfway, and this is the third quarter. So if you want to find the quarter period, it's just pi over 4. And so to get the x values for the next thing that you're working with, you just add a quarter period. In other words, you could start right here at negative pi over 2, and you add a quarter period. So I add pi over 4, so this becomes negative 2 pi over 4 if I get a common denominator, plus pi over 4. And what does that give me? It gives me negative pi over 4, and you'll notice that that is the x value for this guy right here, so a quarter of the way through. If I want to get to this guy right here, the x value is going to be 0, because all I have to do is take negative pi over 4 and add a quarter period, which is pi over 4, and you know that's going to be 0. Then if I want to get to the next guy right here in terms of the x value, you're going to take 0, add a quarter period, which is pi over 4, you're going to get to pi over 4. Then if I add another quarter period, I'm going to get to my next asymptote. So pi over 4 plus pi over 4, that's 2 pi over 4, which is going to simplify to pi over 2. So it's just going to follow that pattern if you're finding x values. So if you're starting at a vertical asymptote, you add a quarter period to get to the x value of your quarter point, and then you add a quarter period again to get to the x value for the midway point. You add a quarter period again to get to the x value for the 3/4 of the way point, and then if you add a quarter period again, you're going to get to another vertical asymptote. In terms of the y values, you can plug into the function, or you can use just graphing transformations. So I'll talk about that on the first 2 problems, and we'll settle into a method on that. Now, the other thing I would say is that for the y values, you really don't have to worry about them too much, because for the first quarter point, everywhere it's going to be the same. So it's always going to be at negative 1 here. When you think about y equals the tangent of x, it's always going to be 0 for the halfway point, and then it's always going to be 1 for the 3/4 of the way point. So finding the y values, once you found it one time, if you're sketching more than one cycle, it's not a big deal. That's just something you can copy over and over and over again. It's not going to change. Always the same for the first quarter point, then it'll always be the same for the halfway point, and then it'll always be the same for the 3/4 of the way point. So you don't have to worry about that. All right, let's take a look at the first problem. So we have f of x equals 2, tangent of x over 2, minus 5 pi over 6, and then minus 2. So again, going back to what we just talked about a moment ago, if we look at y equals the tangent of x, we graph this as x is greater than negative pi over 2 and less than pi over 2. So what we can do is just modify this inequality, because now the argument is not x, it's going to be x over 2 minus 5 pi over 6. So let's say that x over 2 minus 5 pi over 6 is greater than negative pi over 2 and less than pi over 2. Let me slide down here a little bit. What I would do personally is clear the fractions. They're very tedious to work with. You have a denominator of 2, a denominator of 2, a denominator of 6, and a denominator of 2. So multiply everything here by 6. That would be your least common denominator. And so this right here would cancel with this right here and give me a 3. This would cancel with this and give me a 3. This would cancel with this, and then this would cancel with this and give me a 3. So 3 times negative pi is negative 3 pi. This is less than 3 times x is 3x, and then minus. This canceled, so you have 5 pi. So this is going to be less than 3 times pi is 3 pi. Let me slide down here a little bit, and I'm trying to isolate x in the middle. So to do that, I'm just going to add 5 pi to each part here. So this is going to cancel. So let's write that 3x is greater than negative 3 pi plus 5 pi, that's going to be 2 pi, and it's going to be less than 3 pi plus 5 pi, that's going to be 8 pi. As a final step, again, if you're trying to isolate x, let's divide each part by 3. And so this is going to cancel, and you're going to have that x is greater than 2 pi over 3 and less than 8 pi over 3. Let me put a little border here, and let me put that the two consecutive vertical asymptotes that we're trying to find, so v period, a period, we're going to list one as x is equal to 2 pi over 3, and then we'll say x is equal to 8 pi over 3. Now, in some cases, the book will not ask you for this. They'll say, just give me the asymptotes. So in that case, they want a formula to find all the asymptotes. So you could start with 2 pi over 3 or 8 pi over 3. It doesn't really matter. You could just say that it's x equals 2 pi over 3, and then plus, you need to know the period. So coming back up, this really is 1/2 times x. So the period for this guy, let me write this right now because we're going to need it. It's going to be the standard period for tangent, which is pi, and then divided by 1/2. It's the coefficient of x. So you can do that as pi over 1 times 2 over 1, which would be 2 pi. So this would be plus 2 pi n, where n is any integer. So this would be for your asymptotes if you're trying to find a formula for all of them. So that's something you can list. I'm going to get rid of that because I'm just going to focus on these two. Now, if you go to the graph, which I've already sketched, and again, I have a link for you on Desmos if you just want to click on that to follow along. Here's your vertical asymptote. You have x equals 2 pi over 3, and then you also have the vertical asymptote where x is equal to 8 pi over 3. So that one. So again, the period is 2 pi, so if you keep adding 2 pi, so in other words, if you did 8 pi over 3 plus, you could write 2 pi as 6 pi over 3. Well, 8 pi over 3 plus 6 pi over 3, that's 14 pi over 3. So you're going to be at another one. But for right now, I'm just focusing on this right here. So what are these three key points? This one, this one, and this one. So let's go back up. Again, going back to what we talked about in the review, to go from here to the x value of the first quarter point, you just add a quarter period. In other words, here it's x equals negative pi over 2, that's the vertical asymptote. If I add a quarter period, which in this case, y equals the tangent of x, the period is pi, so the quarter period is pi over 4. Well, if you do negative pi over 2 plus pi over 4, you get negative pi over 4. So here the period is 2 pi. Let me write that so we have it. So the period is 2 pi. So the quarter period is going to be 2 pi over 4, which is going to end up being pi over 2. So it's pi over 2. Now you always want to look at this guy right here. So this is your leftmost consecutive vertical asymptote that you found. And you're basically going to say, well, if this denominator is 3, go ahead and convert this over to where you're going to have a common denominator. So this is 2 and this is 3. So the LCD would be 6. So just multiply it now. It's just going to make your life a lot easier. So this would end up being 3 pi over 6. So another way to just write pi over 2, again, just making your life easier. So start with 2 pi over 3, and then plus, let me get rid of this and make it better. You're going to add your quarter period. So 3 pi over 6. Again, all I'm doing here, so you can see this visually, I'm starting at 2 pi over 3, and I'm saying if I add a quarter period, I'm going to get to this x value right here. I don't know what the y value is, I'll get that in a moment, but if I take 2 pi over 3 and I add pi over 2, I'm going to get to 7 pi over 6. So looking at this, of course I need a common denominator here, so I would multiply this by 2 over 2. That would be 4 pi over 6, and then plus 3 pi over 6, which would be that 7 pi over 6 that I just saw on the graph. So let me come down here, and let me say, for the first quarter point, we have 7 pi over 6 for the x value. Again, for the y value, I'll show you how to get that in a moment. That's very, very simple to get. Let's go back up. Essentially, at this point, you're just going to keep adding quarter periods. So now I'm going to go 7 pi over 6 plus a quarter period. And again, now that I have a common denominator, it's going to be very, very easy. I'm going to go 3 pi over 6 here, and that's going to be 10 pi over 6. And of course, that's 5 pi over 3 if you simplify. So this is 5 pi over 3. And going to the graph, again, just look at the x value for this point, 5 pi over 3. So let's keep this as 10 pi over 6 so we have a common denominator. So 10 pi over 6 plus 3 pi over 6. This is 13 pi over 6. So for the 3/4 point, let me make this one better here. This would be 13 pi over 6. And coming down, again, 3/4 of the way, you have 13 pi over 6 for the x value. Again, all we're trying to do at first is find the x value here, the x value here, and the x value here. We don't care about the y values because those are easy to find. Now coming back up, we also need to find the phase shift and the vertical shift, but I'll do that at the end. Coming back to this right here, again, notice that this is negative pi over 4, and this is negative 1. So negative pi over 4 for the x value, negative 1 for the y value, and your basic y equals the tangent of x. Then here it's 0, 0, and here it's pi over 4, 1. So notice that when we plug in, you're going to end up with the tangent of negative pi over 4, and you're going to multiply 2 by that, and then you're going to subtract away 2. So in other words, this original y-coordinate of negative 1 is going to get multiplied by 2 first, and then we're going to subtract away 2 second. So this is 1 and this is 2. It just follows the order of operations. It's very easy to do. In other words, if you start with negative 1 and you multiply by 2, and then you subtract away 2, so negative 1 times 2 is negative 2, and then minus 2, so this becomes negative 4. You go down to the graph, you have 7 pi over 6 comma negative 4. So let me put that in there. Alternatively, if you get confused by that, which is fine, some people do, you can always plug in. So you can say f of 7 pi over 6 is equal to 2 times the tangent of, for this, you have x over 2. So you can say that that is 7 pi over 6, which is your x value, times a half. That would be 7 pi over 12. And then minus, you have 5 pi over 6. You can write that with a common denominator by multiplying by 2 over 2. So you can say that's 10 pi over 12. Close that down and then say minus 2. Let me slide down here a little bit. So 7 pi over 12 minus 10 pi over 12, that is going to be negative 3 pi over 12. So notice that that simplifies to negative pi over 4. And again, we know that the tangent of negative pi over 4 is negative 1. So this becomes 2 times negative 1 minus 2. That's just what we did, just looking at the graphing transformations of multiplying by 2 first and then subtracting away 2 just based on that original y-coordinate of negative 1. It's much faster than plugging in. You get the same thing. So 2 times negative 1 is negative 2. And then minus 2, that's negative 4. So whichever way you want to do it, if you want to plug in, that's fine. If you don't, again, just memorize these y-coordinates. So negative 1, 0, and 1. And then when you're looking at this guy, all you're doing is you're thinking about what's happening in terms of the vertical transformations. We have a vertical stretch by a factor of 2. In other words, you're multiplying your y-coordinate by 2. So if it's negative 1, well, it's negative 1 times 2, that's negative 2. And then you have a shift down by 2. So if you now have negative 2 and you subtract away 2, now you're at negative 4. If you do it for the other two y values, for the midway, you have 0. So 0 times 2 and then minus 2. 0 times anything is 0. So then basically you just have minus 2, that's negative 2. Then the other one was 1. So 1 times 2 minus 2. So 1 times 2 is 2. 2 minus 2 is 0. So for the midway, you can have a y value of negative 2. And for 3/4, you can have 0. So this is negative 2. And then this is 0. Again, if you check this on the graph, here's 7 pi over 6 comma negative 4. Here's 5 pi over 3 comma negative 2. And then here's 13 pi over 6 comma 0. So you can see that matches up exactly with what we have on the graph. Again, if you want to get a little bit more practice, you can click the link I gave you for Desmos. You can get points over here or over here. I'll let you do those on your own. To finish things up, and this is going to lead into the next method, I'm going to do this problem again. We wanted to give the phase shift and also the vertical shift. The vertical shift is easy. It's just minus 2. Let me write that. So the vertical shift, you can just put down 2. And then the phase shift, this is the one that's tricky for a lot of people. You want to factor this. So you have f of x is equal to, you have 2 tangent of, let me move this over here like this. I'm going to pull out the coefficient of x. So it's 1/2, so pull that out. So inside, you would have x here. Now, this is where everyone gets tripped up. If I want to undo multiplication by 1/2, how do I do that? Well, I multiply by 2. So I want to put minus, I'm going to put 5 pi over 6 times 2 like this, and then cancel this with this and put a 3 down there. And then that's what you're going to want for your factorization. 1/2 times x is 1/2 x or x over 2, then minus and minus, and then 1/2 times 5 pi over 3 would be 5 pi over 6. Close that down and then minus 2. So what's the phase shift? You have this minus 5 pi over 3. Again, when you work on the inside of the function, you want to do the opposite. So if it's minus 5 pi over 3, how do I undo that? I need to add 5 pi over 3. So you would say you're going to go to the right 5 pi over 3. All right, for those of you that want to see this, I'm going to restart the problem and use only graphing transformations. So I'm not going to use that method where we use the quarter period to find the x values that we want. So we have f of x equals 2 tangent of x over 2 minus 5 pi over 6, then minus 2. So as we did a moment ago, we're just going to factor this. So we have f of x is equal to 2 tangent of, I'm going to pull out a 1/2. And again, we just saw this, so this becomes x minus 5 pi over 3. Again, you could pause the video and check if you need to, and then close this down, and then minus 2. So when we put this in factored form, it makes it easier to think about the horizontal transformations. The vertical ones are very easy. We saw that earlier, that this right here would be done first, and this right here would be done second. This is a vertical stretch by a factor of 2. This is a shift down by 2. This is done first. This is done second. It follows the order of operations. When I do some plugging in, you'll see why this is the case. Let me slide down here a little bit, and I'm just going to put, in terms of y, what you want to do first is multiply by 2. And then second, you want to subtract away 2, or you could say add negative 2. So we're just going to put subtract 2. So we already know this. We did this one earlier. Let me put a little border here. The ones for x, this is where it gets a little bit tricky and where students often make mistakes. The first thing is you have to think about, how can I undo what's being done to x? So everything is going to be undoing something, and also you have to go in the reverse order. When I plug in the end, I'll show you why that makes sense. But for right now, we want to look at this operation here. This is 1/2 times the quantity x minus 5 pi over 3. So using the order of operations, this right here would be done first. So if I plugged in something for x, I would subtract away 5 pi over 3 first, then I would multiply by 1/2. And I know you could distribute this in, but just looking at it in its current form without doing any distributing, this is how we would do it. This first, then this second. So if you want to undo that, you have to go in the reverse order. So this would be done first, and then this would be done second, and everything is us looking at how we can undo what's being done. So if I have multiplication by 1/2, to undo that, you need to multiply by 2. So here, you want to multiply by 2. So that's giving me a horizontal stretch by a factor of 2. Then this right here is minus 5 pi over 3. So how do I undo that? I need to add 5 pi over 3. So let me go for 2. We're going to add 5 pi over 3. So this would give me a shift to the right by 5 pi over 3. So let me paste this in right here. And again, if you're setting this up, you just need to know your 2 vertical asymptotes and your 3 key points. So coming back up, just to remind us, we look at y equals the tangent of x, where x is greater than negative pi over 2 and less than pi over 2. So a vertical asymptote at x equals negative pi over 2. Then you have the 3 points. So the first quarter point, negative pi over 4 comma negative 1. The halfway point is 0 comma 0. And the 3/4 of the way point, that's pi over 4 comma 1. And then you have a vertical asymptote at x equals pi over 2. So this is something you should have memorized. So let's come down here and let's do the points first. So if we have our first quarter point, then halfway, and then 3/4 of the way. Again, we already know that we have negative pi over 4 comma negative 1. We have 0 comma 0. And then we have our pi over 4 comma 1. So when we do our transformations, we are going to take our x value here, which is negative pi over 4. So negative pi over 4. And we're going to multiply by 2. And then we're going to add 5 pi over 3. So this would be equal to what? This right here would cancel with this right here and leave me with a 2 down there. So you'd have negative pi over 2. And let's multiply this by 3 over 3. So we can have a common denominator. And then plus you have 5 pi over 3. I'm going to multiply this by 2 over 2. The LCD there would be 6. So let's say this is equal to, you'd have negative 3 pi over 6. And then plus, this would be 10 pi over 6. So 10 pi over 6. And if you do the addition here, 10 pi plus negative 3 pi, that's going to be 7 pi. So you'd have 7 pi over 6. So 7 pi over 6. And for those of you that watched the first part where I did this using the quarter periods, you know that that was the x value for a quarter of the way through. So let's put a comma here. Let's get the y value. So that one's a lot easier. Again, all you're going to do for this is you're going to multiply by 2, then subtract away 2. So you take negative 1, you multiply by 2, then you subtract away 2. So this becomes negative 2 minus 2, which is negative 4. So that one's really easy. Okay, so for the next one, halfway, we have 0 comma 0. So this is really easy to work with. So for x, you multiply by 2, you'd still have 0. Then you add 5 pi over 3. That's 5 pi over 3. And then for this one, 0, if I multiply that by 2, I still have 0. Then subtract away 2, you have negative 2. All right, for this one, we have pi over 4 for the x value. So pi over 4. We want to multiply this by 2 first, and then add 5 pi over 3. So this would cancel with this and give me a 2 down there. So you're going to have, let's write pi over 2 as 3 pi over 6. So we can have a common denominator. And then plus, let's write 5 pi over 3 as 10 pi over 6. And this would be 13 pi over 6. So this is 13 pi over 6, and then comma. Again, for the y value, all you're doing is multiplying by 2 first and then subtracting away 2. So you're going to have 1 times 2, then minus 2. So this becomes 2 minus 2, which is 0. So this is 0 right there. Again, if we go back to the graph, we can verify these 3 points. So 7 pi over 6 comma negative 4, that's a quarter of the way. 5 pi over 3 comma negative 2, that's halfway. And then 13 pi over 6 comma 0, that's 3/4 of the way. So on the graph, you can see 7 pi over 6 comma negative 4, 5 pi over 3 comma negative 2, and then 13 pi over 6 comma 0. So we got our 3 points. Again, just using graphing transformations. Let me show you how to get the asymptotes here. So for that, you just need to do the transformations for x. So let me put a little border here. And from our model, we know that we start with x equals negative pi over 2. So negative pi over 2, you're just going to multiply by 2 and then add 5 pi over 3. So we see that this right here would cancel. So you have negative pi. You want a common denominator, so let's write that as negative 3 pi over 3. Just multiplying negative pi by 3 over 3, and then plus 5 pi over 3. And that's going to give you 2 pi over 3. So one of your asymptotes, when you talk about finding 2 consecutive vertical asymptotes, it's going to be at 2 pi over 3. So let's put for the vertical asymptotes, we get x is equal to 2 pi over 3. And then the other one, you'd have pi over 2. Again, you multiply by 2, and then you're going to add 5 pi over 3. So this would cancel. So you're going to end up with, let's say, pi. You could write that as 3 pi over 3, and then plus 5 pi over 3. So that's 8 pi over 3. So the other one would be at, let's say, and x equals 8 pi over 3. Again, coming back to the graph, here's your x equals 2 pi over 3. Here's your x equals 8 pi over 3. Now, if you're trying to go to the right or to the left to extend the graph, all you have to do is use your period. You don't really have to use the quarter period, although you can use that if you want. The period here we found was 2 pi. So all you'd have to do is say, if I take this x value right here, which is 7 pi over 6, and I add 2 pi, well, I could add 12 pi over 6. That would be 19 pi over 6. So if I go over here, this point, let's say about right there, it's not going to be perfect, but let's say that this one would end up being 19 pi over 6, and then comma, the y value would be negative 4. And you can do the same process for this point and this point. You could add 2 pi to this x value to get over here. If you wanted to subtract away 2 pi from this x value, you'd go over there. The y value, again, for each quarter point is going to be the same. The y value for each halfway point is the same, and the y value for each 3/4 of the way point is going to be the same. So you don't have to worry about finding the y value. Let's take one of these points, and let's see if we can figure out why we got this, multiply by 2 first, and then add 5 pi over 3. It's one thing for me to just tell you what the procedure is. It's another to stop and think about where it comes from. So let's go back up, and let's come to this guy right here. Now you can do this with any of the points. In terms of the y values, let me actually do that one first. If you think about why do we multiply by 2 and then subtract away 2 from whatever we get, if you plugged in a 7 pi over 6, so f of 7 pi over 6, and I'll actually show you what's going on in a moment. For right now, I'm doing the y stuff, so let's just say this is equal to, you would end up with 2 times the tangent of negative pi over 4, and then minus 2. If you did f of 5 pi over 3, you'd get 2 times the tangent of 0, and then minus 2. If you did f of 13 pi over 6, you would get 2 times the tangent of pi over 4, and then minus 2. So notice that for the x value that's a quarter of the way through, you end up with tangent of negative pi over 4. For the x value that's halfway through, you end up with tangent of 0. For the x value that's 3/4 of the way through, you end up with tangent of pi over 4. Again, just thinking about what's happening to y, we know the tangent of negative pi over 4 is going to be negative 1. That's a point on this model that we're using. We know the tangent of 0 is 0. We know the tangent of pi over 4 is 1. So the shortcut here, when you're using graphing transformations and not going through and plugging things in, you just need to memorize negative 1, 0, and 1. That way, when you think about it, well, I could really replace this with negative 1. So I could replace this with negative 1. I could replace this with 0. and then I could replace this with positive 1. So notice that all you're really doing here is you're saying, and let me put a multiplication symbol in here just so it's crystal clear what's going on. You're taking your y values that you've memorized, and then you're multiplying by 2. That's giving you that vertical stretch by a factor of 2. And then you're subtracting away 2 when you're done to shift down by 2 units. So 2 times negative 1 is negative 2, then minus 2, that's negative 4. Then 2 times 0 is 0, 0 minus 2 is negative 2. Then 2 times 1 is 2, then minus 2, that's going to give you 0. So that's the insight into why this works in terms of the y values. All you have to do is memorize negative 1, 0, and 1, because once you've found your x value for a quarter of the way through, this is going to end up, this part right here, that's going to end up being negative 1. So all I have to do is multiply 2 times that negative 1 and then subtract away 2. This part right here would end up being 0 here, and then it would be 1 here. Okay, so now that we understand what's going on with y, let's talk about x. So this is the one that's quite confusing for people. You might need to plug this in multiple times. So I'm just going to do it with this first one, and I'll let you do the other ones on your own. So if I do f of 7 pi over 6, I want you to see what's being done to x, and then you got to think about how can I undo that. So this is 2 times the tangent of, we're going to plug in, so we have 1/2 times. For x, we want to put 7 pi over 6, and then minus, you have 5 pi over 3. You could write that as 10 pi over 6. So you have a common denominator, close that down, and then let's close this down, and then minus 2. Okay, so let's go in order. If we don't distribute this, and we're just using our order of operations, the first thing you would do to this x value of 7 pi over 6, you would subtract away 10 pi over 6. So that's the first thing. So the first thing we would do is we would subtract, and I'm going to write 5 pi over 3. That's the simplified version of 10 pi over 6. So when you do that, what do you get? So this equals 2 times the tangent of, you have 1/2 times 7 pi minus 10 pi, that's negative 3 pi. So this is negative 3 pi over 6. Close that down, close that down. Now negative 3 pi over 6 is negative pi over 2. So then we have our minus 2 here. So what's the next thing we would do? We would multiply by 1/2. So let me put for number 2 here, we would multiply by 1/2. And if we do that operation, 1/2 times negative pi over 2, well, that's going to be negative pi over 4. So 2 times the tangent of negative pi over 4, close that down, and then minus 2. So again, going back to the model, we memorize the fact that a quarter of the way through, the x value is negative pi over 4. So what I have to do is actually undo what was done to x. Because if I plug in 7 pi over 6, I do some operations to it, and I end up with negative pi over 4. Well, if I'm only using graphing transformations, I don't know the 7 pi over 6. I know the negative pi over 4. So I have to go in reverse to get this right here. So hopefully that makes sense. Let me put a little border here, and let me put, how do we go in reverse? So this is what we want to do. Let me make this E better here. Okay, let me move this up a little bit so I can try to fit this on the screen. So the first thing here to undo what was done to x, you cannot start by undoing 1. You have to undo the latest thing that was done. You're going in reverse. So in other words, right now I have negative pi over 4. What I want to do is undo the multiplication by 1/2 that got me to negative pi over 4. At this point I had negative pi over 2, and I multiplied by 1/2. Well, to undo that, I need to multiply by 2. So I need to multiply by 2. Again, going back to what we said in our procedure, notice that we multiplied by 2 first. So if I show this, we would have negative pi over 4, and then you're going to multiply by 2. And so this is going to cancel with this, and that gets you back to negative pi over 2. So that puts me back to this point right here. The next thing I want to do is undo this. What did I do here? I took 7 pi over 6, and I subtracted away 5 pi over 3, or you could say 10 pi over 6 if you want a common denominator. So now I need to undo subtraction by 5 pi over 3. So I'm going to add 5 pi over 3 to undo that. And so we come over here and we say, well, if we had negative pi over 2 and we added 5 pi over 3, again, you would need a common denominator, and I'm running out of space. So let me just do this here. Let's say that this is negative 3 pi over 6, and let's say that this is 10 pi over 6. Well, that gets me back to 7 pi over 6 right there. So you see that you need to undo each thing, and you have to go in the reverse order. That's why when you look at this guy right here, you're thinking about, how do I undo what's being done to x? Again, with the order of operations, this is done first. Think about when you plugged in 7 pi over 6, well, you subtracted away first. So now this is going to be last, and you have to do the opposite operation. So this is done secant, and you're going to add 5 pi over 3. Then this right here, this would have been done second. So now when you're undoing things, you have to do this first, and you have to do the opposite operation. So you have to multiply by 2. So hopefully that makes sense for you. I know the first few times you go through graphing transformations in extreme detail, it gets quite confusing, but all you have to do is keep plugging in and going through the steps on your own. So start with something like, you could do 5 pi over 3, or you could do 13 pi over 6 if you want to do that on your own. Plug it in and go through each step, and then just say, well, how would I reverse that? In each case, you're going to come up with, okay, we need to multiply by 2 first, and then add 5 pi over 3. So the idea is I can start with negative pi over 4, something that I know, so something that would be right there, and I can undo all the steps, and then I would get back to 7 pi over 6, and that would be my x-coordinate for what I'm working with. All right, let's take a look at problem 2. So this is another one where I'll do it twice, once using the approach used in most textbooks, where we're involving the quarter period, and then I'll do it again, just using only graphing transformations, just so you can see that one more time, and then you can just pick the method that you like. We have f of x equals 3 tangent of 2x plus 5 pi over 3, then minus 2. So the first thing is I'm going to take this argument for the tangent function. So the 2x plus 5 pi over 3. This is greater than negative pi over 2 and less than pi over 2. So the least common denominator here is going to be 6 because you have 2, 3, and 2 for the denominators. So just multiply everything by 6. That way we can clear all those fractions. And so let's go through and say that this would be a 3 here. And then this right here would be a 2 here. And this right here would be a 3 here. So sliding down, you're going to have negative pi times 3, that's negative 3 pi. This is less than 6 times 2x is 12x. And then plus 2 times 5 pi is 10 pi, which is less than 3 times pi is 3 pi. So if I'm trying to isolate x in the middle, what I'm going to do is subtract 10 pi away from each part here. This is going to cancel. We have 12x is greater than negative 3 pi minus 10 pi, that's negative 13 pi, and it's less than 3 pi minus 10 pi is negative 7 pi. So if you want to isolate x in the middle, let's divide each part by 12. And so this would cancel, and you're going to get that x is greater than negative 13 pi over 12 and less than negative 7 pi over 12. Okay, let me paste this in. So for the 2 consecutive vertical asymptotes, you could say x is equal to negative 13 pi over 12. And then we're going to go x is equal to negative 7 pi over 12. All right, again, this is one that's pretty hard to see. I gave you that link on Desmos, so you can just click on that. This is your x equals negative 13 pi over 12. And this right here is your x equals negative 7 pi over 12. So those are your 2 consecutive vertical asymptotes. We need to figure out this point, this point, and this point. Really hard to read this because of the scale I had to use to get everything in here. But let's go back up. I'm just going to factor this now because we're going to need it in a moment. So f of x equals 3 tangent of, pull out the 2. So inside you'd have x plus, again, if I pulled out a 2, how do I undo multiplication by 2? Well, I need to divide by 2 or multiply by half. So you can go 5 pi over 3 times 2, which is 6. In other words, when this gets multiplied here, 2 times 5 pi over 6 is going to put me back to 5 pi over 3. It's just like I did this. I know a lot of people get confused by that. So this would end up being 5 pi over 6 there. So just close that down like that. And again, you could just check it to make sure. 2 times x is 2x. You have a plus and a plus. 2 times 5 pi over 6 is 5 pi over 3. So you're good to go. Then you have minus 2. For the phase shift, again, you're looking at, you have x plus 5 pi over 6. So that means I need to go to the left by 5 pi over 6. So let me write that in here. So for the phase shift, we're going to go left 5 pi over 6. We also need the vertical shift, and that's just going to be down by 2 because you have that minus 2 outside. So let's put down 2. Maybe that w could be better. Now for the period, again, the standard period for tangent is pi, and here you have this 2, right? You could think about it as being this guy outside the parentheses when it's factored, or the coefficient of x when it's not. So pi over 2 is going to be your period. So let's come down here and say that the period is pi over 2, and then the quarter period is going to be pi over 2 times a fourth, which is pi over 8. Okay, let me make this better here. So now, let me do this and do this. you're basically going to take this negative 13 pi over 12 and add a quarter period to get your x value for the first quarter point. Let me actually do this on another page. So negative 13 pi over 12. Let me make that better. And the quarter period is pi over 8. Again, getting a common denominator is what slows you down here. So if you have 12 and you have 8, again, 12 is 2 times 2 times 3, 8 is 2 cubed. So the LCD is going to be 8 times 3, which is 24. So I'm going to multiply this by 3 over 3, and I'm going to multiply this by 2 over 2. Let me slide this down like this. So this would end up being negative 26 pi over 24, plus this would be 3 pi over 24. So this would be negative 23 pi over 24. So when we think about our quarter period, we're just going to write it as 3 pi over 24 so we can have a common denominator. So let me just write these all at once and we'll go down and fill them out. Or actually, we can just keep it over here. This is a perfect page to use. So let me do this one. And I'll just put a little border, and I'll say for the 1/4 point or 1/4 point, if you want to say it that way, we'll say that the x value is negative 23 pi over 24. Let me go halfway and then 3/4 like that. So we're just going to keep adding quarter periods. Again, we're going to write this instead of pi over 8 as 3 pi over 24. So 3 pi over 24. So this would be equal to negative 23 pi plus 3 pi. That would be negative 20 pi over 24. And you can simplify that. So we would have a negative there. 20 divided by 4 would be 5. So this would be 5 pi over 24 divided by 4 is 6. So this is negative 5 pi over 6. And then again, you're just going to add a quarter period. So let me say this is negative 20 pi over 24, and then plus 3 pi over 24. So that's again our pi over 8 written with a common denominator. So this is going to be negative 17 pi over 24. Negative 17 pi over 24. Okay, let's get rid of this. And again, if you want your y values, you're going to come back up here and you're going to think about this is going to be done first and this is going to be done second. So this is a vertical stretch by a factor of 3, and then you have a shift down by 2. So in other words, if you start with your points from the basic tangent function, so negative pi over 4, comma negative 1, and then 0, comma 0, and then you'd have pi over 4, comma 1, where you're going to take negative 1, multiply by 3, that's negative 3, and then subtract away 2, that's negative 5. Let me come down here. We don't need a border anymore. This one would be negative 5 for the y value. Then for this one, you have 0 times 3, that's 0. Then minus 2, that's negative 2. So this would be negative 2 for the y value. And then lastly, you would have 1 times 3, that's 3. And then minus 2, that's going to be 1. So this would be 1 here. So coming down here, again, just click that link on Desmos. This is going to be really hard to see. But for the first quarter point, you'll see that we do have negative 23 pi over 24, comma negative 5. You'll just have to trust me if you can't read it. Again, on Desmos, you can see it very clearly. Then for the halfway, you have negative 5 pi over 6, comma negative 2. So just matching that. And then 3/4 of the way, you have your negative 17 pi over 24, comma 1. So everything matches there. Again, if you want to get some extra practice and just get some points going to the right or to the left, I have things filled out for you going this way and this way. So one cycle to the right and one cycle to the left if you want to get some practice. All right, so I'm just going to do this one more time where I do the graphing transformations approach. A lot of students find this quite easy and quick. So if you're not making mistakes on the horizontal transformations, it's pretty much the way to do it. So you have to think about what's happening on the outside. So what's affecting the y. So again, we already looked at this. This is 1 and then this is 2. You follow the order of operations. You're multiplying by 3, so that's giving you a vertical stretch by a factor of 3. And then once that's done, you're subtracting away 2. That's shifting you down by 2 units. So for the y, we would just say that for part 1, we're going to multiply by 3. And then the second thing is going to be subtract 2, or you could put add negative 2 if you want. So that's the way you want to do that. Now in terms of x, again, this is where things get tricky. I've already factored it, so that makes it easier. But essentially, you've got to reverse the order and reverse what's being done. So normally, again, you work inside of parentheses first, and then you would multiply. That's the order of operations. You start with parentheses, but you've got to reverse that order. So you're going to do this 1 and this 2. What we're saying is that this is not multiplication by 2. It's going to be multiplication by a half or division by 2. So how do you undo multiplication by 2? You divide by 2 or you multiply by half. So some people will say that this is horizontally compressed by a factor of 2, and then other people will say that it's been horizontally shrunk by a factor of a half. I personally do not care how you say it. Just realize that you're taking the x value and you're either dividing it by 2 or you're multiplying it by a half. So let me just put here that we're going to multiply by 1/2. So each x value gets multiplied by half or divided by 2 if you want to do it that way. Then the second thing is, again, you've got to undo this. I'm adding 5 pi over 6. I've got to undo that. So I need to subtract. Let me put this u better here. Subtract 5 pi over 6. Always the opposite on the inside. It's the opposite order, and everything needs to be undone. So just remember that. Okay, let me paste this in here, and let me just start with the asymptotes. So you have your x equals negative pi over 2, and again, you just follow this. So you're going to multiply by a half. So for the first part, you would say negative pi over 2 times 1/2. That gives you negative pi over 4. Then the second thing is you're going to subtract away 5 pi over 6. So you have negative pi over 4 and then minus 5 pi over 6. So the LCD there, you have 4, which is 2 squared, and you have 6, which is 2 times 3. So you need 4 times 3 or 12. So this becomes negative 3 pi over 12, just multiplying this by 3 over 3, minus this would become 10 pi over 12, multiplying this by 2 over 2. So you end up with negative 13 pi over 12. Again, going back to what we previously looked at, the vertical asymptote, you get x equals negative 13 pi over 12. So the same thing. So that is a vertical asymptote. Then you'd have your quarter point, you'd have your halfway, and then your 3/4. Then we need our other vertical asymptote. So we would work with pi over 2. So pi over 2, first you'd multiply by a half. Again, that's going to give me pi over 4. Then you want to subtract away 5 pi over 6. So pi over 4 minus 5 pi over 6. This becomes 3 pi over 12 minus 10 pi over 12. Again, multiplying this by 3 over 3 and multiplying this by 2 over 2. So this becomes negative 7 pi over 12. So let me get rid of that and just say that x equals negative 7 pi over 12. That would be our other vertical asymptote that we're finding. So let me put that this is our vertical asymptote. Again, coming back up, x equals negative 7 pi over 12. In terms of the points, let's go through those real quick. And let's just do the x part first, because it's a little bit more challenging. So you're going to take your standard points, which you have negative pi over 4, comma negative 1. So you take negative pi over 4, and you multiply by a half, and that gives you negative pi over 8. Then you have to subtract away 5 pi over 6. So negative pi over 8, and you subtract 5 pi over 6. Again, the tedious thing here is just getting common denominators. So you have 8, which is 2 cubed, and 6, which is 3 times 2. So you're going to want 8 times 3, which is 24. So multiply this by 4 over 4, and this by 3 over 3. Let me bring this down here. I'm going to run out of room. This would be negative 3 pi over 24 minus 20 pi over 24, which would be negative 23 pi over 24. So negative 23 pi over 24. For halfway, you're going to have an x value of 0. So that one's really easy to work with. You would want to do multiplication by a half. That would still be 0. And then subtract away 5 pi over 6. So that's minus 5 pi over 6. Then for 3/4 of the way, you have that pi over 4 comma 1. So you're going to go pi over 4 times a half. So that's pi over 8. So now you have pi over 8, and you want to subtract 5 pi over 6. Again, the LCD there would be 24. So let's say this is 3 pi over 24. Let me make that better. Minus, this would be 20 pi over 24. So multiply this by 3 over 3 and this by 4 over 4. So this would give me negative 17 pi over 24. And now we have negative 17 pi over 24. Okay, so that's done. So now we're working over here with the y values. You can just get rid of this. You don't need it. So you have, for the quarter of the way through, negative pi over 4 comma negative 1. So negative 1 times 3 is negative 3, and then minus 2 would be negative 5. And then you have 0 comma 0. So 0 times 3 is 0, then minus 2 is negative 2.
And then you have pi over 4 comma 1. So 1 times 3 is 3, and then minus 2 is going to be 1.
I'll just come back up so you can compare them. you have your negative 23 pi over 24 comma negative 5, your negative 5 pi over 6 comma negative 2, and your negative 17 pi over 24 comma 1. All right, let's take a look at problem 3. So for the rest of these, I'll just tell you that I'm just going to follow the book procedure. So we'll be using the quarter periods to get our x values, and we'll use graphing transformations to find the y values. So here we have f of x equals 4, tangent of 2x plus pi over 3 plus 2. Now, the first thing I'm going to do here, before I get any points or anything like that, I'm just going to go ahead and find the phase shift, the vertical shift, the period, and the quarter period. Just get that out of the way. So let's factor this. So f of x is equal to 4, and then tangent of. So pull out the 2. Inside, you're going to have x plus, again, if I want to undo multiplication by 2, I can divide by 2 or multiply by a half. So what you would do is say it's pi over 3 times 1/2. So we know that's going to be pi over 6. So this is pi over 6. Close that down and close this down, and then plus 2. Again, you can always check this. If you're not sure, 2 times x is 2x. Then you have a plus and a plus. 2 times pi over 6 would be pi over 3. So that's good to go. So when you factor it, it makes finding the phase shift much easier. You're just looking at this right here and you're saying, okay, well, I have x plus pi over 6. So I need to undo that. I need to subtract away pi over 6. So that means for the phase shift, I'm going to go left pi over 6. The vertical shift is super easy. You just have that plus 2 there. So for the vertical shift, we just want to go up 2. So that's all we need there. All right, I'm just going to drop this stuff off here, and we'll come back later on and revisit that page. You can erase this form. You don't need it if you're not using graphing transformations to find the x values. Let me slide down here a little bit. And let's think about the period. So we have this 2 that's the coefficient of x. Remember that the standard period for tangent is pi, but if you have this 2 that's multiplying the x there, well, what you do is you take your pi and you divide by 2. So the period is just pi over 2. So just dividing by the coefficient of x. Again, in factored form, it would be outside of parentheses. Then the quarter period, all you're going to do here is multiply this by a fourth. So that would be pi over 8. And again, I'll just drop this off here just so we have a page with our information. And let's go back up. So now that we found all that stuff, let's just go through and find the 2 consecutive vertical asymptotes, and we'll get our 3 points that we need. So the first thing is you're going to take your argument. So this guy right here. So the 2x plus pi over 3. So let me set that up. So 2x plus pi over 3. And we're going to say it's greater than negative pi over 2 and less than pi over 2. If you want, you can clear the fractions or you can work with them. It's up to you. I think fractions are very tedious to work with, so I always clear them. So you have a denominator of 2, a denominator of 3, and a denominator of 2. So the least common denominator would be 6. So I'm going to multiply this by 6. And I don't know if I have room. Let me slide this over. So multiply this by 6. Let me move that down, and then multiply this by 6 and this by 6. Let me slide that over so it fits. We'll go through and just cancel some stuff. So 6 divided by 2 is 3, and then 6 divided by 3 is 2, and then 6 divided by 2 is 3. So if we go through, we would say that 3 times negative pi is negative 3 pi, and this is less than 2x times 6 is 12x, and then plus you have 2 pi there, and then this is less than 3 times pi is 3 pi. All right, let's subtract 2 pi away from each part here. So we'll cancel this, and we'll say that 12x is greater than negative 3 pi minus 2 pi, that's negative 5 pi. And we'll say this is less than 3 pi minus 2 pi, that's going to be pi. So all we need to do here is divide each part by 12 so that we can isolate x in the middle. So this right here. And so we'll see that this would cancel with this, and you get x is greater than negative 5 pi over 12 and less than pi over 12. So let's grab this and come down here and paste this in. So this is telling me that in terms of those 2 consecutive vertical asymptotes that I'm looking for, let me put v period a period. You're going to have one at x equals negative 5 pi over 12. And then we would say, and you have another one, x equals pi over 12. If you want to look at the graph real quick, again, I left you a link for Desmos. This is your x equals negative 5 pi over 12, that guy right there. And then this is your x equals pi over 12, so that guy right there. So now we just need this point, and this point. So how do we get that? Again, in terms of the x values, you can just start with this negative 5 pi over 12 and add quarter periods. Now, if you look at this being a 12 and this being an 8, again, you're going to need a common denominator. That's what makes this stuff so tedious. So think about 8, that's 2 cubed. Think about 12, it's 2 squared times 3. So really, it's going to be 8 times 3, which is 24. So what you can do is multiply this now by 3 over 3. and say that we're going to write it as 3 pi over 24. It's just going to make your life a lot easier. So let's go ahead and say that we want negative 5 pi over 12 plus 3 pi over 24. And there's no room there, so we'll just do it here. And let me write this stuff up. So for the first quarter, halfway, and then 3/4, let me set this up like this. So the x value for this first quarter would be done here. So let me multiply this by 2 over 2. That would give me negative 10 pi over 24, just getting a common denominator. So negative 10 pi plus 3 pi, that's going to give me negative 7 pi, and then this is over 24. So that's your x value there. So negative 7 pi over 24. And you're just going to keep adding quarter periods. So let's add 3 pi over 24. And what does that give me? Let me move this up here. So this would be negative 7 pi plus 3 pi. That's going to be negative 4 pi over 24. If you simplify that, if you divide 4 by 4, you get 1. So this would be negative pi over 24 divided by 4 is 6. So negative pi over 6. Now just keep it in this form right here. So you have a common denominator already. Let's just move this up like that. And for this guy right here, negative 4 pi over 24 plus 3 pi over 24, that's negative pi over 24. So negative pi over 24. How do we find the y values? Again, you could plug in, but that's super slow. So I would suggest using graphing transformations for these. Again, go back up and look at what you're doing. You have this guy out in front. So this is a 4 that's multiplying this guy. So the tangent of this right here. So this is giving me a vertical stretch by a factor of 4. This is done first. Then this guy is done second. This is a shift up by 2. So we're going to multiply by 4, and then we're going to add 2. And we're doing this to the y coordinates, again, from the basic tangent function that we're working with. So negative 1, 0, and 1. So let me bring this down here, and hopefully you can remember this. If not, you could write out the points. Let me just do that real quick. So negative pi over 4, comma negative 1. Then you have 0, comma 0. And then you have pi over 4, comma 1. I know most of you have memorized this at this point, but you're going to take negative 1, multiply by 4, that's negative 4. Then add 2, that's negative 2. Then you're going to take 0, multiply by 4, that's still 0. Then add 2, so that's 2. Then you're going to take positive 1, multiply by 4, that's 4. Then add 2, that's going to be 6. All right, let's get rid of this. And the last thing to do here is you can just check these points. Again, you could just click that link and see, but I'm going to go down and just show this to you. So let me paste this in. And kind of hard to read, but again, if you start here at a quarter, you're going to have negative 7 pi over 24, comma negative 2. So that matches this. Then halfway, you're going to have negative pi over 6, comma 2. So that matches this. And then 3/4, you have negative pi over 24, comma 6. So that matches this. Again, click the link on Desmos. You'll see I gave you the points over here and over here. So one cycle to the right and to the left if you want to do some more practice. Okay, let's take a look at problem number 4 now. So we have our f of x equals negative 1/2 tangent of x plus pi over 2. In terms of the phase shift here, so the phase shift, I don't have to factor this. So I just have x plus pi over 2. So I think about how do I undo this plus pi over 2? Well, I've got to subtract away pi over 2. So we're going left pi over 2. In terms of the vertical shift, there's nothing out here. So that's none. So vertical shift, that is none. Okay, let's grab this, come down here, and I'm just going to paste that right here with our information. Come back up. Again, if you want to do the y coordinates first, you can, and just get out of the way. All you're really doing is multiplying each y coordinate by negative 1/2. So if you want to do that here, here's the 1/4. Here's the half, and here's the 3/4. Well, again, normally at 1/4, the y value is negative 1, but you're going to multiply it by negative 1/2. So that means I'm going to get positive 1/2. Normally it's 0 here. 0 times anything is still going to be 0. And then normally it's 1 here. 1 times negative 1/2 is negative 1/2. So now let's go in and get the period. Notice that the coefficient here is 1. So it's just going to be the standard period of pi. So for the period, that is pi. And then for the quarter period, it's just pi over 4. Let's just focus on getting the x values now. So just take the inside part here, the argument. So x plus pi over 2. We're going to say, where is this greater than negative pi over 2 and less than pi over 2? Well, the least common denominator here is 2 because you have a denominator of 2, 2, and 2. So just multiply each part by 2. Multiply by 2, and 2, and 2, and then 2. And that's going to give me negative pi. is less than 2x, and then plus this would be pi, which is less than this would be pi. And let me show things as canceling so nobody is lost. And let's make this x better. Now let's subtract pi away from each part. And so this would cancel. So we're going to have 2x in the middle. So we have 2x is greater than negative pi minus pi is negative 2 pi, and it's less than pi minus pi is 0. Let's divide each part by 2. And so this is going to cancel. Let me slide down here and say that x is greater than, this 2 would cancel with this 2, so this is negative pi, and less than 0 over 2 is 0. Come down and paste this in. So when you think about your two consecutive vertical asymptotes, you're going to have vertical asymptotes, x is equal to negative pi, and x is equal to 0. Coming down to look at the graph, here's your x is equal to negative pi, and then here is your x is equal to 0. So again, when you have x equals 0, that's the y-axis, you typically do not draw in an asymptote because you already have something there. You can put it there if you want. It's not incorrect, but that's how I'm going to draw it. So we need to figure out this point, and this point. So let's go back up. Okay, so we know the quarter period is pi over 4. And we're starting with x equals negative pi. That's the leftmost consecutive vertical asymptote. So you have negative pi and then plus pi over 4. So you could write this as negative 4 pi over 4. And this would give you negative 3 pi over 4. So that's going to be for this one right here. So negative 3 pi over 4. And then you're just going to keep adding a quarter period. So you're going to go negative 3 pi over 4 and then plus your pi over 4. That would be negative 2 pi over 4. That's going to simplify to negative pi over 2. So negative pi over 2. And then again, you can take your negative 2 pi over 4 and add a quarter period. So we're going to add pi over 4. And that would be negative pi over 4. So negative pi over 4. And let's just check these points real quick and we'll be done. And let me paste these in. Here's quarter of the way through. You have negative 3 pi over 4 comma 1/2. Then halfway, you have negative pi over 2 comma 0. 3/4 of the way, you have negative pi over 4 comma negative 1/2. So again, those points are there. I've labeled these points and these points there for you. If you want to get some additional practice, just go ahead and click on that link and you can go to the left or to the right by one cycle or even more cycles if you want to play around with the graph. All right, let's look at problem 5. So this is the last problem with tangent. So f of x equals 1/4 tangent of x over 4 minus 2 pi over 3 plus 1. So I'm going to factor it first just so we can get that information. So f of x equals 1/4. And then tangent of, pull out a 1/4 there. Inside, you're going to have x minus, again, if I'm pulling out a 1/4, how do I undo that? How do I undo multiplication by a 4th? You multiply by 4. So 4 times 2 pi would be 8 pi, and this is over 3. Close that down, and then plus 1. 1/4 times x is 1/4 x, or x over 4, minus and minus. 1/4 times 8 pi over 3, 8 divided by 4 is 2. So you'd have 2 pi over 3, which is what you have there. So this tells me that for the phase shift, I am going right. So I want right by 8 pi over 3. So 8 pi over 3. Again, this is minus 8 pi over 3. So to undo that, I need to add 8 pi over 3. Then my vertical shift, so my vertical shift is going to be up by 1. So up 1. And let me paste that in there so we have it. We also need the period, and we need the quarter period. So let's get that real quick. So again, in factored form, you have this guy right here, 1/4. If it's not in factored form, it's just going to be the coefficient of x. So you take your standard period, which is pi, and you divide by that. So what is pi divided by a 4th? In other words, I'm saying what is pi over 1 divided by a 4th? Well, that's pi over 1 times 4 over 1, which is 4 pi. So the period is 4 pi, and the quarter period is just pi. It's 4 pi over 4, which is just pi. Now, if you want to get your y values now, again, it's easy to do. You're going to multiply by a 4th, and then you're going to add 1. This 1/4 right here is giving you a vertical compression by a factor of 4. Again, some people will say it's vertically shrunk by a factor of a 4th. I don't care the terminology you use. Just realize that if you have a y value, you are either dividing by 4 or you're multiplying by a 4th. It has the same impact on that y coordinate. So that's what you're doing first. Then you're adding 1. So what I would do is take, again, you have -1, 0, and 1. So -1 times a 4th, and then plus 1. Then you can have 0 times a 4th, and then plus 1. Then you're going to have +1 times a 4th, and then plus 1. You might as well write this in each case. Well, not this one, because it's not going to matter. But this is 4 over 4, and this is 4 over 4, so you have a common denominator. So this would be -1/4 plus 4 over 4 So this would be 3/4. Then here, this would be 0 times anything is still 0. So 0 plus 1 is 1. And then here, 1 times a fourth is a fourth. And then plus 4/4, this is 5/4. So you get 3/4, 1, and 5/4. So let me put quarter, half, and 3/4. Put our points in there. So this is 3/4, 1, and 5/4. Let me make that better. Okay, so now we just need the x values. To do that, I'm going to go x over 4 minus 2 pi over 3 is greater than negative pi over 2 and less than pi over 2. Now you have a denominator of 2, 4, 3, and 2. So really you want 4 times 3 or 12. That's going to be your LCD. So I'm going to multiply everything here by 12. Let me scooch this down and go 12 times this, and then times 12, and then times 12. All right, so 12 divided by 2 is 6. 12 divided by 4 is 3. And then 12 divided by 3 is 4. And then 12 divided by 2 is 6. So looking at this, we have 6 times negative pi. That's negative 6 pi. This is less than, you have 3x. And then minus 2 pi times 4, that's going to be 8 pi. And this is less than, 6 times pi is 6 pi. So here, let's add 8 pi to each part. So this is going to cancel. We have 3x in the middle, and this is greater than negative 6 pi plus 8 pi, that's going to be 2 pi, and it's less than 6 pi plus 8 pi, that's 14 pi. Let's divide each part by 3. And let's come down here and say that this would cancel. So we're going to end up with x is greater than 2 pi over 3 and less than 14 pi over 3. Let me make this better here. Let me grab this and let me come down here and paste this in. So in terms of your vertical asymptotes, you have one at x equals 2 pi over 3. And you have your x equals 14 pi over 3. So coming down to the graph, here is your x equals 2 pi over 3. And then here is your x equals 14 pi over 3. And we just need these points right here. So we already know the y value is 3/4, 1 5/4. We got that earlier, but we need to get these x values here. So let's go back up. So again, I'm just going to start with this. So 2 pi over 3. That's the x value from the leftmost vertical asymptote that we found. And I'm going to add a quarter period. So I'm going to add pi. You can write that as 3 pi over 3. So 2 pi over 3 plus 3 pi over 3, that's 5 pi over 3. Then you just keep adding 3 pi over 3. So now this would be 5 pi over 3 plus 3 pi over 3. That would be 8 pi over 3. And then do that one more time. So 8 pi over 3 plus 3 pi over 3. That would be 11 pi over 3. So these are going to be those 3 points right there. Let me just grab this real quick. Come down here and I'll just paste this in. So this point right here, you can see it's 5 pi over 3 comma 3/4. Then this point right here is 8 pi over 3 comma 1. And then this point right here is 11 pi over 3 comma 5/4. This is an example of one where you get these 3 points and it would still be hard to draw this by hand because you really don't have any guidance here other than I'm going to draw it to where I approach this asymptote, and the same thing goes over here. So if you want to get something a little bit further to the right, you could just pick something that's close to right here so you can get one of these points in here. It would help you if you were trying to make a more accurate graph by hand. But again, a lot of teachers don't care even in this scenario. You just put your vertical asymptote, your 3 points in your vertical asymptote, and just do the best you can to sketch it. Again, if you want to play around with this and get some additional points, I have this filled in for you for this cycle right here and this cycle right here on Desmos. Okay, the next problems will deal with the cotangent function. So again, I want to show you this one more time from the lesson. We graphed y equals cotangent of x, where we said that x was greater than 0 and less than pi. So for the cotangent of x, now you have the cosine of x over the sine of x. So this guy's going to be undefined anywhere where the sine values are 0. So that's at 0, pi, 2 pi, 3 pi, or you can go negative pi, negative 2 pi. So basically pi n where n is any integer. So you see you have a vertical asymptote. It's not shown, but it would be where x is 0. Again, if you have the y-axis there, you don't need to put it. Basically, this guy is drawn to where it approaches that, but doesn't touch it. And then you have one at pi. But again, you'd have one at 2 pi, 3 pi, 4 pi, so on and so forth. In terms of your points that you're going to use, you need to memorize that you have pi over 4 comma 1. So pi over 4 comma 1, that's a quarter of the way through. This one right here is going to be pi over 2 comma 0. And then this one right here is going to be 3 pi over 4 comma negative 1. So you need to memorize this for the quarter, halfway, 3/4. Very important to memorize those. Now, in terms of the period, it's still going to be pi. So if you get something like y equals the cotangent of bx, something like this, well, then the period is going to be pi over b, just like we saw with tangent. So pretty much everything is the same in terms of the process. You're just going to be solving this inequality here, where you take your argument and plug it in for x. That's going to get you started. That's going to give you your 2 consecutive vertical asymptotes. And then you just figure out what is the period, and you can add quarter periods to get your x values for your 3 key points. The y values, you can just still use graphing transformations. You just have to memorize these points here. The y value for a quarter of the way through is 1, then halfway through is 0, and then 3/4 of the way through is -1. All right, let's take a look at problem 6. So we have f of x equals 3, cotangent of x over 3 minus 5 pi over 6, and then plus 2. The first thing I'm going to do is just get the information. So f of x equals 3, cotangent of, let me just pull this out. So 1/3 times, you can have x and then minus. Again, I want to undo multiplication by 1/3. So that means I need a 3 here. So I'm going to go 3 times 5 pi over 6. This 3 would cancel with the 6 and give me a 2 down here. So let's put 5 pi over 2. So 5 pi over 2. And then close this down and then plus 2. So when you check this, 1/3 times x is 1/3 x, or x over 3. You have a minus and a minus. 1/3 times 5 pi over 2, that would be 5 pi over 6. So this is good to go. So I do this so I can get the phase shift. And so that's basically going to be your phase shift. You have minus 5 pi over 2 here. So you need to undo that by adding 5 pi over 2. So that means I'm going to the right 5 pi over 2. That's all it is. Let me fix that. And then the vertical shift, that is going to be, you have a plus 2 on the outside, so just up 2. So we also need the period in the quarter period. So again, for the period for cotangent, it's just pi. And you have this 1/3 that's right here, or again, you can think about it as, what's the coefficient of x? It's 1/3. So you just take pi and divide it by 1/3. That's the same thing as multiplying by 3. So your period would be 3 pi. So let's come down here and say that the period is 3 pi. And so the quarter period is going to be 3 pi divided by 4. So 3 pi over 4. Okay, so let me make this p better here, like this. And let me move this down a little bit so we have some room, and come back up here. We don't really need the factored form anymore. Again, if you're going to do this with all graphing transformations, you can use it. Let me slide down here a little bit. I'm going to do the y's first, just easy to do. You're multiplying by 3. That's the first thing. And then the second thing is you're going to add 2. So you're going to multiply by 3. That's number 1. And then the second thing is add 2. Now remember, your points changed. Now you have pi over 4, comma 1. Then you have pi over 2, comma 0. And you have 3 pi over 4, comma -1. So you have to memorize these new points. If you're used to working with tangent, it's going to throw you off. So let me do this. And let me get the y values. Let me move this over here so it fits. Do this and this, comma, comma. Put that and that and that. Maybe that could be better. So multiply by 3. 1 times 3 is 3. Then add 2. 3 plus 2 is 5. So then 0 times 3 is 0. Plus 2 is 2. And then -1 times 3 is -3. And then plus 2, that's -1. And let me label this. So this is for the quarter, half, 3/4. And let me just put this in here. And basically we just need the x values now. So let me come up here. And again, you can use graphing transformations if you want. I'm just going to stick with the book method. So I'm going to go x over 3 minus 5 pi over 6. Now you've got to go greater than 0 and less than pi. So what you're going to do here is find that the LCD is going to be 6. So just multiply everything by 6. So times 6, times 6, times 6, times 6. And 0 times 6 is going to be 0. So this is less than 6 divided by 3 is 2. 2 times x is 2x. And then minus the 6's cancel. You get 5 pi. So which is less than 6 times pi is 6 pi. All right, so let me add 5 pi to each part here. This cancels. We get 2x is greater than 5 pi and less than 6 pi plus 5 pi, that's 11 pi. Let me divide each part here by 2. And so this is going to cancel. And we're going to get x is greater than 5 pi over 2 and less than 11 pi over 2. So let's grab this and we'll paste this in here. And now we have our 2 consecutive vertical asymptotes. So for the vertical asymptotes, you get x is equal to 5 pi over 2 and then and x is equal to 11 pi over 2. So coming to the graph, here's your x equals 5 pi over 2. Here's your x equals 11 pi over 2. So we just need this point, and this point. We already know the y values. We just need to get the x values. So again, start with this x equals 5 pi over 2. That's the leftmost vertical asymptote that you found. So 5 pi over 2. And you're going to add a quarter period. So you're going to add 3 pi over 4. Let me do this on another page. Just multiply this by 2 over 2. And you're going to get 10 pi over 4. So this is 10 pi over 4 plus 3 pi over 4. That is 13 pi over 4. And then you just keep adding a quarter period. So you're going to have that 13 pi over 4 plus 3 pi over 4. That would give you 16 pi over 4. So this would be equal to 16 divided by 4 is 4, so this would be 4 pi. So let me put 4 pi here. Just keep this in this form so we have a common denominator. So keep it as 16 pi over 4. And add 3 pi over 4, so that's going to be 19 pi over 4. So 19 pi over 4. All right, so we have our points. Let's just check it real quick. So let's paste this in. So a quarter of the way, we should have 13 pi over 4 comma 5. So that's what we have. And then we have for halfway 4 pi comma 2. So that's what we have. And then 3/4 of the way, we should have 19 pi over 4 comma negative 1. So that's what we have. Again, just click the link on Desmos if you want to see things in more detail or practice going a cycle to the right or to the left. I already have those points filled in for you. All right, let's take a look at problem 7. So we have f of x equals 2 cotangent of x over 2 plus 5 pi over 4 and then minus 2. Let me slide down here a little bit. And I'm just going to start off with a phase shift. So we'll get that out of the way. So f of x is equal to 2 cotangent of. I'm just going to factor out a 1/2. So inside you'd have x plus. Again, if I want to undo multiplication by a half, what I can do is multiply by 2. So just take that 5 pi over 4. That's there right now. And multiply by 2. So this would cancel with this and give me a 2 down there. So this would be 5 pi over 2. Close that down, close this down, and then minus 2. Again, you can always check 1/2 times x is 1/2 x, or you could say x over 2. Then you have plus and plus, and then 1/2 times 5 pi over 2 would be 5 pi over 4. So this is good to go. So when we think about the phase shift, again, we're focused on that part right there, and we want to undo that. So we would want to subtract away 5 pi over 2. So for the phase shift, we're going to go to the left by 5 pi over 2. In terms of the vertical shift, again, this one's always the easy one to get. We just have that minus 2 on the outside there. So let's say that the vertical shift is going to be down 2. Now, while we're here, we can just grab the period and quarter period. So what is the period? Again, just take the standard period for cotangent, which is pi, and you're going to divide by this guy right here, this 1/2. Again, if it's not in factored form, you'd see 1/2 x. So you're just looking at either the coefficient of x if it's in unfactored form or the number outside of the parentheses when it's in factored form. So divide pi, your standard period for cotangent, by 1/2. That's going to be 2 pi. So the period is 2 pi, and then the quarter period, that's going to be 2 pi over 4, which I think we know at this point is pi over 2. And let me paste this in here. Okay, so once again, if you're not using horizontal graphing transformations, which we're not going to do here, you can erase this form. You don't really need it. I'm just going to stick to working with this. So I'm going to take this argument here, this x over 2 plus 5 pi over 4, and I'm just going to set up my inequality. So x over 2 plus 5 pi over 4, we'll say that's greater than 0 and less than pi. So here, the least common denominator would be 4, since you have a denominator of 4 and a denominator of 2. So let's multiply everything by 4, just so we can clear those fractions. And so this right here would cancel with this and give me a 2. And then this would cancel. And so what you have is 0 times 4, which is still 0. That's less than 2 times x is 2x. And then plus, this cancels, so you just have 5 pi. And then this is less than 4 times pi is 4 pi. At this point, I'm going to subtract away 5 pi from each part. And so this right here is going to cancel. So you're going to have 2x is greater than 0 minus 5 pi is negative 5 pi. And it's going to be less than 4 pi minus 5 pi, that's negative pi. To finish things up, let's divide each part by 2. So we can isolate our x in the middle. So we want that right there. So this would cancel. You get x is greater than negative 5 pi over 2 and less than negative pi over 2. Okay, let me paste this in here. So your two consecutive vertical asymptotes, you're going to have x is equal to negative 5 pi over 2. And then I'm going to write and. You're going to have x is equal to negative pi over 2. Again, if you want to verify this on the graph at this point, here's your x equals negative 5 pi over 2. And then here's your x equals negative pi over 2. So we got that part. We need this guy, and this guy. So let's go back up. So the quarter period is pi over 2. So that's going to work out quite nicely for us. So we're just going to take this negative 5 pi over 2. So that's the leftmost consecutive vertical asymptote that we found. And we're going to add a quarter period. So plus pi over 2. Let me do this on another sheet. So let me paste this in here. So this would give me negative 4 pi over 2, which of course is going to simplify to negative 2 pi. So if I'm setting this up, you have your first quarter point, you have negative 2 pi, and then you have your halfway, and then you have your 3/4 of the way. And so now negative 4 pi over 2, that's the next one you're going to do. You're just going to keep adding quarter periods. So we're going to go plus pi over 2. So this is negative 3 pi over 2. So negative 3 pi over 2. And I want to do this one more time. So now let's go negative 3 pi over 2 and then plus pi over 2. That's going to give me negative 2 pi over 2, which is negative pi. So this is negative pi. All right, for the y values, again, it's very straightforward. Let's go back up. When you look at what you have for the vertical transformations, you have this 2 right here that's giving you a vertical stretch by a factor of 2. So first you're going to multiply by 2. And then the second thing you have here, you have a shift down by 2 units. This one right here is going to be subtract 2. So multiply by 2 first, then subtract away 2. Let me grab this and let me paste this in. So hopefully you remember the y coordinates. They've changed versus tangent, so a lot of people get them confused. But with cotangent, you're looking at 1, 0, and then negative 1. With tangent, it's negative 1, 0, and 1. So you just have to remember that. So you're starting with 1, you're going to multiply by 2, and then subtract away 2. So I'm going to go 1 times 2 minus 2. Then you'd have 0 times 2 minus 2. Then negative 1 times 2 minus 2. So 1 times 2 is 2. 2 minus 2 is 0. Close that down. 0 times 2 is 0. Minus 2 is negative 2. Close that down. Negative 1 times 2 is negative 2. Then negative 2 minus 2 is negative 4. So let's put negative 4. Close that down. And again, we can just check this real quick and be done. All right, let me paste this in. For the first quarter point, you have negative 2 pi comma 0. So that's this guy right here. For the halfway, you have negative 3 pi over 2 comma negative 2. So this guy right here. And then for the 3/4 of the way, you have negative pi comma negative 4. So this guy right here. So once again, I did leave you a link on Desmos if you want to go to the left or right by one cycle or play around with the graph and get some more points going on your own. All right, let's move on to problem number 8. So here we have f of x equals 3, cotangent of x over 3, plus pi over 3 plus 2. I'm just going to get the phase shift out of the way. So let's go f of x is equal to 3, cotangent of, pull out a 1/3. Inside you'd have x plus pi. Close that down, close this down, then plus 2. So this one's really easy. A third times x is x over 3 or 1/3 x, then plus and plus. And then you have 1/3 times pi. That would be pi over 3 or 1/3 pi, if you want to write it that way. So that is a match. So the phase shift, again, I want to undo this. I have plus pi there, so I want to undo that by saying minus pi. So I'm going to the left by pi. So for the phase shift, I want to go left pi. Then when we think about the vertical shift, again, this plus 2 out here, that's just telling me I'm going up by 2 units. So for the vertical shift, we're just going up 2. You can erase this. You could keep it if you want. We just need the period and the quarter period. Again, the coefficient of x here is 1/3. So you're just taking that standard period, which is pi, and dividing it by 1/3. So that just means you're multiplying by 3. So you're going to get 3 pi. So the period here is going to be 3 pi. And so the quarter period is going to be 3 pi over 4. So that's all we need there. Let's grab this, come down here and paste this in and come back up. So what I'm going to do now is, again, just get my consecutive vertical asymptotes. I'm just going to grab this right here, this argument for the cotangent function, and just set up my inequality. So x over 3 plus pi over 3 is greater than 0 and less than pi. Let's multiply everything by 3 so we can clear these fractions and not have to work with them. So this is 0 is less than. This cancels, so you have x plus, this cancels. So you're going to have pi, which is less than. 3 times pi is 3 pi. So for this one, I'm just going to subtract pi away from each part here. This cancels. So we'll have that x is greater than. 0 minus pi is negative pi, and it's less than. 3 pi minus pi is 2 pi. Okay, let's grab this, and we're going to just paste this in. So the consecutive vertical asymptotes that we're finding, you get x is equal to negative pi, and then 3 pi minus pi is 2 pi. So 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 3 pi minus pi is and you can have x is equal to 2 pi. Let's go down and let's just check this real quick. So here's your x equals negative pi, and then here's your x equals 2 pi. So we need this point, and this point. So let's go back up and get those. So we're going to start with an x value of negative pi. And again, you're adding quarter periods, so 3 pi over 4. So let's do negative pi plus 3 pi over 4. You could just write this as negative 4 pi over 4. So you have a common denominator. So for the first quarter point, the x value would be negative pi over 4. Just doing negative 4 pi plus 3 pi, that's negative pi, and then over the common denominator of 4. So for the first quarter point, the x value is negative pi over 4. Let's do halfway and then 3/4. So negative pi over 4, you would add 3 pi over 4, and that would give you 2 pi over 4, and that's going to simplify to pi over 2. So this is pi over 2. So let me erase this and put this now as 2 pi over 4. So I'm going to add 3 pi over 4, and that's going to give me 5 pi over 4. So that's for this one right here. Now again, in terms of getting the y values, we're just going to use graphing transformations. Let's go back up. You have this 3 right here. Again, that's a vertical stretch by a factor of 3. And then here you have this 2. So plus 2, that's giving me a shift up by 2. So again, the first thing here, you would multiply by 3. And then the second thing here, this is going to be, we're going to add 2. That's all it is. So multiply by 3 and then add 2. Okay, let me paste this in. So again, remembering your basic points, you're going to put a 1 here. So that's going to get multiplied by 3, and then you're going to add 2. Then you want a 0 here. Multiply by 3, then add 2. Then you want a negative 1 here. Multiply by 3, and then add 2. 1 times 3 is 3. 3 plus 2 is 5. So this is going to be a 5. 0 times 3 is 0, plus 2 is 2. So this is going to be a 2. Negative 1 times 3 is negative 3, plus 2, that's going to be negative 1. So let's grab this, and let's just paste this in maybe right there. And so this point right here, a quarter of the way through, again, you have negative pi over 4 comma 5, so that guy right there. Then halfway through, you have pi over 2 comma 2, so that guy right there. And then 3/4 of the way through, you have 5 pi over 4 comma negative 1, so right there. Again, click the link if you want to get more points on this side or this side. I have them filled out for you on Desmos. All right, let's take a look at problem 9. So here we have f of x is equal to 3 cotangent of 2x minus 5 pi over 6, and then plus 1. Let me slide down here a little bit. Again, I'll just start with the phase shift just to get it out of the way. So f of x is equal to 3 cotangent of. Let me pull out the 2 there. So inside you'd have x minus. Again, if I'm pulling out a 2, I need to think about how could I undo multiplication by 2, because when this comes back in, I'm multiplying by 2. To do that, I want to divide by 2 or multiply by a half. So what you're going to do is say this is 5 pi over 6 times a half. So that's really going to turn into 5 pi over 12. So that's what you want. Close that down, close this down, and then plus 1. Again, we'll just check it. So 2 times x is 2x. Then you have minus and minus. 2 times 5 pi over 12 would be 5 pi over 6. So that is good to go. So when you think about the phase shift, again, you have this minus 5 pi over 12. So I want to undo that. So I want to add 5 pi over 12. So I want to go for the phase shift to the right, 5 pi over 12. That 5 could be a lot better. Now, in terms of the vertical shift, again, it's just this plus 1 over here. So for the vertical shift, we're just going up 1. So very, very easy. Let me just paste this in right there. Again, if you want the period, you're going to take the standard period for cotangent, which is pi, and you would divide it by 2. Again, in this form, it's the coefficient of x. In this form, it's the number outside of the parentheses. So we just want to go for the period that it's pi over 2. And then for the quarter period, again, you're just going to take pi over 2, multiply by a fourth. That is pi over 8. You can erase this form. We don't need it since we're not using horizontal graphing transformations. Let's come down here and put this right there. And now let's find our 2 consecutive vertical asymptotes. So 2x minus 5 pi over 6 is greater than 0 and less than pi. So I just have one fraction and the denominator is 6. Let's multiply everything here by 6. And so you would have 0 times 6, which is still 0, is less than 6 times 2x is 12x. Then minus this right here is going to cancel. So you're going to have 5 pi, which is less than 6 times pi is 6 pi. All right, let's add 5 pi to each part here. And so this is going to cancel. You have 12x is greater than 0 plus 5 pi is 5 pi. We'll say and it's less than 6 pi plus 5 pi is 11 pi. To finish things up and isolate x, what we're going to do is we're going to divide each part here by 12. And so this is going to cancel. So you have x is greater than 5 pi over 12 and less than 11 pi over 12. Okay, we can grab this now and we can paste this in. Let me put a little border here. So the two consecutive vertical asymptotes that we're looking for, let me put v period a period. We're going to have x equals 5 pi over 12. And then we're going to have x is equal to 11 pi over 12. Here's your x equals 5 pi over 12. So you have that guy right there. And then here's your x equals 11 pi over 12. So that guy right there. So we need this point, and this point. So coming back, I'm going to start again with this leftmost vertical asymptote that we found. So 5 pi over 12. And I'm going to add a quarter period. So plus pi over 8. What makes this also time consuming is just dealing with all these fractions and having to get common denominators. You should know at this point that if you're working with 8, which is 2 cubed, and you're working with 12, which is 2 squared times 3, the LCD is 8 times 3, which is 24. So I'm just going to multiply this by 3 over 3 and this by 2 over 2. So this becomes 10 pi over 24 plus 3 pi over 24. So this would give me 13 pi over 24. Now you would keep adding a quarter period. I would just write it as 3 pi over 24. So let me put for the first quarter point, the x value is 13 pi over 24. And then we need halfway and then 3/4. Put that up there. So you're going to keep adding, again, 3 pi over 24. That's just pi over 8 with a common denominator. So this would give me 16 pi over 24. Now, if you want to simplify that, 16 divided by 8 is going to be 2, and 24 divided by 8 is 3. So this would be 2 pi over 3. And then I'm just going to keep it in this form. Let me erase this and move this over here, just so I have a common denominator. And then this would be 16 pi plus 3 pi. That's 19 pi, and then over 24. So this would be 19 pi over 24. So not too bad. Let's go up and figure out what we need to do to y. So for this part right here, you are multiplying 3 by your cotangent function. And so that's giving me a vertical stretch by a factor of 3. So that part's going to be done first. So let's put that we're going to multiply by 3. Then you have your plus 1 here. So that's shifting me up by 1 unit. So that guy would be done second. So we'll say that we're going to add 1. So let's grab this and come back down here. So just remember your basic points, and you're taking the y values. So for this one, it's going to be 1, and then you're just going through this, so times 3, and then plus 1. Here it would be 0, and then again, you'd go times 3, and then plus 1. Here it would be -1, so then times 3, and then plus 1. Okay, we can get rid of this at this point. We don't need it. So 1 times 3 is 3, and then 3 plus 1 is 4. So that right there would be 4. And then 0 times 3 is 0, then plus 1 is 1. So let's put that there. And then -1 times 3 is -3. -3 plus 1 is going to be -2. So this is -2. Let's close that down. And let's take this to the graph and check it. So coming down here, this doesn't show up very well. So let me change the color of the ink, and maybe that'll be a little bit better. So this point, again, hard to read this, but this is for the first quarter point. This is 13 pi over 24, comma 4. Again, 13 pi over 24, comma 4. Halfway, you have 2 pi over 3, comma 1. Again, 2 pi over 3, comma 1. And then 3/4, you have 19 pi over 24, comma -2. Here's your 19 pi over 24, comma -2. Again, you have that link on Desmos if you're having trouble seeing it, or if you want to go to the left or the right by 1 cycle. Those points are already done for you. All right, for problem 10, we have f of x is equal to negative cotangent of x minus pi over 3. So this one's extremely easy to work on. I think it's an example where I would definitely use graphing transformations because it's going to be so fast. So first off, let me just put that the phase shift here. We're just going to have this x minus pi over 3. You don't have to factor anything. So really, I want to undo the minus pi over 3. So I need to add pi over 3. So that means I'm going to go to the right by pi over 3. Then for the vertical shift, you'll notice you don't have anything out here. You could put +0 to make that crystal clear, but this is going to be none. So let's put none. Okay, in terms of figuring out the graphing transformations here, really, all you have to do for y, you just have that -1 that's multiplying the cotangent function. So in terms of y, all you're going to do is multiply by -1. And then for x, all you have to do is add pi over 3 because we have a shift to the right by pi over 3. Add pi over 3. Now, because we're not using that other method, we really don't need the period here, but we did ask for it on the practice test. So remember that the standard period for cotangent is going to be pi. And so because the coefficient here on x is 1, you just keep that standard period. So let me say that the period here, again, just for the practice test because it asked for it, is going to be pi. Now I'm going to leave this here. We don't need it. We're just going to grab this real quick and I'll just come down here and paste this in. So this is all we really need. So just start with the information from the cotangent function. So again, y equals cotangent of x. You have for the vertical asymptotes there, x equals 0 and x equals pi. And then you have the point pi over 4, comma 1. You have the point pi over 2, comma 0. And then you have the point, which is 3 pi over 4, comma negative 1. So all I'm going to do is I'm going to take these x values, and I'm just going to add pi over 3 to each one. So let's start with 0. If I add pi over 3, I would have pi over 3. So for the vertical asymptotes here, you would have x is equal to pi over 3. So let me put and. You would have x is equal to, you would take pi here, and you would add pi over 3. So let me write 3 pi over 3, and then plus pi over 3. So I just took pi, and I wrote it with a common denominator, so I multiplied it by 3 over 3, so that's how I got 3 pi over 3. Then plus your pi over 3 here, that would give me 4 pi over 3. So 4 pi over 3. Coming down, here's your x equals pi over 3, and then here's going to be your x equals 4 pi over 3. So we've got the vertical asymptotes. We just need these 3 points here. And so for those, let me put a little border here, a little border here, like this. I'm going to take pi over 4 here. So let me put first quarter point. So pi over 4, and I'm going to add pi over 3. So this right here, you need a common denominator, and the best you can do is 3 times 4 or 12. So that's going to be your LCD. So let's say this is equal to, you would have 3 pi over 12, just multiplying this by 3 over 3, plus 4 pi over 12, multiplying this by 4 over 4. Let me make that 3 better. So this would end up giving you 7 pi over 12. So that's the x coordinate you're looking for. So this is 7 pi over 12. Now let's go to halfway, and then we also need 3 quarters. All right, so the next one we want to do is pi over 2. And again, all you want to do is add pi over 3. So the LCD there would be 6. So let's say this is 3 pi over 6, just multiplying this by 3 over 3, plus this would be 2 pi over 6, multiplying this by 2 over 2. So that would be 5 pi over 6. Let me get rid of this and just say that this is 5 pi over 6. For the last one, we have 3 pi over 4, and then plus your pi over 3. So again, the LCD there is going to be 12. So this would be, let's multiply this by 3 over 3, so 9 pi over 12. And then plus multiply this by 4 over 4, 4 pi over 12. So this would be 13 pi over 12. Okay, let me get rid of this, and I will write this in as 13 pi over 12, comma, comma, comma. For the y values, again, it's always easier. Here I'm just multiplying by negative 1. So you're just changing the sign of everything. For 0, it's obviously going to stay 0. So 1 times negative 1 is negative 1. 0 times negative 1 is still 0. And then negative 1 times negative 1 is positive 1. So this is what you're looking for the points. So let me paste this in and we can just check this real quick. So for the first quarter point, you're looking at 7 pi over 12 comma negative 1. So there's your 7 pi over 12 comma negative 1. For halfway, you have 5 pi over 6 comma 0. Here's your 5 pi over 6 comma 0. And then for 3 quarters of the way, you have your 13 pi over 12 comma 1. So here's your 13 pi over 12 comma 1. Again, I left you a link on Desmos if you want to get the points over here or over here just to get some additional practice. I already have everything labeled for you. All right, let's take a look at the practice test. For the instructions, we're asked to find the period, phase shift, and vertical shift. Then we want to sketch the graph. All right, before we jump in and look at any problems, I want to give you a quick review of how to graph the secant function. So something like y equals the secant of x. Again, we have this guy graphed in red already. So in the case of the secant function, the reciprocal function is the cosine function. So we're using that as a guide. So y equals the cosine of x. That guy is graphed as a dashed curve because that's what we do with a guide, and it's in green. So when we look at the two graphs together, we can notice a few things. The first thing is that anywhere where the y value is 1, so something like right here at negative 2 pi, right here at 0, right here at 2 pi, there's a shared point. So between the cosine function and the secant function, and that's because, again, if you think about the definition, we have the secant of x is equal to 1 over the cosine of x. Well, if I had a cosine value of 1, 1 over 1 is 1, so the secant value would be 1 as well. And then the same thing is true anywhere where the y value is -1, because 1 over -1 would also be -1. So you have this at -3 pi, again, a y value of -1, and then -pi, and then pi, and then 3 pi, so on and so forth. So those are where you're going to have these shared points. Additionally, you'll notice that anywhere where you have what we call a hill, so this right here would be described as a hill or a maximum on the cosine graph, that's going to give you a local minimum on the secant graph, or you could call that a valley. So a lot of times you'll hear the hills and valleys are interchanged. So that's how I know which direction this guy is going to face for the secant function. This guy is a hill, so this is a valley. This guy is going to be a valley, so this guy is a hill. This guy is a hill, so this is a valley, so on and so forth. Now, the only other thing you really need to know is where to find the vertical asymptotes for your secant function. And this is going to happen here because we don't have any vertical shifts involved, anywhere where the cosine value is 0. So anywhere where you have an x-intercept. So something like pi over 2, we know that one. The cosine of pi over 2 is 0. So you'll notice that on the cosine graph, this is an x-intercept. And let me do that a little bit further down so you can still see that. And then also at 3 pi over 2, the cosine of 3 pi over 2, that's 0. So again, that would be an x-intercept. Why does that give me a vertical asymptote for the secant function? Well, again, it's 1 over the cosine value. And if the cosine value is 0, 1 over 0 is undefined. So you get these vertical asymptotes here and here and here. So odd multiples of pi over 2. One thing I want to call your attention to is that if you look at this over one cycle, so we've graphed this a million times. So let's say we go from 0 to 2 pi. Think about where the x-intercepts occur, because when you get vertical shifts, so shifting up or down, this is no longer going to be done by finding the x-intercepts. You're going to think about what is a quarter of the way through and what is 3/4 of the way through. So if you start here, again, a quarter of the way through, you're going to hit that pi over 2 or the x-intercept. You're going to come down and you're going to come back up. And then 3/4 of the way through, you're going to hit that x-intercept. And then you're going to finish up your cycle. For myself, I always just graph one cycle when I do this. Your teacher may give you a specific interval over which they want you to graph this guy. Just follow that. If you're self-studying, I think just doing one cycle on your own is fine. And then you can just check Desmos. I gave you links for everything and just see what the rest of it looks like. So for something like this, again, you have a shared point here. And I know that this is a hill, so this would be a valley. And I'm just going to draw this part right here. So again, this gets drawn to where it approaches the vertical asymptote, but doesn't touch it. And let's just say this point is about right there. It's not going to be perfect. And let's just say again that this is a valley, so this is going to be a hill. So this right here would approach that vertical asymptote, but not touch it. And the same thing for this. So it's going to approach that vertical asymptote and not touch it. And again, this would be a shared point here. Let's just say it's about right there. Not going to be perfect. And this is a hill, so this would be a valley. So this will approach the vertical asymptote and not touch it. Again, this would be one cycle of the secant graph. This is good enough for me if I'm self-studying, but if you want to do more, of course, you can. All right, for problem 1, we have f of x equals 1/2 secant of x plus pi over 2, and then minus 1. So what I'm going to do is just start off with the basic information that we're asked for. We want to find the period, we want to find the phase shift, and we want to find the vertical shift. So those are pretty easy to do. Now, normally I would factor, but in this case, you'll see that the coefficient of x is 1, so there's no need to factor here. So for the period, it's just going to be the standard period for secant, which is 2 pi. So what you would do here, if you have something that's not 1 for the coefficient, you just take that standard period of 2 pi, and you divide by whatever that is. Then for the phase shift, you're going to go inside the parentheses, and you're going to say, how can I undo what's being done to x? Well, you have this plus pi over 2 here, so that means you're going to the left pi over 2, because I need to subtract away pi over 2 to undo what's being done to x. Then for the vertical shift, you have this minus 1 that's outside here. So I'm just going to say that we're going to go down by 1. Now, once you've done that, what you would want to do is copy this right here, but you want to replace your secant with cosine. So you would say that you have f of x is equal to 1/2, and then cosine of, you're going to have this x plus pi over 2, and then minus 1. We're going to come down here to a little fresh sheet of paper. And again, when you try to graph something like this, there's different approaches you can use. So what a lot of people will do is they'll do the quarter period method. And all that is you start off with the first x value coming from the phase shift. So in other words, we know that this guy right here, we shifted pi over 2 units to the left. So I'll start off with this being negative pi over 2. And then from there, to get the additional x values, you would just add quarter periods. So the period is 2 pi. So a quarter period, let me write this right here. Let me put a little border and put the quarter period is going to be 2 pi over 4, which is pi over 2. You just take this and you keep adding pi over 2. So negative pi over 2, let me write this out. So negative pi over 2 plus pi over 2. So that's going to give me 0. So this right here would be 0. And then you can do 0 plus pi over 2. So this is pi over 2. And then pi over 2 plus pi over 2. So pi over 2 plus pi over 2. That would be 2 pi over 2, which of course is pi. So let me write this as pi. And then to get a common denominator, you could write this as 2 pi over 2 and then plus your pi over 2. And that's 3 pi over 2. So that's basically all you have to do. We have the x coordinates that we're going to work with for this guy right here. Now, let me drag this over a little bit. If you wanted to do this using an alternative approach, let me put a comma in each case, you can of course use graphing transformations for x. So let me put a little border here and let me put for x, the only thing you have to do is subtract away. So we're going to subtract this pi over 2. Now for this one, let me actually move this right here and I'm going to put a little border. This is just an alternative approach. I don't want anybody to get lost, so forget about this for right now. To do it this way, you have to start off with your basic points for the cosine function. So y equals the cosine of x. And so you have your 0, 1, you have your pi over 2, 0, and then you have your pi, negative 1, you have your 3 pi over 2, 0, and then you have your 2 pi, 1. Well, what you're doing is you're taking each x value here, and you're just going to subtract away pi over 2. And you're going to see that it's going to match what we found using the quarter period method. Just some people don't like doing this, and in a lot of cases, it's actually a lot more work. So I'm just going to do this real quick and just show you get the same thing. This is just going to be for the x values, and then I'm going to erase it, and we're going to work on this and get the y values. So when you subtract away pi over 2 from 0, you get negative pi over 2. So that matches. So now I'm working with the x value in each case. So I want to do pi over 2 minus pi over 2. And of course, that's going to give me 0, just like I got there. So the same thing. Then here I have pi minus pi over 2. So again, you could write that as 2 pi over 2. And so 2 pi over 2 minus pi over 2, that would be pi over 2. Again, that matches what we got there. 3 pi over 2 minus pi over 2. Let me write this out. So 3 pi over 2 minus pi over 2. That's going to give me 2 pi over 2, which is just pi. And then the last one, we have 2 pi. So 2 pi, we could write that as 4 pi over 2, and then minus pi over 2, and that's going to be 3 pi over 2. So this right here would be 3 pi over 2. So you can see everything is going to match. The main thing is to understand that if you look at horizontally what's happening, we are just going to have a shift to the left by pi over 2 because of this subtract away pi over 2 to undo what's being done to x. So that's basically it. And actually, we can just keep this and erase this and move this over here because what you do want are those y values here from the original y equals cosine of x to get your y values for this guy right here. Let me write out y. And let's think about what we're doing. We have this 1/2 that's multiplying this guy. So we're going to multiply by 1/2. So we're going to do that first. The second thing is we're going to subtract. So we're going to subtract away 1. Now, when you think about what's happening here, well, you can say that you have a vertical shrink by a factor of 1/2. Or again, some people will say a vertical compression by a factor of 2. It's just different ways to phrase the same thing. You could just think about the fact that each y coordinate is being either multiplied by 1/2 or divided by 2. That's what you want to realize. Then when you subtract away 1, you're shifting down by 1 unit. So what you could do is just take this 1 right here and multiply by 1/2 and then subtract away 1. If you didn't like that, if you don't like going through these steps here, you could always plug in. So you could take this negative pi over 2 right here and plug it in for x there. But notice what's going to happen. You're going to end up with this part right here, so this part right here, being the same as this right here. In other words, negative pi over 2, if I plug that in there, negative pi over 2 plus pi over 2 is 0. The cosine of 0 is 1. So this part right here exactly matches this right here. So that's why you can just shortcut that and say, okay, well, I would have 1 times this 1/2 and then minus 1. That's all you have to do. If you did this, you would have 1 times 1/2. That's going to be 1/2, and then 1/2 minus 1. So 1/2 minus, let's go 2 over 2. Well, that's going to be negative 1/2. So that's going to be the y coordinate there. And that's all it is. So this is negative 1/2. Continuing, if you came down here again, if you plugged in a 0, so 0 goes in right there. 0 plus pi over 2 is pi over 2. The cosine of pi over 2 is 0. So notice that this right here would match this 0 right here. Again, the cosine of pi over 2 is 0. That matches that. So you could shortcut this and just say, since I know the result of this would be 0, I just want to go 1/2 times whatever this is. That's what I'm going to get. So times 0 and then minus 1. 1/2 times 0 is 0. 0 minus 1 is -1. So that's that right there. Close that down. Then let me just do one more of these. If I plugged in a pi over 2 here, pi over 2 plus pi over 2, that's going to be 2 pi over 2. And 2 pi over 2 is pi. So this right here is going to be the cosine of pi, which is -1. Again, it perfectly matches that right there. It's going to every time. So you're going to have 1/2 and then times this -1 and then minus 1. So 1/2 times -1, that's going to be -1/2. So let me write -1/2. And then minus 1 you could write as 2 over 2. So this would be -3/2. Let me erase this and say this is -3/2. Close that down. And then these two can come from these two. So this is 0 here, this was 0 here, so this will end up being -1. And this is 1 here, this was 1 here. This will be -1/2. And that's all you really need to consider when you're getting these points. Again, you can use the quarter period method for x, or you can use graphing transformations. Most students will just rely on the quarter period method. The graphing transformations can get a little bit challenging to both figure out and then also to do, because sometimes it's a little bit more tedious than the quarter period method. In terms of y values, again, I would just use graphing transformations. It's very, very straightforward. So once you have all of these points, you're ready to basically sketch your graph. Let me go ahead and grab this real quick. If you look at what we have here, you have -pi over 2 comma -1/2. So that's that point right there. -pi over 2 comma -1/2. Then you have 0 comma -1. So that right there. You have pi over 2 comma -3/2. You have pi comma -1. And you have 3 pi over 2 comma -1/2. Again, I have a link for you on Desmos if you want to click that. You could see things in more detail if you're having trouble with anything on the screen here. We know that at the start of the cycle, they're going to share a point. So we have that right there. That's also going to happen midway and then also at the end of the cycle. So that's a shared point, a shared point, and a shared point. Now, in terms of this guy right here and this guy right here, I want you to remember that on your basic cosine graph, you have an x-intercept a quarter of the way through and 3/4 of the way through your cycle. So what's going to happen is if you look at a quarter of the way through and 3/4 of the way through here, you're not getting an x-intercept because this has been shifted down by 1 unit, but you're still going to get the vertical asymptotes. And the reason for that is when you plug in for x, let's say you plug in a 0, this right here is a quarter of the way through. So once you go through this, you're going to end up with pi over 2. For this one, when you plug that in, once you go through this, you're going to get the 3 pi over 2. So you're going to get undefined in each case. Let me show you that. So f of, let's say you plug in a 0, you get 1/2 and then secant of. Of course, this would be 0 plus pi over 2 and then minus 1. So 0 plus pi over 2 is pi over 2. So the secant of pi over 2, we know that's undefined. And then if you did the other one, so let me erase this and this. And let's say we did pi. So plug in a pi there and a pi there. Well, now pi plus pi over 2, that's 2 pi over 2 plus pi over 2, that's 3 pi over 2. So you'd end up with a secant of 3 pi over 2. Again, that's undefined. So all you have to do is remember that at a quarter of the way through and 3/4 of the way through, that's where you're going to have your vertical asymptotes. Another thing that a lot of teachers will do is they'll look at this vertical shift here. So this is -1 here. So I've been shifted down by 1 unit. So you could, if you wanted to, draw a new midline at y equals -1, because normally it's y equals 0, but it's been shifted down by 1 unit. So let's say something like that. So let's say this is y equals -1. Again, this is your new midline. So any point that lies on that midline, so 0 comma -1, pi comma -1, so on and so forth, so where the y value is -1, well, the x value for that point is going to be a vertical asymptote for your secant function. Now, once you have all this, you're ready to sketch your graph. If this is a hill or a maximum for the cosine function, this is going to be a valley or a local minimum for the secant function. So this guy right here is going to be drawn to where it approaches. Again, you're going to have a vertical asymptote at x equals 0. It's not drawn, so you're just going to approach the y-axis there. And then this over here, this is a minimum for the cosine graph, so it's going to be a local maximum for the secant graph. So the valley is going to become a hill. So this right here is going to approach your y-axis. Again, that x equals 0 is a vertical asymptote, and then this right here would approach that vertical asymptote there, so that x equals pi. And then over here you have, again, a maximum for cosine, so that's going to be a local minimum for secant. So this is going to approach that x equals pi, so that vertical asymptote, but not touch it. Again, if you're self-studying, feel free to just do one cycle. If you're somebody who's getting an assignment, then just follow what your teacher tells you. They'll generally say that they want to sketch it over a certain interval. All right, for problem 2, you have f of x equals 1/2 secant of 2x minus 2 pi over 3, and then plus 2. I like to factor these. I think it makes it easier to find the phase shift, but again, that's personal preference. So let's go f of x is equal to 1/2, and then secant of, I'm going to pull out the 2. So inside you have x minus pi over 3. Close all this down, and then plus 2. All right, so looking at this, if you want the period, you're going to look at, again, the standard period, which is 2 pi, and you're going to divide by the coefficient of x in unfactored form or the number outside of the parentheses if it's factored. So you'd be dividing by 2. So 2 pi over 2 is going to be pi. You could write out the quarter period. We're going to need that. So that would be pi over 4. That's all it is. Then you have your phase shift and you have your vertical shift. And thinking about the phase shift, again, when you factor it, it's really easy. You're going to come inside the parentheses here. You're going to say, how can I undo what's being done to x? Well, I have minus pi over 3. So to undo that, you need to add pi over 3. So that means I'm going to the right pi over 3. And then for the vertical shift, I have this plus 2 here. So that means I'm going up 2. So at this point, what I'm going to do is just replace secant with cosine and just graph that guy. So f of x equals 1/2, and then cosine of, you have 2 times the quantity x minus pi over 3. And then you have this plus 2 here. And let me paste this in here. You can use the quarter period method to find the x values for this guy right here, or you can use graphing transformations. In this particular instance, the graphing transformations for x are going to take longer, so the quarter period method would be faster. I'm just going to show you the procedure for each, just so you have it, and then on all the future problems, I'll just use the quarter period method because in most cases, it's a little bit faster. So let me just start off by writing y equals the cosine of x, just for reference. So we have our points. So we know that we have 0, 1 to get things started. Then we have pi over 2, 0. Then we have pi, negative 1. Then we have our 3 pi over 2, 0. And then lastly, we have 2 pi, 1. Now, if we think about the quarter period method, we really don't need to worry about any of these x values. We're just going to start with a phase shift. So we know that we're undoing what's being done to x. Again, we're shifting to the right by pi over 3 because we have minus pi over 3. So we need to add pi over 3 to undo that. So you just start with that. So the phase shift would say that I'm going to have pi over 3 there. And then at that point, you're just going to add quarter periods. Don't worry about these x values. You're just adding quarter periods. So the quarter period, as we talked about earlier, is pi over 4. To make your life easier, just multiply this by 3 over 3. So you have a common denominator. So that would be 3 pi over 12. So this one right here, you'd multiply by 4 over 4 temporarily. That would be 4 pi over 12. So 4 pi over 12 plus 3 pi over 12, that is 7 pi over 12. Then 7 pi over 12 plus 3 pi over 12, that is 10 pi over 12. You can simplify that, but don't do it yet. 10 pi over 12 plus 3 pi over 12, that is 13 pi over 12. 13 pi over 12 plus 3 pi over 12, that is 16 pi over 12. Now, get rid of this. You don't need it. And you actually don't need this anymore either. At this point, let me go through and show you how you could have gotten these using graphing transformations with x. And actually, let me simplify this real quick. So if I divide 10 by 2, I'm going to get 5. And 12 divided by 2 is 6. Here, 16 divided by 4 is 4. And 12 divided by 4 is 3. Thinking about what we would do for x if you wanted to go that route, you have to undo things in a reverse order. I always use the saying that if you're typing out a Word document and you hit Control-Z, so you undo something, you're going to undo the last thing that you did. You don't undo the first thing that you did. So if you look at what we have here, again, you would go inside of parentheses first because of the order of operations, you would multiply second. So if I'm undoing that, now this is first and this is second. So how do I undo multiplication by 2? I want to multiply by 1/2. How do I undo subtracting away pi over 3? I want to add pi over 3. So if you think about where this is coming from, I could box this off for a second, and you could just plug in. Let's say I pick something like 7 pi over 12, and I just do this part. So we have 2 times the quantity. Let's go 7 pi over 12, and then minus pi over 3. Let me grab this real quick and go to another page because this is not going to fit. So let me paste this in here just so you can see what's being done. So here you could write this as 2 times 7 pi over 12 minus, multiply this by 4 over 4. This is 4 pi over 12. And so this becomes 2 times, you would have, when you subtract this away, 3 pi over 12. And 3 pi over 12 is pi over 4. So this becomes 2 times pi over 4. So notice that the first thing I did was subtract away pi over 3. Now, the next thing I'm going to do is multiply by 2. So this becomes 2 times pi over 4, which is pi over 2. So notice that I plugged in 7 pi over 12, and I got pi over 2. Let me go back up. So 7 pi over 12, there's pi over 2. But the problem is, I don't know the 7 pi over 12. I'm working with the basic points for cosine. I know pi over 2, and I'm trying to get 7 pi over 12, so I have to go in reverse. In other words, I have to undo what was being done so that I can go from this pi over 2 to the 7 pi over 12. So to do that, you have the multiply by 1/2 and then add pi over 3. Let me come back down. Let me see if I can make that make sense for you. So if you wanted to undo this, in other words, go backwards, you would undo the last thing that was done. So the last thing that was done is we multiplied by 2. Let me put a little border. So to undo that, I need to take this pi over 2, and I need to divide by 2 or multiply by 1/2. So you have pi over 2, and I'm going to multiply by 1/2, and that's going to give me pi over 4. So notice at this point, that puts me back to this pi over 4. So 2 times pi over 4 gave me pi over 2. To undo that, I multiply by 1/2 or divide by 2. That puts me back to this point right here. So going back through, again, to this right here, I need to undo the subtraction now of pi over 3 because that's what's happening right here. I'm taking the 7 pi over 12 and subtracting away pi over 3, which we wrote as 4 pi over 12. So in the second step, you're going to say that you have this pi over 4, and I'm going to add this pi over 3 that was subtracted away. And so this becomes 3 pi over 12 plus 4 pi over 12, just getting a common denominator. And that gets me back to the 7 pi over 12. So that's this right here that I was plugging in for x when I started. So when you undo things, you have to go in the reverse order. So just keep that in mind. So coming back up, again, you see that 7 pi over 12. So I know the first time you see that, it might not make a whole lot of sense, but what I would suggest is just stop the video here and go through with each one of these guys and plug in and write down the steps, then go in the reverse order. So you're going to see how these guys are related. You'll be able to say, okay, if I'm starting with pi and I multiply by 1/2 and then add pi over 3, I'm going to get the 5 pi over 6. If I start with 3 pi over 2 and I multiply by 1/2 and then add pi over 3, I'm going to get the 13 pi over 12, so on and so forth. So now that that's out of the way, let's just do the y. And I know a lot of you find the y values, getting those a lot easier because it's very straightforward. So in this particular case, again, all I'm doing is I'm multiplying by 1/2. So I'm going to multiply by 1/2, and then I'm going to add 2. So very, very straightforward. This right here is going to give me a vertical compression by a factor of 2, or again, you could say a vertical shrink by a factor of 1/2, whatever you want to say there. You're just taking the y coordinate and dividing by 2 or multiplying by 1/2. Then when we add 2, we're just shifting up by 2 units. Again, if you were to plug in pi over 3 minus pi over 3 is 0, 2 times 0 is 0, the cosine of 0 is 1. So it just matches this. So all you have to do is just take that y coordinate, that's what you're going to get anyway, and just say, okay, it's 1/2 times whatever that is. In this case, it's 1, and then plus 2. So just following the order of operations, multiply by 1/2, and then add 2. So this would be 1/2 plus 2. So you could say that it's 1/2 plus 4 over 2. So that is 5/2. Let me erase this and put this in as 5/2. This right here, 0 times anything is 0. So you can just say that you're just going to add 2. So this is 2 right here. And then -1 times 1/2 is -1/2. And then let's add 4 over 2. So this would be 3/2. And then for the rest of them, you can just copy. So for 0, we know that's going to be 2. And then for 1, we know that's going to be 5/2. That's basically it. So let's go ahead and grab this. So going through these points, again, they're tough to see because of the scale of things. You just click the link on Desmos to follow more closely. You have this pi over 3 comma 5/2. You have this 7 pi over 12 comma 2. You have this 5 pi over 6 comma 3/2. You have the 13 pi over 12 comma 2. And then the 4 pi over 3 comma 5/2. So I'm just going to erase this real quick. We know that the start of the cycle, you're going to have a shared point. We know that that also occurs at the middle and then at the end. So those are shared points on both graphs. When you look at a quarter of the way through and 3/4 of the way through, again, that's where you're going to have your vertical asymptotes for the secant function. So here that's going to happen at x equals 7 pi over 12 and x equals 13 pi over 12. If you're not comfortable with that or you can't remember it, remember you can always use this plus 2 here, this vertical shift, to give yourself a new midline. So what you could do is draw this in right here and say this is y is equal to 2. So any point that intersects that line y equals 2, so the y value is 2, well, that's where you're going to have a secant value that's undefined, and so you're going to get vertical asymptotes there. In other words, if I plugged in a 7 pi over 12, you can do that real quick if you want. So the secant of, you have this 2 times 7 pi over 12, and then minus 2 pi over 3, close that down, you're going to see that this right here, once you evaluate, once you go through this, you're going to have pi over 2. So let's just do that real quick so this is crystal clear. This cancels with this and gives you a 6. And this you can multiply by 2 over 2. So what would that give you? It would give you the secant of, you would have 7 pi over 6 minus, this would be 4 pi over 6. So this would be the secant of, you would have 7 pi minus 4 pi, that's 3 pi. So what is 3 pi over 6? That's pi over 2. So this part right here is going to be undefined, so you're going to get a vertical asymptote. I'll let you do the other one on your own. Again, if you plug in a 13 pi over 12 and you go through the steps, you're going to end up with 3 pi over 2. So the secant of 3 pi over 2 is going to be undefined. So let me get rid of that, just so we know what's going on. So I'm going to draw this to where it approaches that vertical asymptote. And it's not supposed to touch it, but I might go over a little bit. And this right here, again, it's going to approach the vertical asymptote and not touch it. I'll get as close as I can. This would approach the vertical asymptote and not touch it. And I went over a little bit there. And then this one would approach the vertical asymptote and not touch it. All right, let's take a look at problem 3. So we have f of x equals 3 secant of x over 3 plus 7 pi over 4 plus 1. I would, again, factor this. It just makes it easier. So let's say that we're going to pull out a 1/3 here. So this is out in front of some parentheses. So you have your x plus. What goes here? Well, how do I undo multiplication by a third? Well, I need to multiply by 3. So 7 pi over 4 times 3 would be 21 pi over 4. And so now it's very easy to get the phase shift. Let me start off with a period. So the period here is going to be 2 pi, the standard period for secant, divided by 1/3. So that's 2 pi times 3, which is 6 pi. Then you have your phase shift. And then all I'm going to do for that is come inside the parentheses here and say, how do I undo this? Adding 21 pi over 4, we need to subtract away 21 pi over 4. So that means I'm going to the left, 21 pi over 4. And then for the vertical shift, you have this plus 1 here. So I'm just going up 1. So all you have to do, let me just copy this and come down to a fresh sheet. You're just going to erase this and just write in cosine, and you're going to graph that. Now, again, you could use graphing transformations, but again, in terms of x, it's a little bit slower in this case, and I know a lot of you get confused by it, so you might want to work on that a little bit on your own if you need to. I'm just going to use the quarter period method just to speed this up a little bit. So what I'm going to do is write out y equals the cosine of x, and we'll say that we have a point which is 0, 1. We have a point which is pi over 2, 0. We have a point which is pi, -1. We have the 3 pi over 2, 0, and then we have 2 pi, 1. So we know these points already, and all we're going to do is think about, first, what is the phase shift? So the phase shift is minus 21 pi over 4. So that's going to be your first x-coordinate, so negative 21 pi over 4. And then to get the next ones, you're just going to go through and add quarter periods. That's all you need to do. Nothing complicated. We know the period was 6 pi, so the quarter period here is going to be 6 pi over 4. Now you could simplify that and say it's 3 pi over 2, but notice that you want to keep it this way so you have a common denominator. Negative 21 pi over 4 plus 6 pi over 4, that would be negative 15 pi over 4. And then negative 15 pi over 4 plus 6 pi over 4, that is negative 9 pi over 4. Then negative 9 pi over 4 plus 6 pi over 4, that is negative 3 pi over 4. Then negative 3 pi over 4 plus 6 pi over 4, that is 3 pi over 4. So now we have the x values. We want to get the y values. Again, you can use the plug-in method, but just realize that if you plug in something like negative 21 pi over 4 for x right there, well, this right here is going to end up being this right here. Negative 21 pi over 4 plus 21 pi over 4, that's 0. 1/3 times 0 is still 0. Cosine of 0 is 1. So the shortcut here is just to say that I'm going to multiply by 3, so 3 times whatever this y coordinate is, and then add 1. That's all it is. So 3 times 1 is 3, plus 1 is 4. So this would be 4. Then for this one, 0 times 3 is 0, then plus 1 is 1. And then for this one, negative 1 times 3, and then plus 1. So negative 1 times 3 is negative 3. Negative 3 plus 1 is negative 2. So this is negative 2. And then for this one, we're going to copy. So this is 1. And then for this one, we're going to copy. So this is 4. Okay, let me grab this and let me paste this in here. So you have this negative 21 pi over 4 comma 4. So that's going to be something that's shared. Then you have negative 15 pi over 4 comma 1. That's going to be this point right here. Again, the x value there would be a vertical asymptote because this is a quarter of the way through. Then you have this negative 9 pi over 4 comma negative 2. So again, that's a shared point. Then you have this negative 3 pi over 4 comma 1. So again, that's where you're going to have a vertical asymptote. So at that x value there at negative 3 pi over 4 for the secant function, you're 3/4 of the way through. And then here you have 3 pi over 4 comma 4. So again, that's going to be a shared point. Let me get rid of this. And again, once you know where the vertical asymptotes are and you sketch that guy, so again at negative 15 pi over 4 and negative 3 pi over 4, where then you're just considering, okay, well, this is going to be a hill, so here this is a valley. This is going to be a valley, so this is a hill. This is going to be a hill, so this is a valley. So I know that I can draw this guy right here, again, to where it approaches the vertical asymptote, but doesn't touch it. And this piece right here is going to approach the vertical asymptote and not touch it. And then the same thing here, approach but not touch. And then this one right here, we're going to approach the vertical asymptote but not touch it. All right, let's take a look at problem 4. So here we have f of x equals 3 secant of x over 2 plus pi over 3 and then minus 2. So again, I'm just going to factor this just to make finding the phase shift easier. So f of x equals, we have our 3, and then we have secant of. Let me pull out a 1/2 here. And then inside you'd have your x plus, how do I undo multiplication by a half? You need to multiply by 2. So you'd have 2 times pi over 3, which is 2 pi over 3. And then we'd have minus 2 here. So just sliding down, we just want the basic information. So what is the period here? And that's going to be the standard period, which is 2 pi divided by 1/2. So that's going to be 4 pi. What is the phase shift? Looking at the inside here, how do I undo what's being done to x? Well, I have plus 2 pi over 3. So to undo that, I need to subtract away 2 pi over 3. So this is left 2 pi over 3. And then for the vertical shift, we have this minus 2 here. So that means I'm going down 2. That's all it is. So all I'm going to do here is just, again, copy this. Let me go f of x is equal to 3. Instead of secant, let's write cosine, and then we'll copy the rest. So you have this 1/2 times the quantity x plus 2 pi over 3, and then you have the minus 2. Okay, let's grab this, come down here and paste this in. Let me write out, once again, y equals the cosine of x. You have your 0, 1. You have the pi over 2, 0. You have, let me make this better here. So pi over 2. And then you have pi, negative 1. Let me make that better. And then you have 3 pi over 2, 0. And then lastly, you have your 2 pi, 1. Okay, so for the first thing, we're going to just use the phase shift. Again, you have minus 2 pi over 3 here to undo what's being done to x. So this is minus 2 pi over 3. I'm going to the left by 2 pi over 3. To get the next x value, you're going to add a quarter period. The period was 4 pi, so a quarter period is pi. So a quarter period is going to be pi. You might as well say it's 3 pi over 3. So negative 2 pi over 3 plus 3 pi over 3, that would give me pi over 3. Let me make this better here. And then you're just going to keep adding quarter periods. So pi over 3 plus 3 pi over 3, that is 4 pi over 3. And then 4 pi over 3 plus 3 pi over 3, that is 7 pi over 3. And make these better here. And then this one right here, 7 pi over 3 plus 3 pi over 3, that is 10 pi over 3. Okay, so we have the x values that we need now, and we just want to get the y values. Again, all you have to do is think about the fact that if you plug this in here, so negative 2 pi over 3 plus 2 pi over 3, that's 0. 1/2 times 0 is 0. Cosine of 0 is 1. So it just matches that. So all you have to do is take this and say I'm going to multiply by 3 first and then subtract away 2. So in other words, you'd have 3 times 1 and then minus 2. Then here, you'd have 3 times the y value is 0, then minus 2. Then here, you'd have 3 times the y value is negative 1, then minus 2. So this is 3 times 1, that's 3, then minus 2, that's 1. So this is 1. 3 times 0 is 0, minus 2 is negative 2, so negative 2. 3 times negative 1 is negative 3, then negative 3 minus 2 is negative 5. So this is negative 5. Let's close all this down. Again, for these you can copy. So for 0, it's going to be negative 2. And then for 1, it's going to be 1. So grab this and just go through this with me real quick. You have negative 2 pi over 3 comma 1. Again, that's a shared point. Then you have a quarter of the way through pi over 3 comma negative 2. So the x value here, that's going to be a vertical asymptote for your secant function when you draw it. Again, if you plugged in a pi over 3, you went through the stuff there, you're going to end up with a secant of pi over 2, and the secant of pi over 2 is undefined. So you'd have a vertical asymptote right here at pi over 3. Then you have 4 pi over 3 comma negative 5, so it's going to be this right here. That's going to be a shared point. Then this guy right here, again, that's 3/4 of the way through. You can have another vertical asymptote there. If you took that x value, that 7 pi over 3, and you plugged it in, you'd end up with a secant of 3 pi over 2, and so that's undefined. So that's your vertical asymptote there at x equals 7 pi over 3. Then this point right here to finish up the cycle is 10 pi over 3 comma 1. Again, that's a shared point. So let me get rid of this, and we can just sketch this guy real quick. So we know that, again, this is a hill, so this is a valley. This is a valley, so this is a hill. And then this is a hill, so this is a valley. So I'm just going to sketch this to where it approaches the vertical asymptote, but doesn't touch it. Same thing here. Approach, but not touch it. So that right there. And then we'll do this one right here. So approach, but not touch it. All right, for problem 5, we have f of x equals 2, secant of x over 2, minus 3 pi over 4, then plus 1. Slide down a little bit. Let's write f of x is equal to 2 secant of, let me pull out the 1/2 there. So inside you have x minus, again, I'm just going to multiply this by 2. So 3 pi over 4, let me show this. 3 pi over 4 times 2. This would cancel with this and give me a 2 down there. So this is 3 pi over 2. And then we can just close this stuff down, and you have the plus 1 there. Okay, so looking at the period, this is the first thing we want to know. You're going to have 2 pi divided by 1/2, so that's 4 pi. Looking at the phase shift, we know that we have this minus 3 pi over 2. So I'm just going to add 3 pi over 2 to undo that. And so that's going to give me a shift to the right. So to the right, 3 pi over 2. Then the vertical shift here, you have this plus 1. So I'm just going up 1. Let me bring this over here and erase this and this. I'm going to erase the secant and just put in cosine. And again, I just write out the basic points so we have them. Y equals the cosine of x. We'll have the 0, 1. We'll have the pi over 2, 0. We'll have pi, negative 1. We have 3 pi over 2, 0. And then you have 2 pi, 1. So looking at, again, the phase shift, we know that we went to the right by 3 pi over 2. So we're just going to start off with that. We're going to say that this is going to be 3 pi over 2. And then from there, you're just going to add quarter periods. Now the period was 4 pi. So a quarter period is pi. So let me write out that the quarter period, again, you could write pi as 2 pi over 2. So you have a common denominator. And so you're just going to go through and say 3 pi over 2 plus 2 pi over 2, that's 5 pi over 2. Then 5 pi over 2 plus 2 pi over 2, that's 7 pi over 2. Then 7 pi over 2 plus 2 pi over 2, that's 9 pi over 2. And then 9 pi over 2 plus 2 pi over 2, that's 11 pi over 2. So we've got the x values, and now we want the y values. Again, if I plug in a 3 pi over 2 here, 3 pi over 2 minus 3 pi over 2 is 0. 1/2 times 0 is 0. Cosine of 0 is 1. So all I have to do, instead of going through that, is just say, okay, I have that y value there. I'm going to end up multiplying it by 2 and then adding 1. So I'm going to say that this is 2 times 1 plus 1. I'm going to say that this is 2 times 0 and then plus 1. I'm going to say this is 2 times negative 1 and then plus 1. So 2 times 1 is 2, plus 1 is 3. So this is going to be 3, and then this down here would be 3 as well. You can just do that now. 2 times 0 is 0, plus 1 is 1. So let's say this is 1, and then this right here would be 1 as well. 2 times negative 1 is negative 2, and negative 2 plus 1 is negative 1. So this is what we want here. So again, looking at the start of the cycle, you have the 3 pi over 2, 3. That's a shared point. Quarter of the way through, you have 5 pi over 2, 1. Again, this right here, this x value, you're going to get a vertical asymptote there for the secant function. If you plugged in 5 pi over 2 for x, you're going to end up with the secant of pi over 2. So that's what this is going to turn into, and the secant of pi over 2 is undefined. So you get a vertical asymptote there at x equals 5 pi over 2. Then you get 7 pi over 2, negative 1. That's a shared point. Then you get to the 3/4 of the way through. Again, the x value there, that 9 pi over 2, well, that's going to give me, if I plugged it in for x there, you'd have the secant of 3 pi over 2. That's undefined. So you get a vertical asymptote there. And then if you get to the end of the cycle here, we're going to have 11 pi over 2, 3. So again, this is a hill, becomes a valley. This is a valley, becomes a hill. This is a hill, becomes a valley. So this would be drawn to approach that vertical asymptote. And then the same thing for this. This is going to approach that vertical asymptote. And I'll do that this way as well. And then this guy right there. All right, let's take a look at the cosecant function now. So again, here's where we have this red graph. That's your cosecant graph. And you're using the sine function as a guide here. So that's going to be this guy in green, this dashed curve. So think about what we know about the sine function. Let's just go from 0 to 2 pi. So here's 0 and here's 2 pi. You know you have an x-intercept at the start, at the middle, so that's going to be at pi, and at the end, that's 2 pi. So 0, pi, 2 pi. Beginning, middle, and end. So remember that. You have x-intercepts there. If you have an x-intercept, remember something like the sine of 0 is 0. The sine of pi is 0. The sine of 2 pi is 0. Well, if the sine value is 0, then the cosecant value is undefined. Because again, the cosecant of x is equal to 1 over the sine of x. So you'd have 1 over 0, which is undefined. So at 0, pi, 2 pi, 3 pi, so on and so forth, you're going to end up with these vertical asymptotes for the cosecant function. Now thinking about the other guys, so if you're at the quarter of the way and 3/4 of the way, that's going to be a shared point. So something like pi over 2 and then 3 pi over 2, those x values lead to a shared point. This is pi over 2 comma 1. This is 3 pi over 2 comma negative 1. So when you draw this, just keep that in mind when you have this guide function that you're making. So there's one cycle. At the beginning, you'd have a vertical asymptote. Again, because of the y-axis, I'm not showing it. You could put it there. It's not wrong, but you don't need it. Then you have your shared point at 1/4 of the way through. At halfway, you're going to have a vertical asymptote. At 3/4 of the way, you have the shared point. And then at the end of the cycle, you have a vertical asymptote. Again, notice that when you look at this guy, your maximum point on the sine graph is going to give you a local minimum on the cosecant graph. And then notice that your minimum point on the sine graph is going to be a local maximum on the cosecant graph. So the hill becomes a valley, and then the valley becomes a hill. So for this one, again, you could just draw it like this to where it approaches your vertical asymptote. It doesn't touch it on each side there. And then you can do it like that and like that. And that's really all you need to do to graph one cycle. All right, let's take a look at problem 6. Here we have f of x equals 2, cosecant of x over 2 plus pi over 6 plus 1. All right, let me slide down a little bit. And again, I'm just going to factor this. So f of x is equal to 2 cosecant of, pull out the 1/2. Inside you have x plus, I'm going to multiply this by 2. Let me show this so nobody's lost. So pi over 6 times 2. This would cancel with this and give me a 3 down there. So this is pi over 3. And then once we close all this down, we'll put plus 1. So looking at our period, again, the standard period for cosecant is 2 pi. So you just want 2 pi divided by 1/2, which is 4 pi. Then for the phase shift, we're going to think about how do I undo what's being done to x inside the parentheses there. So we have plus pi over 3. To undo that, I want minus pi over 3. That means I'm going to go to the left pi over 3. And then for the vertical shift, we're going to think about this plus 1 right here. So we're going to go up 1. Let me copy this real quick. I'm going to try to write it as small as I can. So f of x is equal to 2. Instead of cosecant, let's write sine. And then I'll keep it in factored form. Again, if you want to use graphing transformations for x, if you don't, then it doesn't matter. So we're going to keep this factored. So x plus pi over 3 is on the inside. And then close this down and then plus 1. So just on this first one here, I'll show you the graphing transformations approach just so you get another one where you have some practice. But typically you would use a quarter period method. It's going to be faster. Let me just do that first. So y equals the sine of x. You have those basic points. So 0, 0. You're going to have pi over 2, 1. Then you're going to have pi, 0. You have 3 pi over 2, negative 1. And then you have 2 pi, 0. So here, the beginning, the middle, and the end, remember that you're going to have vertical asymptotes there on the cosecant graph because you have an x-intercept on the sine graph. And when we get to this one, because of the plus 1 here, it's not going to work out quite the same way. It's going to be where you have a y value of 1, and I'll show you that when you get to the graph. So first, quarter period method. Again, you would start with the phase shift. So it's minus pi over 3. So just minus pi over 3. That's all you have to do. And then you're just going to keep adding quarter periods. So we know the period here was 4 pi. So the quarter period would just be pi. And of course, to get a common denominator, you could really write this as 3 pi over 3. So negative pi over 3 plus 3 pi over 3. That's 2 pi over 3. And then you just keep doing that. That's all it is. So 2 pi over 3 plus 3 pi over 3, that's 5 pi over 3. And then 5 pi over 3 plus 3 pi over 3, that's 8 pi over 3. And then 8 pi over 3 plus 3 pi over 3, that's 11 pi over 3. Okay, so just in case you want to see it, if not, you can just skip ahead. If you wanted to do graphing transformations for x, again, you want to undo what's being done to x. Again, if I plug this in and I go through the operations, I'm going to end up with 0. Negative pi over 3 plus pi over 3, that's 0. 1/2 times 0 is 0. If I plug this in, 2 pi over 3. 2 pi over 3 plus pi over 3. Again, we can do that real quick. That's pretty easy. So 2 pi over 3 plus pi over 3, that's 3 pi over 3, so that's pi. And then pi times 1/2 would be pi over 2. So all I want to do is reverse that because I don't know the 2 pi over 3. I know the pi over 2. So I've got to go in the reverse order. So what I did first here will be last. So this will be done second, and this will be done first. Got to go in the reverse order, and you have to undo stuff. How do I undo multiplying by 1/2? I need to multiply by 2. How do I undo adding pi over 3? I need to subtract pi over 3. So in other words, for this one, it's pretty simple. 0 times 2 would still be 0. Subtract away pi over 3, you have negative pi over 3. For this one, for pi over 2, you'd multiply by 2. Let me write this out. So pi over 2 times 2, that would just be pi. And then at that point, you'd have pi minus pi over 3. So you could say this is 3 pi over 3 minus pi over 3. That's 2 pi over 3. So again, that's another way to get these x values here. It does take a little bit longer. Now, your teacher might ask you for a description of the transformations, right? So in this case, you're multiplying by 2. That's giving me a horizontal stretch by a factor of 2. And you're subtracting pi over 3. So that means I'm shifting to the left by pi over 3. Okay, let me get rid of this. You can do the rest of them on your own if you want. I'll just stick with the quarter period method from here on out. And then in terms of getting the y values, again, it's very straightforward because if I plug this in, I know that the result of this is going to be this. So to shortcut the process, I can just say, well, it's 2 times whatever this is, so times 0, then plus 1. Again, to write this out, just for this one, so for y, the first thing is you're multiplying by 2. Then the second thing is you're going to add 1. So all you're doing is you're getting a vertical stretch by a factor of 2 and then a shift up by 1. That's all it is. So get rid of this. So for this one, it would be 1. So let's go 2 times 1 plus 1. This one is a duplicate, so we just need to do this one. So we're going to go 2 times negative 1 plus 1. So 2 times 0 is 0, plus 1 is 1. So this right here is 1. Then this one, 2 times 1 is 2, plus 1 is 3. So that is 3. Then this one, again, you could just copy from this one, so that's 1, and you could do that here, that's 1. 2 times negative 1 is negative 2, and then negative 2 plus 1 is negative 1. So this is negative 1. Now, what you want to focus on here is the fact that at the beginning, the middle, and the end, that's where you take those x values, and you're going to have vertical asymptotes when you draw the cosecant function. Let me grab this real quick, and let me bring this over here. So again, just looking at the points on the sine graph, you have negative pi over 3 comma 1, so that's this right here. You have 2 pi over 3 comma 3, that's this right here. Then you have your 5 pi over 3 comma 1, that's this right here. 8 pi over 3 comma negative 1, that's this right here. And then 11 pi over 3 comma 1, so that's that right there. Again, when you think about the beginning, the middle, and the end, so those guys right there, you take the x value, so in this case, it's negative pi over 3, you'd have a vertical asymptote. Here it's 5 pi over 3, you'd have a vertical asymptote. Here it's 11 pi over 3, you'd have a vertical asymptote. You could just plug this in and figure that out. So it's not in factored form here, but we can just do it real quick. So we have negative pi over 3. You'd have divided by 2, so let's just multiply by 1/2. And then you have plus pi over 6. Well, obviously this right here, this negative pi over 3 times 1/2, that would be negative pi over 6. Negative pi over 6 plus pi over 6 is 0. The cosecant of 0 is going to be undefined because the sine of 0 is 0. Again, the same thing would happen when you get right here. You plug in 5 pi over 3 and you do these operations, you're going to end up with the cosecant of pi in that case. And then when you get here at 11 pi over 3, again, you plug it in and do the operations, you're going to end up with the cosecant of 2 pi. So in each case, that would be undefined. So you get a vertical asymptote there. So we know where that's coming from here, here, and here. A lot of teachers do this instead. They say, okay, you have this plus 1 here. So the new midline would be y equals 1. So let me draw that in there. Not perfect, but good enough. So this is y equals 1. So another way to do this is, well, everywhere where I have a point where the y value is 1, so it hits that line, you're going to have a vertical asymptote. If you kept moving this way, you'd see you get that at negative 7 pi over 3. So in that guide function, the sine function, you would have negative 7 pi over 3, comma 1. You'd have negative 13 pi over 3, comma 1, so on and so forth. So you're getting vertical asymptotes at those x values. Let me get rid of this. You can draw it in on your graph if you want. And then basically, once you have this, Remember that the hills and the valleys are interchanged. So I know this guy is going to go up and this guy is going to go down. So all I have to do is take that shared point and say, okay, I'm going to sketch this to where it approaches the vertical asymptote, and then the same thing over here. So approaches the vertical asymptote, and then this guy right here, this is going to face down. So we're going to approach the vertical asymptote and then approach the vertical asymptote. And that's basically it if you just want to do one cycle. If you want to keep going to the left or the right, that's up to you. But typically for self-study, I would just say do one cycle. All right, let's take a look at problem 7. So here we have f of x equals 3, cosecant of x over 2 plus 1. So this one right here is actually ideal for using graphing transformations for x, because if you notice, you just have that 1/2 that's multiplying x, so it's really easy to deal with that. So let me just write out, you don't need to really factor this. You can just put f of x is equal to 3. I'm going to just write the sine of, let me just write 1/2 x right now, and then plus 1. That way we have it. I'm just going to grab it real quick, come down here, and paste this in. We'll come back to this in a second. Let me come back up here. Let me just get the basic information going. So for the period, you're just going to take that 1/2, the coefficient of x there, and you're going to take 2 pi and divide it by that. 2 pi divided by 1/2 is going to be 4 pi. There is no phase shift. So the phase shift, you could just put none, right? Because you just have 1/2 that's multiplying x. You don't have some plus some number or minus some number. It's just 1/2 that's multiplying x. So really you're just getting a horizontal stretch by a factor of 2. And I'll show you that in more detail in a moment. For the vertical shift, you do have one of those. Let me make this better here. So for that, you have this plus 1 right here. So you're just going to go up 1. Let me just write out y equals the sine of x. Hopefully you know these points at this time, but let me go 0, 0. Let me go pi over 2, 1. Let me go pi, 0 again. And then we have 3 pi over 2, negative 1. Let me move this up a little bit so it fits like that. And then we're going to finish up with 2 pi, 0. Again, x-intercept, x-intercept, x-intercept. That's what you want to remember. So if you just wanted to use graphing transformations here for x, all you really have is the 1/2 that's multiplying x. So to undo that, you just need to multiply by 2. That's why you're getting the horizontal stretch by a factor of 2. So all you'd have to do is come in here and multiply each x value by 2. That's all. So 0 times 2 is still 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. 2 pi times 2 is 4 pi. That's all you're doing. Now, if you wanted to use the quarter period method, you could. The phase shift is none, so you'd start with 0. And then at that point, you would just add quarter periods. Well, what is the period? The period is 4 pi. What's a quarter period? 4 pi over 4, which is pi. Notice that if I start at 0 and I add pi, I get to pi. Add pi, I'm at 2 pi. Add pi, I'm at 3 pi. Add pi, I'm at 4 pi. So either way you do it, it's going to be the same amount of time. In this particular case, I would say it would be faster to use the graphing transformations because you just multiply your x coordinate by 2 in each case to get the new x coordinate. That's basically all you have to do. All right, for the y values, again, you would multiply by 3 first, then add 1. So you would do 3 times 0 plus 1. Then you do 3 times 1 plus 1. Then this one is a repeat. You'd have 3 times negative 1 plus 1. So here, 0 times anything is 0, so it's just plus 1, which is 1. Here, 3 times 1 is 3, plus 1 is 4. And then this is a repeat. This would be 1, and this is 1. That's a repeat. And that comma should be moved down here. And then 3 times negative 1, that's going to be negative 3. And then negative 3 plus 1, that's negative 2. So this is negative 2. And now we have our points. So let me grab this. And let me just paste this in. Again, just going through these points, here is your 0, 1. Here's your pi, 4. Here's your 2 pi, 1. Here's the 3 pi, negative 2. And here's the 4 pi, 1. Again, when you think about the beginning, the middle, and the end, again, if I plugged in a 0, well, 0 over 2 is 0. Cosecant of 0 is undefined. If I plugged in a 2 pi divided by 2 is pi. So I'm right back to that pi, and we know the cosecant of pi is undefined. 4 pi, if I plug that in, 4 pi divided by 2, that's 2 pi. We know the cosecant of 2 pi is undefined. So at those x values at the beginning, the middle, and the end, I'm going to have vertical asymptotes. Again, if it's on the y-axis, don't worry about it. You don't have to put it in. You can if you want, but I wouldn't put it in. You have something to where you can approach, right? You just need that as a guide. Now, when we think about the other way to do it, again, you could have drawn a horizontal line, y equals 1. So anywhere where the y value is 1, that's where the x value is going to be undefined for the cosecant function, so you could do it like that to get the vertical asymptotes. Now the point right here, which is pi comma 4, that's at the quarter of the way through. That's a shared point. And then the point right here, which is 3/4 of the way, that's 3 pi comma -2, that's going to be a shared point as well. So to graph this, again, this is just going to approach the vertical asymptote. Again, I know it's not shown there, but x equals 0 would be a vertical asymptote. You're just going to approach the y-axis in that case. Same thing for this. You're going to approach that vertical asymptote, and then this guy right here is going to be drawn this way, and this right here is drawn this way. Again, I know that this goes up because this right here is a hill, so this would be a valley. I know that this goes down because this right here is a valley, so this would be a hill. So that's all you really need to know. All right, for problem 8, we have f of x equals 2, cosecant of 2x plus pi over 2, and then minus 2. So let me slide down here a little bit, and let me write f of x is equal to 2 cosecant of, let me pull out the 2, and then inside I would have x plus, how do I undo multiplication by 2? Well, I can multiply by half, so pi over 2 times a half would be pi over 4. Close that down, close this down, then minus 2. And then if we want to get the basic information, so what is the period here? The period is 2 pi divided by 2, so that's going to be pi. Then for the phase shift, I'm going to look at this inside. How do I undo what's being done to x? Well, I want to subtract away pi over 4 because here it's x plus pi over 4. So that means I want to go to the left, pi over 4. For the vertical shift, I want to go down by 2 because I have that minus 2. So down 2. Let me just copy this real quick. I'm going to try to make it smaller. So f of x is equal to 2. Instead of cosecant, let's write sine. And then we'll keep this in factor form. If you want to use graphing transformations, I'm not going to do it on this one. I'm just going to use the quarter period method because it's a little bit faster. So let me write y equals the sine of x. Let me go through our points again. So I think all of you have memorized them at this time. So we have 0, 0. We have our pi over 2, 1. Then we have pi, 0. Then we have 3 pi over 2, -1. This 3 could be a lot better there. And then lastly, we have 2 pi, 0. So you have your x-intercept at the beginning, the middle, and the end. That's very important to remember. So thinking about a way to do this, again, you could use graphing transformations if you want for x. You think about how to undo things. Well, you'd want to multiply by a half first to undo this one, and then you'd want to subtract away pi over 4 to undo this one. You go in the reverse order. This would be 1, this would be 2. But I'm not going to do that here because, again, that's very time consuming. To go quicker, if you want to use the quarter period method, what you would do is you would say, well, first I'm going to do my phase shift. So I'm just going to subtract away pi over 4. So this is minus pi over 4. And then at that point, you'd want to use the quarter period and just keep adding that. So what is the period? We know that's pi. So the quarter period is pi over 4. So negative pi over 4 plus pi over 4, that's going to be 0. 0 plus pi over 4, that's pi over 4. Pi over 4 plus pi over 4, that is pi over 2. But you could write that as 2 pi over 4 so that you can say 2 pi over 4 plus pi over 4. Well, that's going to be 3 pi over 4. Now, in terms of the y value, again, that's the easy one to get. If you plug in negative pi over 4 here, well, notice you put that in for x, negative pi over 4 plus pi over 4, that's 0. 0 times 2 is 0. So you would end up with the sine of 0. So remember, you're just plugging this in. You're going to end up with this right here at the end of the day right there. So the sine of 0 is 0. So the shortcut here is just to say that I have 2 times 0 minus 2. Multiplying by 2 first, then subtracting away 2 second. If you looked at this one, if you plugged in a 0 and you went through, 0 plus pi over 4 is pi over 4. Pi over 4 times 2 is pi over 2. So notice you're getting this. You want sine of whatever this is, and that's going to give you 1. So to shortcut this, I know this right here at the end is going to be this right here. So I'm just going to say that this is going to be 2 times 1 minus 2. You could skip this one because it's a duplicate. For -1, again, the process would be 2 times -1, then minus 2. So 2 times 0 is 0, and then 0 minus 2 is -2. So this is -2, and then you would copy that for this one, and then this one. And then 2 times 1 is 2, minus 2 is 0. So this is 0. And then for this one, 2 times -1 is -2, and -2 minus 2 is -4. Okay, so we have what we need now. Let me grab this real quick. And this one's really hard to see, so you might want to click that link on Desmos. I think it's going to be something you probably need to do because this is very, very small. It's hard for me to even see, and I'm looking straight at it. So this point right here is negative pi over 4 comma negative 2. So it's just coming from there. Maybe I'll actually arrow to that so that is crystal clear. So this is negative pi over 4 comma negative 2, just so you can see it in case you don't have access to Desmos. This point right here is 0 comma 0. So let me arrow to that and say that's 0 comma 0. And then this point right here, this is going to be that pi over 4 comma negative 2. So pi over 4 comma negative 2. Let me erase these as I use them. And then this point right here, this is your pi over 2 comma negative 4. So pi over 2 comma negative 4. Let me get rid of that. And then this right here is the 3 pi over 4 comma negative 2. So this is 3 pi over 4 comma negative 2. So thinking about the beginning, the middle, and the end. So at negative pi over 4 for the x value, for pi over 4 for the x value, and then for 3 pi over 4 for the x value, again, you're going to get an undefined value for cosecant. If you plug in negative pi over 4 and you go through the steps there, you're going to end up with the cosecant of 0. And the cosecant of 0 is undefined. If you plug in pi over 4, you're going to end up with a cosecant of pi that's undefined. If you plug in 3 pi over 4, you're going to end up with a cosecant of 2 pi, which is undefined. So on and so forth. So you'd have a vertical asymptote there at negative pi over 4, and then you'd have one at pi over 4, and then you'd have one at 3 pi over 4. Let me highlight this because it's really hard to see. So let me do this one right here, and let me do this one right here, and then let me do this one right here. Really hard to see that one. Okay, so thinking about, you have a shared point here at 0 comma 0, and you have a shared point here at pi over 2 comma negative 4. So again, I know that since this is a hill, this will be a valley. And then since this is a valley, this would be a hill. This is going to be really hard to do, so I'm going to try my best, but I'm going to go over. This would just approach the vertical asymptote, but not touch it. And same thing for this part right here. I'll do my best. And then this right here, this one's going to go down. So approach, but not touch. And approach and not touch. And I know I went over the line in a few places, but just pretend like I didn't. Again, you have that link on Desmos. If this is really hard for you to see, you could just click on that and go into more detail. All right, let's take a look at problem 9. So here we have f of x equals 3 cosecant of x over 2 minus pi over 3 minus 2. Let me go ahead and factor this again. So f of x is equal to, we have 3 cosecant of, let me pull out the 1/2. And then inside you're going to have x minus, how do I undo multiplication by 1/2? I would multiply by 2. So 2 times pi over 3 would be 2 pi over 3. Let's close everything down, and then you have minus 2. Okay, so looking at it, if we want the period, and maybe this e could be better here. Well, we want to go 2 pi divided by 1/2, so that's 4 pi. If we want the phase shift, we're going to come inside here, and we're going to think about, how do I undo what's being done to x? We have x minus 2 pi over 3, so I want to add 2 pi over 3 to undo that. So that means I'm going to the right 2 pi over 3. And then lastly, you have your vertical shift, and you're thinking about this minus 2 right here. That's just going to put me down by 2. All right, let me copy this real quick. Again, I want to try to make it smaller. So f of x is equal to 3. I'm going to replace cosecant with sine. And then you can keep it in factored form, again, if you want to use graphing transformations. So 1/2 times the quantity x minus 2 pi over 3. Close all that down, then minus 2. And paste this in here. Again, I'm just going to start with y equals the sine of x. You have your 0 comma 0. You have your pi over 2 comma 1. You have the pi comma 0. Maybe this could be a lot better here. Let me just do that again. And then you have 3 pi over 2 comma negative 1. Let me slide down just a little bit so this fits. And then you have 2 pi comma 0. Again, an x-intercept at the beginning, middle, and end. So just remember that. If we're using the quarter period method, again, you could use graphing transformations, but it's going to be slower here. The period is 4 pi. So the quarter period is pi. So the quarter period is going to be pi. Well, first you start off with a phase shift. And again, we're going to the right 2 pi over 3. So this is 2 pi over 3. And then now you're just going to add quarter periods. That's all you need to do. So 2 pi over 3 plus, you could write this as 3 pi over 3. And that's 5 pi over 3. Then you add 3 pi over 3 again. You're going to get 8 pi over 3. And actually, let me just make this a little bit smaller. So 8 pi over 3. And then I'm going to add 3 pi over 3 again. So that's going to be 11 pi over 3. Add 3 pi over 3 again, you're going to get 14 pi over 3. Okay, so for the y values here, again, very straightforward. I know that if I plugged in 2 pi over 3, that this guy right here would turn into 0. If I plugged in 5 pi over 3, this guy right here would turn into 1, so on and so forth. So the shortcut here is just to say that I'm going to multiply by 3 first, then subtract away 2. So I'm getting a vertical stretch by a factor of 3, and then I'm shifting down by 2. So I'm just going to go 3 times 0 minus 2. Here I'm going to go 3 times 1 minus 2. And you could skip this one. This would be 3 times negative 1 minus 2. So this would be 3 times 0 is 0. 0 minus 2 is negative 2. So this is negative 2. 3 times 1 is 3. Minus 2 is going to be 1. And then this one you can copy from here. And then you can put that here. 3 times negative 1 is negative 3. Then minus 2 is negative 5. Okay, so we have this. Let me grab it. Come down here and paste this in. And again, I'll just go through these with you real quick. So if we look at what we have, you have the 2 pi over 3 comma negative 2. Let me just highlight that real quick. And then you have your 5 pi over 3 comma 1. You have your 8 pi over 3 comma negative 2. You have your 11 pi over 3 comma negative 5. And then you have your 14 pi over 3 comma negative 2. So those are your points on the sine graph. Again, at the beginning, the middle, and the end, that's where if you plug those guys in terms of the x values, you're going to get undefined. If you plug in 2 pi over 3, you're going to end up with the cosecant of 0, which is undefined. If you plug in 8 pi over 3, you're going to end up with the cosecant of pi, which is undefined. If you plug in 14 pi over 3, you're going to end up with the cosecant of 2 pi, which is undefined. So you're going to get vertical asymptotes here and here and here. So then all you need to focus on is that at a quarter of the way through and 3/4 of the way through, you're going to have a shared point. So 5 pi over 3 comma 1, and then 11 pi over 3 comma negative 5. So now we know that this right here is a hill, so it becomes a valley, and this right here is a valley, so it becomes a hill. So all I have to do is sketch this going this way, approaching the vertical asymptote but not touching it. Same thing for this right here, and then same thing for this guy going this way, and then this way. So that's all it is. All right, let's take a look at problem 10. So here we have f of x equals 3 cosecant of 2x plus pi over 6, then minus 1. All right, once again, I'm just going to factor. So f of x is equal to 3 cosecant. Pull out the 2. Inside, you're going to have x plus, how do I undo multiplication by 2? I can multiply by half. So pi over 6 times a half, that would be pi over 12. Close everything down, and then you have minus 1. So for the period, you have 2 pi divided by, in this case, 2. So 2 pi over 2, that's going to be pi. Then for the phase shift, you go inside and you say, how do I undo what's being done to x? Here you have x plus pi over 12. To undo that, I need to subtract away pi over 12. So that means I'm going left, pi over 12. Then for the vertical shift, you have that minus 1. So that is going to tell me that I want to go down 1. That's all it is. I keep rewriting it, trying to make it smaller, but I never do. So I'll just go with what I have, and I'll just replace this with sine. And again, one more time, we'll just write y equals the sine of x. Hopefully you know these points at this time. So we have 0, 0, we have pi over 2, and then we're going to have comma 1. We have pi, comma 0. We have 3 pi over 2, comma negative 1. And then we have 2 pi, comma 0. X-intercept, x-intercept, x-intercept. So just remember that. So looking at this guy, again, if you want to do the quarter period method, the period we know is pi. So the quarter period, that is going to be pi over 4. So let me go ahead and say that first you do the phase shift. So we're going to have minus pi over 12. And then from that point, you're going to keep adding quarter periods. You can go ahead and just multiply this by 3 over 3. So this would give me 3 pi over 12. So negative pi over 12 plus 3 pi over 12. That would be 2 pi over 12. I know you can simplify that, but just hold off for a second. 2 pi over 12 plus 3 pi over 12, that's 5 pi over 12. That 5 could be a lot better. And then 5 pi over 12 plus 3 pi over 12, that's 8 pi over 12. Of course, you can simplify that, but we'll do it in a second. 8 pi over 12 plus 3 pi over 12, that is 11 pi over 12. So 2 pi over 12 is pi over 6. So pi over 6. 8 pi over 12. 8 divided by 4 is 2. So that's 2 pi over 12 divided by 4 is 3. So 2 pi over 3. Okay, so we've got everything for x. Again, you can do the quarter period method, or you can go through and do your graphing transformations, whatever you want to do. For y, again, it's very straightforward. You can always plug in, but again, we know that if I plugged in negative pi over 12, negative pi over 12 plus pi over 12, that's 0. 2 times 0 is 0. So you end up with the sine of 0. So the sine of this right here, which gives you this right here, you get 0. If you plugged in pi over 6, you'd end up with the sine of pi over 2, which is 1. So you'd have this right here. So all you're really doing is you're multiplying whatever the y-coordinate is by 3 first, then subtracting away 1. So you have a vertical stretch by a factor of 3, and then you're shifting down by 1. So I'm going to do 0 times 3, and then minus 1. I'm going to do 1 times 3, and then minus 1. I'm going to do, this is a repeat, so this one down here is what I'm going to do. So it's negative 1 times 3, and then minus 1. So 0 times anything is 0, then minus 1 is negative 1. So you have that there, and then there, and then there. And then 1 times 3 is 3. 3 minus 1 is 2, so that's there. Negative 1 times 3 is negative 3. Minus 1 would be negative 4. So pasting this in, again, this is another graph that's going to be really hard to read. So you can just click that link on Desmos if it's a little bit challenging for you. And so this point right here is negative pi over 12 comma negative 1. Let me arrow to this and say this is negative pi over 12 comma negative 1. Maybe that helps you if you don't have access to Desmos. So this right here is pi over 6 comma 2. So pi over 6 comma 2. Then this point right here, this is 5 pi over 12 comma negative 1. So 5 pi over 12 comma negative 1. Then this point down here, this is 2 pi over 3 comma negative 4. And then this point right here, this is 11 pi over 12 comma negative 1. Okay, we can get rid of this. So thinking about the asymptotes at the beginning, the middle, and the end. So the x value is there. So here, this would be your x value of negative pi over 12. Then at the middle, you can have an x value of 5 pi over 12. So that's that guy right there. And then at the end, you're going to have 11 pi over 12. So this guy right here. So that's the end of the cycle. So again, if you plugged in negative pi over 12 for x there, so you went through this, you'd end up with the cosecant of 0, which is undefined. If you plugged in 5 pi over 12 for x there, you'd end up with the cosecant of pi, which is undefined. If you plugged in 11 pi over 12 for x there, you'd end up with the cosecant of 2 pi, which is undefined. So that's why you're getting vertical asymptotes at the beginning, middle, and end. One more time, if you wanted to, and a lot of teachers do this, you could use the negative 1 there, that shift down, and you could say, well, anywhere where the y value is negative 1, you're going to get your x value that's undefined there. So you could draw the horizontal line y equals negative 1 if you want. That would be your new midline. You could do it that way as well. Okay, so we know that we're going to share a point at a quarter of the way through. So that's going to be right here. That's at pi over 6 comma 2. And then 3/4 of the way, so that's this right here. That's at 2 pi over 3 comma negative 4. And again, with the sine graph, this guy is going to be a hill. So this would be a valley. And then this right here is a valley. So this would be a hill. So let me draw this to where, and this one's really hard to do. It approaches the vertical asymptote, but doesn't touch it. And this one's going to approach the vertical asymptote, but not touch it. Same thing for this going down here. So approach, but not touch.